Okay, good morning, everyone, and welcome to the ENFIELD Final Conference. We are super happy to have you all here, and we hope that you will enjoy the insightful presentation, engaging discussion, and valuable networking opportunities today. To begin with, I would like to invite my colleague, George Spatoulos, the technical coordinator of the ENFIELD project, to deliver the opening remarks. Thank you, George.
Good morning and welcome to the final ENFIELD conference. My name is George Spatoulas and I'm an associate professor with the Department of Information Security and Communication Technology in NTNU in Norway. I have the honor to serve as the technical coordinator of the ENFIELD project, and I'm very excited to welcome you all here today to the final ENFIELD conference, which is the most important event of our project. ENFIELD is a European AI network of excellence. It's a rather ambitious project with a mission to promote research excellence in AI, to propose novel applications of AI technology in different domains, to define a common research vision and roadmap for AI in Europe, to contribute to AI talent development, and to participate in all ongoing AI-related policymaking activities. And while we have been very active and successful along all these dimensions, our main goal remains to establish, maintain, expand, and sustain a network of stakeholders interested in AI research and AI applications. The success of the ENFIELD project will be mainly decided by whether we're able to extend our network after the end of life of our project. Today's event typically marks the end of a cycle, but for all of us within the ENFIELD consortium, it indicates the start of a new cycle that will last longer and will have a greater impact than the project itself. Today, with all of you here, we envision to kickstart what we define as the sustained ENFIELD network that will last beyond the end of the funding for the project and will allow us to multiply the effect of the results we have already achieved. On that basis, your presence here today is very important for us, and I would like to thank you for that. I would like to thank all colleagues that participate in the final ENFIELD conference, either physically or remotely. I would like to especially thank our speakers that have kindly agreed to join us in this initiative. And of course, I have to thank all ENFIELD colleagues that have been working very hard in recent months to design and organize the final ENFIELD conference. Closing, I'd like to wish you all to have a very interesting event that will enable you to think, discuss, and interact about challenges, but also opportunities for AI in Europe. And that at the end of the event, tomorrow evening, we will all leave the venue a bit more aware about what the future of AI in Europe holds for us. Thank you.
Dear colleagues, on behalf of the organizing committee, as co-chair of this conference, I'd like to introduce Rod Evans, Vice President of Supercomputing and AI Cloud Infrastructure for Europe, the Middle East, and Africa from NVIDIA, and to ask him to present his ideas and thoughts about green and sustainable AI, especially in data centers. So, Rod, the floor is yours.
Thank you, sir. So it's a great pleasure to be here today. As you say, I look after a lot of remit for NVIDIA. I look after higher education, supercomputing, and I look after our entire AI cloud infrastructure. Now, one of the aspects of that I've been really closely involved with is data centers, because data center is becoming one of the key barriers to the success of AI. But one of the things I'd like to open up with is to give you a clear message at the start, if it'll work, that AI at the moment is driving the biggest infrastructure rollout in human history. Now, people say, it can't be as much as it was with the railways and everything else. It's way beyond that. The amount of building that's going on, the amount of momentum that's going on, this is the biggest build out in history of anything of the history of mankind. And anybody who thinks and talks about AI bubbles clearly doesn't understand what's going on. And I'll put that in context for you. In the last 2 fiscal quarters, NVIDIA has done the biggest 2 corporate revenue numbers in history. We did it in Q4 for our results that finished in February, and we just announced them again for our Q1 results, even bigger, 20% rise on the previous quarter. And not just that, all of our partners and people we're working with have just had their biggest results in human history as well. Hewlett-Packard, Dell, Supermicro, all of the people who build servers and stuff around that are all having their biggest ever revenue numbers they've ever had in history. We're in a new era of corporate results. So it's really changing, and this big rollout is really one of the fundamental things that people don't actually realize is going on. And I'm going to talk a lot about this when I look at data centers and what's happening. Now, what we're actually seeing is this huge increase in demand for AI computing. We've seen model size growing at about 10x parameters per year. The test time to scaling, or the thinking, the number of tokens that comes out of it, 5x per year over the last few years, and the token cost being 10% cheaper per year. Now, we've also seen, to give you some context, in the past decade, we've seen a 1,000,000x improvement in complexity, in scalability, and performance over the start of the decade. Now, to put that in context, if you look back at the days when there were CPUs only doing traditional computing, the most you ever saw in a decade was 100x improvement. So we've gone from 100x improvement to a 1,000,000x improvement over a 10-year period. So it's a huge transformation on everything that's going on out to the marketplace. And what we've seen is a number of different things along the journey. In real terms, the first large language model landed only in 2012 with AlexNet. Then we went through a few areas: perception AI, speech recognition, and medical imaging, and things like that, and how we can use AI to do things in a better way. Through generative AI, really about content creation, digital marketing. Through most recently now agentic AI, coding assistance, customer service, patient care activities. And the next area that's coming along with this now is physical AI. Humanoid robots are almost with us. In fact, this year we would expect you to see them in production in some marketplaces. Now, there was a very interesting article published by a UK newspaper called the Daily Telegraph. Now, anybody's familiar with the UK press, you'll be familiar. There's 2 types of press in the UK. You have the sort of big broadsheet newspapers or serious newspapers, and you have the sort of smaller ones that deal to the consumer. This is Daily Telegraph, which is not a main serious broadsheet newspaper. And the headline that was in the business section said, "Western executives go to China and come back terrified," which is not a headline you normally see in these sort of newspapers. And when you read the article, it opened up with a discussion from the chief executive of Ford. And he said, "I've just been to China for 2 weeks." He said, "I visited all these car manufacturing plants. We're Ford. We invented mass production. What I'm seeing in China is higher productivity, better quality, faster time to production, lower cost than we can do it in the West. And if we don't change, Ford won't exist." And it's a really damning statement. And when you read through all of this, one of the things they recognized in China early on is, despite the fact China has a huge population, it has a very aging workforce, and it cannot get new workers to fill the factories and things it's got going. So it's moved towards robotics. So a large number of these factories are now almost completely robotically run. Now, this started around 10 years ago when China went out and got most of the most advanced Western robots from all over the world, and they bought one of each. And then what they did is they re-engineered them, rebuilt them, and came up with something now that is probably a decade ahead of anything we have in the West. A decade ahead. Let's let that sink in for those of us in Europe. It's a huge risk to our future prosperity and of our families and everything else moving forward, that we are a decade behind where China is in terms of robotics and its advancement in this area. So 20 years ago, all this was science fiction. 10 years, it was a dream. Today, we're living it. And we've really gone away from this threshold of generating ads to performing work. And the next sort of big statement from Jensen Huang, my chief executive at the World Economic Forum in Davos. And I'll give you an example of this. I went to see an event recently, and there was a startup there and 4 people who'd come out of a university. They set up a new company, and they'd written an application in 4 weeks. How do you write an application in 4 weeks? Oh, it's very simple. We built an agentic AI system. We went out and looked in the marketplace. We set the parameters to go and find all the information. We got the information back. We ran it through Perplexity, which is one AI model. We ran it through Claude, generated an application. So we got the benefit of 1,000x developers in 4 weeks in terms of producing code. Now, I spent a large part of my life dealing with HPC people who are still writing codes and still running code 30 years old. I don't see too many new HPC codes coming out. If I look back at the RFPs I saw 10 years ago and the RFPs today, the codes are the same. So while some of the academic world is sat there looking with ancient old HPC codes, people are writing new codes in 4 weeks in the AR world. And we need to wake up and start to recognize the change and transformation that can be found by embracing the new technology and not be afraid of the future. So let's look at about what I call it European autonomous AI. I hate the word sovereign AI. Sovereign AI to me has very negative connotations in a world where we're used to sharing information and sharing things. This idea we suddenly want to be is all ours and nobody else's, I think is a terrible momentum for the world today. So I like to talk about autonomous AI rather than the word sovereign, even though the meanings are necessarily the same. And what we've seen is a huge drive in interest in European autonomous AI. You'll see myself, my chief exec, and others meeting various people around Europe. And when Jensen Huang meets chief executives and he meets politicians, he hates meeting politicians, by the way. It's just a necessary evil of the business we're in. When you meet politicians, he said one thing to them. He said, you've got two choices. As a country, you can be an AI taker or you can be an AI maker. And as a country, you need to decide what are you, because you won't have a choice but to take the technology. It'll happen around you anyway. And so the real winners are going to be the people who embrace making the technology, making it in what you want it to be for your country or your continent, and make it achieve the objectives you want to do within the legal framework you want to put around it. So you might have constraints and guardrails and frameworks around it that are different to other countries. That's perfectly okay. But you need to be in control of your own destiny and become a maker rather than a taker. And not surprisingly, I've never seen a prime minister yet, and I've met several of them, or a deputy prime minister says they want to be a taker. Everybody wants to be a maker. So we'll see how that momentums. But there's been a huge change here. Now, when they look at this, why are people interested in trying to do something as a government in terms of why would I be interested in AI? And there's several reasons for that. Most of our economies today are in the mode where we are not having a lot of growth. I read a very article this morning online that said in Germany right now, the growth rate for this year is expected to be about 0.8% growth in GDP, while inflation is growing at 3%. It's not a great place to be. Now, all of the governments around here are looking to say, how can I do a new engine for economic growth? Getting startups involved, getting new jobs and sectors, retaining my talent, making sure my workforce is skilled. I want to do some things with scientific discovery. How do I get improved things for fundamental research, industrial innovation? And one of the other things is all of them are struggling with having to do a platform for public sector innovation. Anything that is necessarily government related is a paper factory. If anybody's ever done a planning application, I don't care which country you're in, you try and do a planning application and you see how much paperwork you have to do just to get a simple thing analyzed. And people are starting to wake up to this. I was with the Minister for Digital Transformation in Portugal, Gonçalo Mateus, and he's very clear, I'm going to change all of this. So the average time to get something approved in Portugal is about 10 to 12 months. I want it down to 3 weeks so we can kickstart and get our economy moving and not have to be stuck with this paperwork factory that is public sector. So they need to change that. And we're starting to see this concept of data, creating this concept of an AI factory, and then generating intelligence. Now, one of the other things that's really interesting, I did an event last year for Digital Europe in November, and we talked about one of the issues we have with productivity of people. And it's becoming a big issue. UK, for example, there's 1 million people between the age of 16 and 24 who are not doing anything gainfully economic. They're not in education, not in training, not in employment. And that's particular pattern we've seen over Europe at various times. Spain had this problem a decade ago, and it managed to change its economy in a different direction. Netherlands is doing very well in getting people back into doing traditional trades, because not everybody can go to university and be an academic. Some people need to go and do things in a different area. So we are going to have to reinvent our economies. And one of the challenges that came out of the Digital Europe event is, as advanced economies, we spend 4.6% of our GDP on education from kindergarten through to university. And then we spend 0.8% of our GDP on educating people after they've left university. So around the rest of their life cycle might be 40, 50 years of work, 40 years of work certainly. We spend 0.8 of our GDP retraining people. That needs to fundamentally change. If it doesn't fundamentally change, we're not going to be able to keep up with the rest of the world and sustain our economies and sustain our welfare and sustain our standard of living and all the things we want to do. And there's a lot of things that need to happen there to actually change and make sure that we're constantly training and developing people as we go, because things are moving so fast. And we're creating this new industrial revolution. If you take the AI factory producing these tokens of intelligence, you're developing a new 100 trillion market with robotics and also things around that, and a 10x growth in European infrastructure over the next 2 years. It's actually going to be beyond 10x this year compared to what it was the previous year. Now, one of the things that's also changed in this is the unit of compute has changed. Previously, we would talk about a server being a unit of compute. It's now moved beyond the server to a rack level deployment, and it's moving very much to entire sort of factory level deployments of technology. And using different ways, we're going to have to look at data centers and how do we make this sustainable so we don't actually destroy the planet and make sure you don't use all the electricity and everything out there just to generate these new things. So let's look at what AI is doing to drive data center growth, because this is very, very significant. So AI factories are the new infrastructure of the era. And the number one thing these kind of people are trying to do is to get to the first token production as fast and efficiency as possible. Now, why is this? If you are going to go and build out a 20 megawatt data center and fill it full of AI compute, that's an investment of about 1.8 billion euros. And that's not a very big system at 20 megawatts. We're seeing people build out 200 megawatt and gigawatt factories. But it's 1.8 billion euros. Now, if you're going to invest 1.8 billion euros, you better get it come into production to get your return on that investment as quick as you can. So this time to first token has become the new metric that a lot of these organizations are talking about. And when I talk to my cloud partners, the one thing they're always looking at is when I get the system in, when is the time that the first token could be generated that uses anything? And one of the signs we're starting to see as well is we're starting to see the traditional problems about permitting delays and power availability limiting data center delivery. I'm going to change and grab the mic here so I can walk around. Not that one. This one. I like to walk around. Now, this chart is showing construction of data centers in the United States from 2018 through to 2032. Now, if you look at 2026, which is where we are today, you've got this lovely, great plan of 16.2 gigawatts of data center construction that's supposed to be finished in 2026 and roughly 31.2 in 2027. Now, you add all that together, I've got 48 gigawatts of data center construction that's supposed to be happening. And what's actually going to be rolled out and finished is about 12 gigawatts. So about a quarter of what is expected is actually going to be delivered. Now, what this means now is you've got your 25% constructed is everybody from the US is looking for where can I actually get compute somewhere else that can actually fill the gap, which is why you're starting to see this momentum where people are starting to talk and look about building data centers in Europe and what it's going to do for the European economy because they can't get it done quick enough in the US. Now, I find that quite surprising because I always think the US operating faster than Europe with the permitting issues we have here. But the reality is a lot of governments are starting to make things happen quicker. In Italy, for example, if you are going down in the very south of Italy, in Puglia and places like that, you can get approval in about 2 months, what in the rest of Italy would take you 12 months plus to get an approval done because it's an underdeveloped area that the country wants to develop out. And data centers are seen a way to get that into the new world. But once this data center is built and operational, as I said, the number one thing is to maximize the amount of AIs per token per watt of available energy. Now, this is showing you a gigawatt of grid power at the top. And then by the time I actually get down to it, I've only get about 60% of it for actually using output. So I lose about 40% of the power. I get things stranded. I have conversions that go on from AC to DC. And you get all these inefficiencies along the way that are over-provisioned. It means I only actually get about 60 to 70% of what I expect to get out of the power I've got. And it's worse than that. If I'm using grid power and you say you contract with a power company to get 100 megawatts of power, guess what? You never get 100 megawatts of power. You actually get about 93% of that power at best. Now, why is that? Because grids are over-provisioned, but grids are over-provisioned for a reason. You need to keep hospitals up and running 24/7. You need to keep traffic lights running the whole time. So grids by necessity are over-provisioned. So even if you think you're getting a large chunk of power, you actually lose about 7% before you even start, because the power company cannot guarantee you that you're ever going to get the money you're contracted for. So you have to make sure you're as efficient as possible in terms of making sure this efficiencies are getting better. And we're looking at how we do this. So this rack power efficiency and other things, and I'll talk a little bit about that in a minute, on the changes we're making that are going to transform the industry in terms of data center development. Now, we had an event in NVIDIA every year. We have the GPU Technical Conference in California in March, and I was there with Jensen Huang, and we had the chief executives of all of the biggest hyperscalers and AI cloud companies in the room. And Jensen said to them, why is it if I want to go and build an apartment block in Paris or London or New York or Rome or whatever I want, nobody asks me how many apartments have I sold before they lend me the money to build the apartment block? So why is when I'm building a data center, everybody wants me to have sold 70% of the capacity before they'll give me the money? That makes no sense, because data centers are constrained. We've seen that things are not getting built, but the way the financial world is working, until it sees a 70% demand, it won't give you the money to go and build a data center. So it can be, that's part of the reason why we're having this issue and challenge in terms of supply and capability, and how we need to maximize the efficiency of what we've got. Now, we're starting to see some trends around this impact in sustainability. We've got AI now happening everywhere, in clouds, in data centers, at the edge. We've got a lot of increasing model size and complexity in different systems, and we've got a lot of computational requirements around it, and companies consuming ever more power. But we're trying to make this as efficiently as we possibly can by lowering energy consumption over traditional methods of doing things with CPUs or other areas, and trying to make model efficiency as efficient as possible. And with that, we've seen this concept of these things called AI gigafactories, which are really designed to be purpose-built to train over 100,000 processors, doing a lot of innovation in this sort of infrastructure that we need, this autonomous infrastructure, a lot of parallel efficiency and all the rest of it, and rapid deployment and scalable architectures, so I can move things together really quickly. And people are looking at using modular designs to get things done quicker, because it's quicker than building a traditional land power shell. The actual shell you put the data center in is actually much quicker in many cases to use containerized modules. And the picture on the bottom there shows a containerized module farm under construction in Saudi Arabia, which is showing you the example of how you can build this really quickly. And it's happening everywhere. I was happily involved with the Jülich Jupiter system, Europe's first exascale system, and that's completely installed in modular containerized data centers. They're all linked out the back of their location because they couldn't get it built quickly enough or within budget to do it with traditional methods. So containerized DCs and more modular ways of deploying things are becoming the norm as we move forward. Now, let's take a look at this. This is Stargate in Texas. It's a 200 megawatt site, scaling to 1.2 gigawatt site. And if you look at it from the air, it's super ugly, and it looks like a manufacturing site to me. Looks like I'm building a set of factories, not a set of data centers. Now, it doesn't have to be like this. There are better ways to do this, and I'm going to show you some examples in a minute of how actually we can use a more sustainable method to build up data centers for the future and make it more beneficial for the people around them and the economy around them, rather than just being this big center employing about 5 people, because that's what the data centers typically are doing. Now, what we've seen is the US cloud and hyperscale data centers have been leading the way to green energy. Microsoft has been 100% renewable for more than 14 years now, with a very high efficiency on its data center. Amazon's been 90% renewable since 2022, Google since 2016. And the rationale behind this is the ability to do rapid growth, resilience, and more importantly, minimize the cost of energy and obviously maximize the return on their investment that they're putting out there. Now, in order to continue this, you have to look at strategies to make data centers sustainable. And the first thing, obviously, is how can I consume? Oop, did something there. Don't know what I've done. Okay. Right, sorry, we did the wrong thing there. Helps you know. You should never let me press buttons. I'm not an expert, but there you go. Go back one. So how to make strategies data centers sustainable? Number one is consume less. Reduce the number of resources, energy, water, and waste by optimizing existing processes, developing different design practices, engage suppliers in decarbonization things, purchase lower carbon materials, and so on around this. I've heard people talk now about this concept of blue energy alongside green energy. I met with Eni, the oil company in Italy, and they've got a plant that is running a gas-powered generator. Oh, gas, not great, but it's completely decarbonized. When you completely decarbonize it, it becomes this new concept of blue energy, because I'm decarbonizing the fossil fuel design and actually getting a decarbonized product at the end of it. So you'll hear this concept of people talking about blue energy alongside green energy and green methods of doing things to actually sustain into the future. Second area is to look about do better. So how can I make things in terms of just by switching to different things like renewable energy, cleaner fuels, to actually recycle waste for waste and heat, and we'll come back to that. Obviously, the ability to then procure renewable energy from non-IT power, invest in agreements and everything else. And then the final thing is to do things differently. How can I design data centers in a different way? How can I design my power distribution in a different way? How can I make sure I can make best use of all the things around it? Now, this is an example of a data center built, which I love.
Now, this is from a Norwegian company called Fossifal, and it is bidding for a site in Sweden, which is a 650 megawatt data center proposal. And it's using many things to make this more sustainable and more environmentally friendly than the idea of the one from Stargate in Texas, which is a big sort of concrete monstrosity. Here you've got buildings that are made of wood. You've got a district heating plant integration. And as part of it, one of the things they had to do in their bid is to the business park there is come up with a plan of what else are you going to do for the local economy. Apart from just building a data center, what else are you going to do for us? So in this bid, Fossifal is going to build a complete new university campus for Mid-Sweden University, building an AI campus on site, as well as an incubation hub for startups and things around that. They build a whole science park alongside the data center as part of the proposal. So providing more employment to the population, providing more sustainable method and everything else.
And so this is an example again from this site. This is the campus designed with natural integration, ensuring phase development in Swedish timber. They're using controllable expansion. So timber architecture, which means they've got a regional value chain from the area. It's using liquid cooling. It's got a noise reducing design from day one, reusable heat, with the intention here to create a large-scale infrastructure with low visual impact, with a lot of local stakeholder and construction strategy. Now, if you do it correct, you've got a really good idea here. I went to another data center site in Norway that's probably not doing it correct. It's by a US site that's in Norway, and in that particular site, it's in a town of 1,262 people. There's a 649 megawatt data center site being built that's going to be built over the next 6 years. Well, what's the first thing they got to do? First thing they have to do is they have to build a hotel for the 1,200 migrant workers that are going to come into that area and build the data center. Now, when you're in a town of 1,262 people, as you can imagine, there's not a lot of facilities. There are no hotels. There are 2 restaurants in the town nearby there, only 2. And you're going to double the population for 5 years, people coming in. That's not necessarily being done the correct way. And because of where it is in Norway, there aren't really the access to the people that can do a lot of the skills either. There aren't construction people there. There aren't plumbers there. There aren't electricians there. There aren't people who know how to do this. So you have to bring all these people in. So the end result, better make sure you get something sustainable for your community on the back end of it. And Fossifal, with this model that they're building in Sweden, is certainly doing that with deep involvement with the local authority and the municipality to make sure they're building something sustainable for the future. And as we said, data centers can produce huge amounts of heat. Now, we're now at a mode where we're moving our cooling methodology, so we're now going to liquid cooling. Academic data centers and supercomputing sites have been doing liquid cooling for a long time, but the commercial world hasn't. But when you use liquid cooling, we're now using liquid cooling at 45 Celsius. Now, when you use 45 Celsius, I can build a data center anywhere. I can build in the middle of the Sahara Desert if I want. You're hearing people talk about building data centers in space and all sorts of fanciful ideas like that, which are great marketing. I'm not sure it's real, but it's great marketing messages around it. But you could certainly build data centers into deserts. Today, the biggest data center hotspot in Europe is Spain. Spain had over 3 gigawatts of new data centers under planning and construction, already being built in some of the areas of Spain. And one of the things with 45-degree water, you get 45-degree water in, you get 65-degree water out. Now, when I get 65-degree water out, I can do something with 65-degree water. I can actually use it with heat exchangers. I can add it into other areas. So up in the Nordics, for example, a few examples, obviously district heating is quite well established in many Nordic countries, and it's a great idea to provide your heating for your local people. You can use industrial process heat for doing things like drying. Now, a lot of these areas up in the Nordics, they're in forested areas. Now, when you move in forest products, and you cut down trees and move it, and you move it to wherever you're going to process it, you're moving, half of what you're moving is water. These trees retain an awful amount of water in them. So if I can just process them on site using waste heat from the data center, I can produce biomass and pellets on site without having to transport all that water across the country, which is not necessarily a great use for our environment or for resources to move water around the country that's inside a tree. It might be better to do it on site. Another area is things like fish farms. Fish farms for salmon. I had no idea about this, because I always think of salmon spawning and going into the ocean and the rest of it. But apparently when they're very small, they need warm water. They can't go into the fjords and places like that because it's too cold. So they build them, and they do fish farms. They build them in tanks with warm water. But if I've got waste heat coming from a data center, I can reuse that water. I can reuse the heat to heat the water up, spawn the salmon, and then I can release them out into the fjord afterwards. But I'm actually making fish farms and aquaculture go there, as well as biogas and hydrogen and new industrial establishments. I think the key message here is there's more you can do with the data center side than just building a data center. If you think about it carefully, you can get a lot of benefits. And I'm starting to see a lot of municipal governments across Europe asking now increasingly, what are you actually going to do in addition to the data center for the local economy? What are you going to do around this so it becomes sustainable? Now, in 2025, we had a big change. As I said, big inflection point. Liquid cooling became an AI foundation. And at the end of 2025, we reached a $3 billion marketplace globally with 117% year-on-year growth over the previous year. And it's projected to grow at about 24.5% growth for the next sort of 4 years. We're currently using single-phase direct liquid cooling, 90% of online capacity. Two-phase direct cooling is coming in there, but it's not there today. And increasingly now we're starting to see people do hybrid environments. So old data center buildings that were designed around air cooling, you can readapt those to do liquid cooling with sidecars and other technology around it. So I can reuse old buildings. I don't have to throw away the investment I've made in the past in a data center that doesn't have liquid in it. So those hybrid environments are coming through. Immersion cooling's been a topic that people have been looking at for more than a decade. It hasn't really made much of a breakthrough for several reasons, but serviceability challenges are really the number one problem. When you're using oil-based technology, as you do in most immersion coolings, the problem with it is you get ingress of that oil into cables and electronics, and actually causes problems with reliability. So it's not yet been a great technology. It could end up in the future, but today it's still a niche technology. So the market's no longer debating liquid cooling is necessary. It's like, how quickly can I scale it? Our next generation product we start to ship in November this year is going to be 250 kilowatts a rack, 100% liquid cooled. Switches, power supplies, chips, memory, everything is liquid cooled in the rack. 250 kilowatts. And in 2028, we're going to be up to 650 kilowatts a rack. A single rack of equipment, 650 kilowatts. Now, that requires you to do something different, because I can't use AC into the rack at 650 kilowatts. I have to use direct current. So the industry is moving towards 800 volt DC. Now, 800 volt to DC has many advantages, because it's straight DC into the rack, and then you rectify it down to negative 54 volts to go to the actual compute trays, and then inside the compute tray, it goes down to 12 volt for the CPU's memory, everything else that's required inside it. Now, the advantage of this is this technology of using this type of direct current has been in the telco marketplace for the last 50 years plus. Now, increasingly, that means I can do this and reuse technologies that are out there, but it also means if I'm doing more direct current into the racks, I don't necessarily need big diesel-powered UPSs and other things out there. I can reduce that by 50, 60%, which reduces, again, the output of fossil fuels and other things in the atmosphere and things that come out of that by reducing the amount of UPS capability that I need because I'm using DC in the first place. And here's a change. You can see the forecast there from 25 at 3 billion to 7.2 billion by 2029. And interestingly, you're starting to see enterprise and others, hyperscalers and co-locations, traditionally air-cooled data centers, moving increasingly to adopt liquid. This came from a very good forecast document that came out in December 25, but gives a really good picture of what's going on in the marketplace right now. So how do we do this in a better way? And we've come up with this model for the industry called the DSX framework. Because one of the things that I said from Jensen when he said, why is it when I build a data center, I need to sold 70% capacity? Well, one of the other problems with this is everybody who builds data centers a different way. There's no standard for data center builds. Now that means it gets, there are all sorts of different components and things you use, but it means it's very difficult for an investor to assess, well, what is good about this data center built by Digital Realty, or this data center built by Equinix, or this data center built by EdgeConneX, or a data center built by Hochtief in Germany. What is the benefit of one or the other? They all look different. They all do things in a different way. So we are leading and working with the industry to adopt a single framework for data center design with lots of intentions built into that to make it sustainable and better for the future. Now, when you start to plan a data center deployment, and several of you have probably done this even on your own facilities, you've got facility operations, network operations, all the things to go with it. But you have to get a well-planned deployment has got to bring in multiple constituencies of how I put this together. And if you've got solution to resort constraints in one of those domains, it may impact planning in another. So it's not a simple solution to go and build something slightly differently. And the economy of resources really all data centers have got finite resources. And there are two areas for this. Your main resource constraints are power, cooling, space, and connectivity. Now, I've seen people come to me and say, I'm going to go build a data center in Kosovo. I had people visiting a site there last week. I've got one in Northern Macedonia. I've got several being built in Romania, which is becoming a big hotspot for data centers. And the two things that really become important is what is your cost of electricity and how much electricity can I get to? And secondly, what is the latency on network connectivity? Because if you don't have cheap electricity and decent latency, you're never going to build a sustainable, successful data center in that location because it won't be economic. At 20 cents a kilowatt plus of a power cost is not sustainable. When I can go to the Nordics and get it for sub 8, I can get it 8 to 10 in Spain and Portugal. I can get it 8 to 10 in Romania. If I'm starting off at 20 plus, the data center is not probably a business I want to be in because it's just not viable. So you have to look on those areas that go with that. And building data centers, what we're trying to do is in a responsible and efficient manner so that every watt we get can generate tokens in the most efficient use of the power. We'd like to move towards zero external water. So you use closed loop cooling. You don't have to go out and get new water, bringing it in all the time for chillers and things like that. I don't need those because chillers are very bad for the environment, chilling air down to a certain temperature level. Using high temperature liquid cooling, 800 volt distribution, and looking at how do I optimize and load balance workloads. So trying to make a responsible design for both the community and the compute around the future. And we've come up with this model called DSX, which has got various things in it. We have a whole operating system for power optimization, infrastructure and platform software. We have reference designs of how to build. We have lots of libraries and frameworks, some of which I'll go through in a second. So simulating it, we have this thing called Max LPS. Max LPS, LPS stands for Land Power Shell, which is a standard word in the data center industry. How can I get the maximum use out of the facility I've got? And then the final thing is, how do I make it as flexible as possible? And we'll look at that. So when you look at this concept, you end up with this model.
So you end up with this concept over here of the AI factory. You have the software to run it. You have the max power shell capability to optimize the use of the power that you have, the exchange, and how do I interoperate everything. And then Flexes gives me API to go to either on-site power generation or into the grid. Now, grid availability is one of the biggest constrictors today. And as I said, even if you contract for 100 megawatts of power, you'll probably get 93 megawatts. So what people are increasingly looking at is, how can I put my own on-site generation alongside this? Now, in places like Spain, they're looking at solar power, for example. There's a lot of solar power farms being developed. And if you can use the solar farm to augment my grid connectivity, I can get things up quicker. And I can also make sure I get the power I need in the most sustainable way at the right price point. So there's a lot of changes there where you can mix between on-site power generation and grid penetration. Now, in some cases, the grid power companies are happy to give you more power overnight. but it wants you to use less in the day. So if I've got my own solar farm, I can use my own solar farm in the day when it's generating electricity, and I can use the grid connectivity in the evening to maximize the use and the most sustainable manner. Now, this alone, as I've said, this is a factory ecosystem slide from Jensen, which shows all the different things around that. At the top, you've got all the number of my cloud partners. You've got all the people who are doing software around this, design and construction. We're working with people like various people who build data centers, such as Siemens and others, energy and cooling. We're working with all of the major suppliers there, whether it be ABB or Hitachi or Schneider Electric from France or whoever it is around that, Vertiv. Infrastructure facilities, the people who go and build the data centers, and then also with the compute systems to make sure that people are building things to a standard design so I can take anybody's equipment, plug it all together, and it'll all work. It doesn't have to be different from HP or Dell or Supermicro or Foxconn or whoever else. All of the equipment is the same. Now, NVIDIA did a design called MGX. We gave it to the industry for free. We open sourced it and gave it to everybody to enable people to go and build things to a standard design point. And if you go to headquarters, you'll see a thing on the wall called the Wall of MGX. And it shows 9 different rack designs, different liquid cooling designs, different power designs, all built to the same spec. Slightly different variations from different manufacturer, but I can interconnect them all and build a system in the most efficient manner. We gave this to the industry for free, and people of other manufacturers have taken this as well. So Apple, for example, is building its own server infrastructure. Rather than do a different design, it took all our designs and started to build to the same design point. We welcome that. We want to make things as sustainable as possible for as many people as possible to have a sustainable future. So we start off then with the way we start off with these things. We start off with a reference design. So we have a reference design for 1 gigawatt of AI factory. So if you start from 1 gigawatt, you can start and scale it down to 10 megawatts if you want, but the design principle is the same. So we build up a scale around this. You know, if you're taking 1 gigawatt data center, you need around 144 acres of land, or about 150 hectares of land. Each of the data halls in this module for 1 gigawatt site is 6 megawatts. You have 5 nines availability plus power generators, direct-to-lit chip cooling at 45 degrees, with modular sequencing, very, very efficiency liquid cooling, and ops-driven uptime. And you can actually start in that 60 megawatts. You're starting in 9.6 megawatts deployment units to start your construction point. So you can start relatively small and scale up for the future. You don't have to start by saying, I'm going to build a gigawatt site. You can start at 9.6 megawatt site and build up. DSX Flex gives you power management capability. It gives you a grid-aware power orchestration layer that can connect you to your data center, as it said, to power grid services and online energy sources to improve reliability and economics. Make sure you don't have issue with peak demand problems. Make sure you can mix the intent of renewables and hybrid power and balance the I/O load with the grid capability you have available from it. And we've got a great example of this. We have a partner called Emerald AI. Emerald AI is a software company. They've worked on the capability of how to deploy data centers by unlocking power through power management, using distributed energy sources, flexing a period of grids, and faster, more deployment operations. And as you can see there, they've reduced the power demand by 30% in under a minute. They can bypass the grid by using bridge power when need to, and they can sustain 25% load containment in the heat dome areas when it gets too hot or I can't get my power grid off the area. So I can still maintain my production by managing the efficiency of my power that I'm using in the data centers. So, great example. Then I mentioned this thing called DSX Max Power Shell, which is really an efficiency layer that maximizes compute output per watt within a fixed power budget. So if I want a fixed limit, and I only want to operate within a certain amount of power, I can limit it so I run it at the most efficient way. Because if you're running your data center or your equipment at full performance, it's not necessarily the most power efficient way to operate. And if you operate it at 75% of peak performance, you can actually get much more efficiency per watt. In a lot of cases, the TED is time per token per watt, and how efficient I do that is the key metrics for the future. Again, FIDRA is a good example on here. They use the capability to stabilize the thermal and power things, giving 80% fewer temperature spikes, with a half a degree Celsius precision.
10% more available power to generate things from, and reducing the operational times down from weeks to minutes, giving a lot of reduction in the power usage effectiveness by raising water set points and things like that. So by using the technology around you, you can get much more efficient use out of your data center. So when you're looking at what am I actually got, what can I do with it, how can I get my science generated quicker, how can I get my tokens generated quicker, I've got a lot of parameters around this to optimize what I can within the power window I've got available. A DSX Sim, this is a simulation tool that enables you to simulate and design a data center. So I can look at designing it, simulate it before I build it and operate it to make sure I'm building it in the most efficient manner. And what you actually do is you build a digital twin. So this is showing a data center. We have a model called DSX Air, which is a logical simulation of how you design the infrastructure. We have a Omniverse DXX blueprint, which gives you a complete digital twin of your design. So here you can see chiller yards, stations, data halls. What is the airflow around it? What is the heat generation around it? Where do I connect to the grid? Where's the substation? I can simulate all this and design all of this in a digital twin before I even break any piece of ground. So it gives me a lot of efficiency, so I don't have to have issues in terms of having to make adjustments on the fly on my design, because quite often with construction projects, whatever you start, if you haven't simulated correctly, you will have a problem somewhere along the line. So the more you can simulate, the better. And we have a good example of that. Switch is a data center provider. They used a blueprint. They got a design validated now that will go up to 2 megawatts a rack. Even though we're only doing 250 kilowatts a rack today, their design can take it up to 2 megawatts a rack. They've managed operational density. You can get all of the things around it to look at airflow, heat capture. How do I capture everything? How do I make it as efficient as possible? So the space I have is being used in the most efficient manner before I actually start to break ground. And then when I've got it, how do I manage it to scale for the future? There's no point me building a data center with 30-degree water and 100 kilowatt a rack if the next generation is going to be 650 kilowatt a rack with 45-degree water. You've got to think for the future and really change the way you think about data center construction and builds. So what we really want to ask people to do is partner with us to build you on a sustainable future. What we try to do from the start is reduce overall energy use. Accelerated computing is very, very efficient at doing that. Get data center efficiency down to the right way, address the AI demand sustainably, do a lot of energy innovations as we can, so you can actually bring in operational efficiency, new modular sources. A lot of interest right now in Europe around small modular nuclear as a way forward. France has been the leader in nuclear energy in Europe for some time. Small modular nuclear is going to change the dynamics of that because the build cost and time to build the nuclear stations reduces substantially. Simulate first, make sure you virtually test, experiment, optimize, and then enable a scalable impact. Come up with something that's going to be sustainable for the environment around you, for the municipality around you, and how do I build a data center for the future? Oop, I'll go back one. So some final thoughts. So while AI has had significant impact on our world, that it's important for you to remember that the pace of innovation isn't slowing. If anything, it's increasing. Future data centers have got to evolve with the technology to adapt to that. We're going to start to see a lot of advanced AI shape the next generation of data centers, as we say, to deliver better efficiency and advanced features. Sustainability, I think I've made that point today. It's increasingly becoming a huge part in data center design decisions. Workloads using advanced CPUs and GPUs that require liquid cooling will give you all that thing. We see data center energy consumption will go up by 12%, but a lot of that will be provided by, as I said, off-the-meter power like photovoltaic or wind power, as we're starting to see in some countries to do that. And by using AI, you can make sure that data center providers and people who are building for the future can actually adapt with these changing demands. The example I gave you recently there of the building up a design that can go to 2 megawatts a rack gives you future proofing, giving us the ability to have a digital backbone of the future that's done in a very more considerate, more ethical way than perhaps we've done it in the past. That's basically what I had to share with you today. I'm open to take some questions from anybody, if there are any. Good. And for once, I'm within the time limit, because I don't usually manage to keep to time, so you've done very well to keep me to time. It's not on. Question, second row.
Hi, my
Hi.
name is Nikki Lisa Cole. I'm a senior researcher at No Center for Trustworthy AI and a member of the ENFIELD Consortium. Thank you so much for this talk today. I really appreciate the efforts that NVIDIA is putting in to create energy efficient, resource efficient data centers.
Yep.
You've presented some wonderful plans and examples of how things can be put into place, and I really applaud the company for that. That said, I want to push back a little bit on the term you're using of something being more or less sustainable, just to point out that something either is sustainable or it is not, right? Either the way we're using resources ensure that future generations have access to what they need, or it doesn't. For me, that's a very hard black and white. Something can be more or less efficient, but not more or less sustainable. And building out on that, I note that you didn't share any information about the sustainability challenges in the hardware supply chains for AI, which is something we've been focused on in this project. So I wanted to ask how NVIDIA is managing that as a maker of chips, right, which are increasing in massive demand, right, which is putting strain on material resources, labor, mining communities, et cetera. So I'm curious about what you're doing in that regard. And I'm also curious about your approach to collaborating with other companies within these supply chains. I noticed that in terms of those providing compute for this DSX model, that you have companies like Foxconn, Pegatron, and Wistron on the list, which are notoriously very bad actors in the electronics industry in terms of labor rights, environmental pollution, toxicity to workers. And so if you could respond to those points about what your planning is or what your operations are as regards those challenges.
Sure. So we have a complete corporate sustainability report that gives you all of the details in it. I can give you the link to how that's in there. I'm not an expert on everything that's in there, but I do know a lot of the things we do. One of the interesting things is we don't manufacture anything. People don't realize that. I had governments say to me, can you come and build a fabrication plant for me in Poland? And I'm like, no, because we don't build anything. We outsource our entire production. All of our production is manufactured by 2 or 3 different people. So for our chip manufacturing, it's done by TSMC in Taiwan and in other locations. There's a new location in the US that's coming up online. We also use Samsung and others. And some of those people are probably using the most efficient designs in the marketplace today in terms of their sustainability efforts to get that production out. But we don't actually manufacture anything, which people actually find quite surprising. We don't make things, we design things. And then people build it to our spec. So the interesting thing is the whole industry. If I go back 5 years ago, and I remember having discussions with people like Hewlett-Packard and Dell and everybody in the industry about the speed of change that we're making in terms of changing technology. And they're like, we don't want to invest a load of engineering money to go and build stuff for you to go and spend money of our own for something that's got a life cycle of 2 years, 18 months for each product line that comes out before you change the design. So they basically, most of the big mainstream manufacturers refuse to go and do any more engineering work, which is disappointing because they, in many cases, had built liquid cooling systems for HPC examples, for example, much more efficient than anything in the commercial world. But it was very much a niche marketplace for scientific computing. Now, what's happened now, of course, is all of those guys don't manufacture anything either. HP, Dell, they don't manufacture anything. It's all outsourced directly to ODMs usually in Taiwan. So everybody's using the same ODMs. We do, as part of our sustainability report, we do review anybody that builds anything on a contract basis for us. We review their availability and the things you mentioned about labor laws and things and abuse of the people. We go away and measure that. And it's all in our sustainability report, but we don't control. When people buy our technology, our chips, what they choose to do it and who they choose to manufacture is up to them. We can't tell. HP, you shouldn't use person X or person Y. They've got to make their own decisions in that space. But we do take it extremely seriously. We have a corporate sustainability officer, Josh Parker, who does a lot of work on this space. He's presented to the EU recently. We did a big review with the EU about sustainability, and we've done the same with many national governments around the world. So it is an area that we're fully on top of, making sure we can do our bit to make sure from the process that we control that we actually may maximize sustainability. So,
okay, Rod, thank you so much for your presentation. Very insightful. I'm Manuel from EDP, which, by the way, is generating some of the renewable energy that you are using in the US.
Yep.
Quite straightforward question. You talked about traditional processing. How do you see the photonic processing that is coming up, as they say? What NVIDIA is envisioning for the future for this kind of processing?
Photonics is a massive area. We've invested in it, quite heavily. We're moving to using co-packaged optics next year for most of the connectivity around the switching behind our technology. The main advantage of that is we can take a lot more copper use out of it. The other area that's got the photonics is enabling us to do is look at things in a different way. So I would expect it to have a huge impact in terms of reducing the number of transceivers and cables and copper that comes into there that's required for the future, and it's giving you better, more reliable performance. So photonics is something we're all in on. We're probably leading the world at the moment in getting that out there in a quick as manner as we can into our networking technology. One of the other things I didn't mention, actually, but I will mention it, as we move to these new racks at like 650 kilowatts a rack, with our new design that's coming out in December this year, we have no cabling in the racks. The current ones have got a lot of copper in them. We've moved completely to co-packaged optics on the back of the rack, so there's no physical cabling in the back, or we're using the zero insertion hard connect on the back end of it to take all the cabling out of it. The other thing is, as we move to 650 kilowatts a rack, you have to look at how to do things differently. So copper for heat sinks and the liquid cooling side of things is too heavy. We built a rack with copper, and it would go straight through a concrete floor. It's too heavy. So we've had to change the dynamics to use aluminium, which is not quite as efficient as copper at doing cooling, but obviously is a lot lighter and is a much more sustainable metal than copper is today. So we're going to move increasingly to use things like aluminium without compromising on the amount of cooling capability to actually reduce the amount of weight and power and the manufacturing loss that comes in terms of making those racks more sustainable.
Yeah. Can I take this one? Yeah. Hi, I'm Sagar from Sintef, a research institute in Norway. Very impressive what NVIDIA has achieved over the last few years. I mean, it's incredible. Although this amount of scaling to me seems like promoting an AI monoculture, which is making very large models by few actors. And it doesn't promote diversity so much from the first look of it, because not everyone.
I'd love to answer that for you. I've got a great answer for that.
So yeah, my question is, like, how would you get people to use a diverse set of AI models, small, big, and not, push everyone towards this very large scale hyperscale infrastructure development only? And it gives the impression that you're building these gigantic models, which is not accessible to everyone. It's highly controlled in the way they are trained and fine-tuned and so on. So I'd like to hear your opinion on this. Diversity is the seed for evolution and change and variety. So
fully aligned with everything you're saying.
Okay.
I mean, we happen to supply a lot of equipment to the people who are building the large frontier models. So the Anthropics, the OpenAIs, of the world that are building out these large frontier models. But at the same time, we have generated more open models and made all of our stuff open source to the marketplace more than anybody else. I didn't have the slide in my presentation today, but there's a great slide that we use which shows the number of open models that are being generated out there right now. China has probably led the world in building open models. DeepSeek was a good example of that when it came out. We have produced more open models for the marketplace than anyone else. We've produced about 50% of the open models in the marketplace have come out of NVIDIA Research, NVIDIA Labs, and they're all available completely open source. So you can take them, download them, do whatever you want with them. And we're encouraging people to use as many open models as possible, because open models are the future, not the closed frontier models. The only issue with open models is you have to find some way to maintain them. And I'll give you a great example of this. We were working with Barcelona's Supercomputer Center on building a large language model for all the languages in Spain. Now, if you go to Spain, there are 3 primary languages. You've got Spanish, you've got Catalan, you've got Basque. And if you look at Basque, it's a very different language structure to what the other 2 are. It's not close. So we built a model with Barcelona Supercomputer Center. They used our open model and their own open models to go and build it out. They built a model called ALIA. ALIA is now being used by the Spanish Health Service as a national model for Spain. The problem in getting ALIA to go beyond that is it was built as an academic model by an academic center, and there is no method today for anybody to take on support and maintenance of it. We have another project we're working on in Germany called SUFI, which is a large language model for the German language being built with Fraunhofer and various other partners. It's a fantastic model. It's probably the most advanced language model I've seen developed in Europe, again, using open models and some of our open technology inside it. But again, it needs to go to somebody to take these open models and support them. What Europe needs is a red hat for all these open models. So one of the things I've said to people is, well, if you want to be an entrepreneur, why don't you go out there and go and take all these large language models? There's the BLIC language model being built in Poland, which is, again, fantastic model for the Slavic languages, does Czech and Polish and most of the Slavic languages really well. And they are looking to try and get a maintenance model around it. But in order for these models to get accepted into industrial commercial world, there's got to be maintenance and support. I mean, no chief exec is going to go and say, I'm going to go and build a system based on a model built in a university with nobody supporting it. They're going to go to probably a foundation model to go and do that at the moment. So we're rapidly encouraging and working with people to make that happen. There are 2 really good examples in Europe at the moment. One is Mistral out of France. We've been working really close with Mistral. I'm having dinner with their chief exec this evening to go their next level, because they're trying to position themselves as Europe's foundation model and front model as an open based. And there's also one out of Italy called Domin, which is also building very strong open models and supporting them with customers. We are starting to see 2 or 3 European vendors really come to marketplace with models that are not on a par with anything that's coming out of the US. And that's what we obviously need to see on the European landscape, really. Yep. Absolutely. So it's very interesting because I have a friend of mine who's the chief executive of one of the bigger quantum companies, a company called Quantum Motion out of the UK. And I was with him at his house recently, and I spent a weekend with him, we were chatting, and quantum in terms of production quantum machines in real volume is still probably at least a decade away. I mean, quantum to me is a bit like fusion energy. It's been 10 years away, for the last 40 years. And I still think it's probably 10 years away from being in production. Now, that doesn't mean you can't make use of it. And what we're doing today is we're working a lot on helping people build up the quantum algorithms, the quantum solutions around that. AI is a great way to help you simulate and build out your quantum algorithms and simulations around that. We think that AI will play a strong part alongside quantum as it moves forward, the same as it does today with numerical simulations. I was chatting earlier with one of your colleagues. We chatted about weather, and I said, interestingly, ECMWF still uses a numerical simulation model to do its weather forecasting, and it is the leader in the world. Number 2 in the world is the Met Office, so the top 2 in the world have come out of Europe. Even though some people think the UK is not Europe anymore, but anyway. We have to have a bit of fun with that with the EU constantly. But what these people are now doing is they're using AI models alongside the numerical simulation. So the numerical simulation gives you the base data, and then I can rerun that 1,000 times an hour on an AI model to predict what's going to happen on individual levels. So if I've got a cloud formation coming, I can actually model what individual clouds can do with an AI model, which I can't do in a numerical model. But the AI model is not replacing the numerical simulation, it's augmenting it. Because with all AI models, they only work as well as the physics coming into them. And most of the AI models for weather, for example, can predict okay for about 72 to 96 hours, and then they fail. They don't, unless you give more data, more physics coming in, it's very difficult to be able to maintain it. So all of the weather sites and climate sites are running AI models alongside the numerical models, not necessarily replacing them. And I think that'll be the same with quantum, by the way. I think people will use quantum to do some of the really hard, difficult things that quantum is very good to do. But they use AI simulations around that to look at, well, okay, now I've got that. How can I optimize my algorithm for the future and things like that? And again, with ECMWF, they gave us their code, which is a very old piece of code with lots of very complicated Fortran routines in it and lots of parameters and things in it, right? And the only bit of good news about ECMWF's code is it's very well documented. So you can actually work out what all the parameters and things are. So we took their code, we ran it through our AI model, and we created it into Python from Fortran. And we built a Python-based version, and then we decided, well, let's turn it back to Fortran. So we turned it back to Fortran, and we've actually running it at about 20% more efficiency than the original Fortran model, because it identified your program errors and issues that were in there that may have been in there 30 years. You can now adapt. So I think as you start to see quantum come out, AI will be a key part alongside quantum moving forward, and I think you'll start to see all those technologies be in the forefront in the future, particularly for science.
Hello. Thank you very much for your presentation, and yeah, it was quite enlightening. And sorry, I'm Astik from Gruppo Maggiore, Italy.
Okay.
I completely agree with the dissipation, energy dissipation, and the cooling forms you have for the chips on design or the server racks. Yeah, we also have been working with Carolina supercomputer to dissipate the energy to the nearby municipalities and all. But do you have like other cooling methodologies, like liquid cooling, for example, like dielectric or a closed system loops that you are potentially exploring at this moment? And what do you think the major impediments would be for a space-based cooling?
So all of the cooling we do today is closed loop. So the intention is to go to no external water. You use a CDU unit and reuse the water coming out of it, and take the warm water out and put it through a heat exchanger to extract the heat and bring the water back in at the 45 degrees. So we're doing all that today. We have done a lot of experiments in looking at how can I mix this with immersion cooling. So can I use immersion for some parts of the technology and liquid for the other? We did a project with the US DOE recently, which is a pilot project, look at doing that. And we're very much on the forefront of looking at whatever type of cooling technologies make sense. At the end of the day, the big thing that causes immersion, as I mentioned, about ingress of the liquid into the technology you're using, which is an issue. But there are ways you can adapt to do that by keeping all your cable connections, for example, outside the liquid and things like that. There are ways to do that, but it's still usually using a mineral type liquid, which is not necessarily environmentally very friendly. And water today looks like it's the most efficient way to do that. So we're reserving judgment for the future, but single phase direct liquid cooling, 100% liquid cooling of everything is where we are today, and that's where I expect this to be for the next 2 years at least.
Thank you. We can take the last question back there.
Yeah, I'm at the back. I'm Martin William from UC Leuven in Belgium. I had a question about one of the slides you presented in your presentation when you said that big tech companies like Google are running their data centers on 100% carbon-free energy.
Yep.
And actually, if you look at the environmental report of a company like Google, that was published a few weeks ago, they say that they are at 65% of carbon-free energy.
Yep.
Despite the this point, and it's on market-based, not even location-based. And we see that this is not improving over years, despite the trajectory that they are showing, that they are claiming to have for decarbonization. And at the same time, we have this energy efficiency that is improving and with major improvements, but still the electricity consumption is increasing. And so actually the total impact of these companies is actually increasing. And so they are deviating from the carbon targets. And it's clearly because of the investments they do in AI, they say it clearly. And so I wanted to have your first, where does your number of 100% carbon free comes from? And second, what is your thought about this dynamic where we see that actually energy efficiency is not solving the problem right now?
So it's a fantastic question. I'm really glad you asked that, actually, because that slide is a slightly old slide, as you say. And it came out a while ago about in terms of where they were. They were the first people leading towards going 100% sustainable, all of them. The three I had up there, Amazon, Microsoft, and Google. Unfortunately, In the last 18 months, that's gone backwards because in the means to get things out quicker, they've been deploying gas turbine technology in an extensive way in the United States, encouraged by a certain gentleman in the White Office to go and do that, which is not necessarily the right thing for the planet. So they've gone backwards a little bit for the time being. I think that's a temporary blip because I think they will get increasingly measured on going back to making sure they hit sustainability targets that they need to get to. In answer to your question about power consumption, it all comes down to it's a function of demand. If the demand wasn't there, people wouldn't go build against it. That's why when I said at the beginning, don't believe this is a bubble because the demand is actually growing off the scale right now. If you go out and look into the cloud marketplace today and try to find an NVIDIA one single B200 GPU available to rent, you won't find anything. There's not a single GPU available today right now. It's a whole 100% full. So I understand that what we've been recently doing is with each generation, we've been adding the performance metrics in a higher way than the power consumption. So as we move from our current generation, Blackwell generation, to our new generation Rubin GPU, for example, we move from a 750 watt package to a 1.25 kilowatt package. So you're increasing the power by sort of 50%, 60% if you like, but we're improving the performance by 3 to 5x. So you're getting 3 times the performance for 60% more power. So the power efficiency is where we tend to focus because it's, at the end of the day, nobody's asking us to build anything that's less powerful than the previous generation. The opposite, we're getting increasingly pushed to do more with less. So we are focusing very much on making sure we maximize the power efficiency of what we ship. The other thing I mentioned this max LPS thing that I mentioned up in my slides. If you run a rack on our next generation of full performance, you're at 250 kilowatts a rack. If you run it at the LPS setting, so you're running to maximum power efficiency, you can run it at 169 kilowatts a rack. So we're increasingly giving people the tools to make those decisions that say, do I really need to run my racks at 250 kilowatts? Or can I run it at 169 and save 81 kilowatts of power for every hour that I'm using it by saving all that amount of power? Now, we've been doing this in the HPC world for quite a while. University of Edinburgh is one of the first people in Europe to build models to actually run some of the simulations at different levels. We've been working with people like TU Dresden quite extensively for many years to look at how can we maximize the power efficiency. So it is an area that we're really focusing on to make sure that people get the most efficient use of the power, not necessarily using it at full performance. I mean, if you run a car at 150 kilometers an hour, you use twice as much fuel if you run it at 75, and you probably get there 10% quicker than you would do if you stayed at 75. So we're increasingly trying to bring that same methodology and thinking into how you run the compute farms.
Okay, thank you.
Thank you.
Please join me in another round of applause. And thank you so much.
Thank you very much. Thank you.
Yes, now we are moving to the demonstration session, which you can actually, we are showcasing part of the ENFIELD project result. And it's located in Marble Gallery, which is in the 2nd floor. And coffee, refreshment are available. We just kindly ask that, make sure the coffee and all of this food will remain out of this auditorium. We'll start at 11 sharp. See you again here in 15 minutes.
Yes, fine. I can also. If you can just finish it at 12. Yeah, I will shrink as much as I can. Skip some questions if there. Yes, some of them are a bit redundant. Yeah, maybe the final one. Yeah. For the blocks, the synthesis and the spots. Yeah, the final ones are a bit. Yeah. Since you're already here and you're so. We miss Sutiris. Oh, he's there. He's there. Okay. Maybe her, and then I come for the transition next. Yeah, right.
And you can't give them speaker, I mean, the microphone.
Yeah.
Speaker time.
Yeah. So we're two, so one of us will talk, the other one will handle each.
Yeah,
Oh, yeah,
but
yeah.
one miss.
Yeah.
So 5 speakers, so we have only four microphones. Ah,
Yeah.
as a moderator, stand here.
Yeah.
Okay, then, so everyone.
Or I mean, walk between them, but I think there are enough
Just
mics. for-
one?
Yeah.
This is all.
All right, great. Yeah, I think it will be easier if they already have that. Hi, everyone. So we will start the next session. And so this next session will actually be a panel discussion session. But before we start the panel discussion, I will do a short introduction of a few minutes, then introduce the speakers, and then we can start the discussion. And so this session is named Edge AI, Robustness, Continual Learning, and Real-World Deployment. The main point will be to drive home discussion about how to bring AI into actual industrial environments, into sectors like manufacturing and the automotive sector, where there are many, many challenges that can. And so obviously, ENFIELD is a network of excellence project. So the purpose is to drive research excellence like other networks of excellence before it. But of course, the ENFIELD project is a bit different because the previous network of excellence projects, their aim was really fundamental research excellence, low TRL, drive really fundamental progress. And through the ENFIELD network of excellence, we have a slight shift, seeing that ENFIELD itself is in fact has a strong focus, of course, on fundamental research, but also has a whole other dimension on how to apply this fundamental research to industrial sectors. And so we are really a transitional phase from purely fundamental research into actually transforming that research into something that can be used in industry, and where we can see this integration. I think you saw in the keynote a very nice slide of AI adoption across sectors, and you could actually see, healthcare and so on. But the latest ones and the hardest ones, industry, manufacturing, automotive sector. So we will discuss specifically how we can overcome the challenges that pertain to bringing AI into those domains. And of course, one of the leading challenges that we have is how to deploy AI solutions on premise in those environments so that they can run and integrate with the existing systems that operate within, factories and so on. And we have a certain number of aspects that are very important. In addition, to edge deployment, would be to have robustness in non-stationary environments, because you will always have new data with changing characteristics. So a bit different from what AI research looks like, where you have a set training data benchmark, and then you have a sort of fairly stable distribution. A significant challenge is this non-stationarity. You need continual adaptations of the systems in production, avoiding things like catastrophic forgetting. And it's already been, the focus of extensive research, but there is a significant gap to bringing that research into actual industrial use. And of course, validation, certification, trust all the things where we can guarantee compliance with laws, with regulations, with norms in those industrial domains, norms that can be extremely complex and challenging. Besides, from the usual constraints of edge deployment, like latency, compute available, energy consumption, and so on. And finally, all the aspects pertaining to integrating the AI in the processes, in human-driven processes, seeing how AI will interact with the stakeholders, with the workers, with the various systems. So those are all extremely challenging questions to address. In fact, the argument could be made that Europe has all the ingredients to making that work, to tackling those challenges of industrial integration, from research excellence through, networks of excellence, of course, but all the ecosystem of Horizon Europe projects. There's a vibrant community of Horizon research projects with incredible outcomes. So, really strong research excellence in Europe, really strong industrial research and development, research and innovation. Next to that, we're starting to have the other pieces necessary for deployment, the development of platforms for AI compute to make access to compute easy and possible. So things like the AI on-demand platform, the AI factories, the TEFs, and so on. So many tools being developed to facilitate uptake of the technology, scaling, at least being projected through the next phases of funding through the Apply AI strategy. And a last ingredient for industrial uptake, which would be the whole Direct Europe program and things like the European Digital Innovation Hubs, which really allow research institutes to transfer the technology to companies, to industrial use cases, and to industrial sectors. So, but of course, the pieces are there, and the main question is, how do we connect them together to maximize what we can get out of the whole system? Because yes, if they're coordinated properly, we can really have a very fast transformation of European industry and the acceleration of AI uptake. So that was for my quick introduction, and I will now introduce the panelists and invite them to come on stage. First, we have Antoine-Alexandre André, who is Policy and Legal Officer at the European Commission AI Office. Then we have Ovidiu Verdmesan, Chief Scientist at SINTEF and representative of the DAI Edge Network of Excellence. Then we have Sotiris Makris, Professor at UPatras and representative for EFRA. Bert Pluimers, who is an industrial research manager at KU Leuven, who is very involved with AI applied to industrial projects and also in the automotive sector. So thank you all for agreeing to participate in this panel. So we'll start with more broader exploration of the topic and then delve deeper into the specific of industry integration. And so maybe we can start with Ovidiu. Did I pronounce it correctly?
Yes.
All right, great. So these, adaptive AI, edge AI systems are often presented as the magic solution for industrial applications. They can adapt, operate close to the machine, react in real time. But of course, from the research perspective, it's one thing, but when you actually start deploying them in those environments, you have all the safety critical constraints, you have all the unplanned things that can happen in those environments. It's very, constrained, very unforgiving sometimes in terms of safety, in terms of many aspects. So from your perspective, what are the hardest technical barriers that we need to overcome to move from this research-oriented solutions to actual industrial usage?
Thanks for the question. First of all, AGI, it's a natural development and move closer to the data, right? So the development in IoT created a huge opportunity to collect the data. And then we realize why you should transfer this data to the cloud, use a lot of energy, use a lot of communication capabilities, instead for moving the AI and the processing capabilities at the edge. And this is actually fantastic for all the application that you mentioned in the industrial arena, because all the industrial processes, for example, in manufacturing, you have the sensors that are producing data, you have the PLCs that are processing data, and one of the very important part is to include, for example, the intelligence in the PLC, and then transfer the data process across. It's not working. Is working, or I have to? Okay, thanks. So then this will create a much more efficient manufacturing process. At the same time, you can connect the dots. And not only connecting the dots, but as well processing in an intelligent manner. The challenge that you have is the one that is related to the constraints. You have at the edge a lot of constraints. So the boundaries are defined. So you have constraint related to the data rates, you have constraints related to the latency, you have constraints related to the processing power, memory, communication capabilities. All these have to be solved. But at the same time, you have a very interesting and beautiful way of doing by optimizing the different elements. Maybe in the cloud, you don't think about the hardware. Hardware exists. At the edge, you have to clearly optimize the four elements, how we call it the quad. The hardware, the software, the AI model, and the data. And this actually would solve some of the challenges that we have. At the same time, I'm glad that I represent the one sister project or brother project. It's AGI, and there are several of our partners that are participating in this event. And the Network of Excellence, DIH, address actually this part from the point of view of building a community, an AGI community. This is not done alone. Actually, what you mentioned, that some of the low TRL activities are done in this Network of Excellence. We are connecting and working very closely with large projects, industrial projects that are financed by other initiatives like joint undertakings, where you have large projects of 35, 40 million euros, and the majority of the participants are industrial partners that apply the AGI findings, research into different applications.
Thank you very much for this. Yes, thank you very much for this very detailed answer. And now I'll move to Sotiris. So we heard of a certain number of obstacles that are faced, that AI systems are faced with when being transferred in these settings. So in your opinion, from the perspective specifically of manufacturing systems and robotics, what are the most significant of these challenges? The bottlenecks really, is it mainly data integration, validation? Is it operator trust? There are many things that,
But on some resource, yeah, seems good.
Networks.
Now it's back. Yes, about the challenges. I think one thing that I would like to say is that in one sentence is that the challenge is less in the algorithm and in the model itself. As you said, it's more in the integration. And what integration means has different, let's say, perspectives. I will try to explain how we dealt with this discussion in EFRA, in the European Factories of the Future Research Association. I have been running the working group on productivity and flexibility, and we have been trying to analyze how AI, and especially the new generation of AI, can bring up potential benefits in manufacturing. So the key driver there, especially in this community, is the variability in different levels. First of all, we have complex products. If you take the car, for example, that's a product that has more than 8,000 components. Each of those components may come in different variations by design. And also from model to model, or I mean from the one car to the other, the very same part will have variation due to the nature of manufacturing processes. Every time you process a part, you have wear on your tool, and so you have a different dimension achieved by the final parts. So when you're going to bring all those parts together, you're not entirely sure that you have everything in nominal dimensions. So no matter what you do, you have variation for sure. Then you have drift of processes happening in machines, in cutting, milling, welding, in assembly processes. And then, of course, you have drifting happening in more logical layers, like the supply chain and workplaces, human variation. So there are so many variations that have to be controlled. This is mostly increased by the increased need for having more customized products that will fulfill more and more the needs of individual consumers. So this increases further variation. And the latest thing that is actually something of the next, let's say, framework program discussions is the ability of factories to be transformed to produce different products. There are many discussions about dual-use factories that can change from one product to the other. And automotive is one example, but there may be other factories that we want to change quickly. So this flexibility had a specific sense up to now. It keeps changing. There is more and more change on that. So that's a great opportunity, I would say, for AI to help us with that. So to systemize the scientific development of AI in this environment, we structure in 3 levels, having at the lower level the AI aspects related to the processing of materials, how you really process materials and how AI can help you control the process. Then we have a level up that is the workplace level where humans and machines interact or machines and machines interact, and you have to deal with handling variation at the workplace. And finally, we have the production line where a full line is producing part, and then you have to synchronize and orchestrate the production of the entire product, and of course, expanding to the supply chain. All these 3 layers are connected with the data, a sort of data layer. And this is where AI maybe can use this sort of common bus to synchronize everything. So this is a very brief picture of integration. I would say it's not, we had this discussion if we should have, when GPT came out, we thought we should have the manufacturing GPT that describes everything, and you have the factory copilot that everything will run with the help of this copilot. But later, going to detail, people thought that you need probably a foundation model for the processing of the material where you characterize the actual process, and a different process for human-robot collaboration and a different foundation model for the production line. So there is a lot of discussion of how these foundation models should be structured at first and how to be further integrated to have an integrated paradigm. So I will try to stop here. I hope I gave some perspectives on the integration challenges. And thank you.
Thank you so much for this answer, and I think you did a very good job at giving quite a comprehensive picture of how AI can be deployed specifically in manufacturing. And now turning to Bert, I think you have some experience specifically with the automotive sector, and according to you, what would be the unique challenges in this sector? Is it mostly the same as manufacturing, or are there unique challenges? I think during the keynote we had this example of the revolution of automotive factories in China. So from your perspective, and maybe from the European perspective, what are the specific challenges in this sector?
Yeah, thank you. This is working. Yeah, super. Yeah, thank you for the question. And I will build on what Sotiris said, because automotive is just one sector in the full manufacturing sector. It's an important one, especially for Europe, looking at GDP and employment. If I take a step back, I think I agree with the starting sentence of Sotiris that the main challenges in automotive manufacturing are not on, let's say, the algorithm side. I think a lot of algorithms have been developed. A lot of algorithms are being deployed in industry, but let's say an industry which is less physical. In manufacturing, in automotive, we are in a physical space. We are making, across a very complicated value chain, we are making physical products. And we will keep doing that in whatever manufacturing sector you look at, because we live in a physical world. You're all working your laptops, your mobile phones, you're sitting on a chair. I'm speaking through this microphone. We are living in a physical world, so we need to manufacture things somehow, tangibly. And I think there is the biggest challenge ahead of us. How can we make sure that the enormous potential we have on the digital side, on the AI side, on the algorithmic side, how can we make sure we fully exploit that in a complicated manufacturing context where, due to elements such as variability, let me add two more elements there, an element of industrial heritage. You refer to China. In China, there's a different policy. They just throw down a full village and they build a new one. We don't have that way of working in Europe. We have industrial investments which have been made over the past decades, and we cannot just forget them. We need to build on them. We need to leverage upon them. That is one. Secondly, and now I lost my third point. It will come back. So we have the variability. We have the enormous investment on cultural heritage. And the third one being, we have very limited data. Yes, we have data. We have sensors on manufacturing machines. But our manufacturing is typically low volume, high mix. You heard the customization element, which means that we don't have the gigabytes on training data. We have some tries on generating synthetic data using the simulation models. It was also mentioned this morning. But I think there are huge challenges on how to convince our industry, which is suffering today, which is fighting for survival on manufacturing. How can we convince them to do things differently as they have been doing for the past 50 years? They know they have to do things differently, but how? And I think that is where this community needs to inspire them through maybe pilots, through maybe bringing them close and letting them themselves discover what is possible.
For your answer, and now as a conclusion to that first phase, moving to Antoine, and we've seen that there are some research gaps, deployment, validation. I mean, there are certain number of gaps. And from the perspective of the European Commission, what are the next steps to sort of set forth a better ecosystem coordination to drive AI adoption in these sectors?
Thank you, and thank you for the invitation first. I think all of what was mentioned by my fellow panelists are all interesting and important things, but I think we are missing a big point, which is, and it was actually touched upon a bit by Bert, which is this this human aspect, actually, this integration into existing organizational processes. It is true for manufacturing, but it's also true for other strategic sectors in the EU. We have a tendency actually to think that all of our problems or challenges that our companies are facing are actually technological problems. They are, definitely. There are a problem of data, there is a problem of data, there is a problem of compute, and so on and so forth. But there is also a very big problem of reflecting on existing organizational processes and making sure that actually these reflections take into account the needs and the requirements of and the potentials and opportunities of AI technologies. So this is something we are very much working on now at the European Commission level, notably with the Apply AI strategy, where we are introducing this idea of we want to ensure the focus being on the identification of concrete use cases in sectors that we find strategic. And we are talking mostly about use cases in core sectors, in core activities of those strategic sectors. So with the Apply AI strategy, we are providing kind of the framework that allows these identifications. And then the next step is very much the scaling of these identified concrete use cases, because we believe actually that companies have a lack of awareness of existing solutions that can be very much easily integrated into their organizational processes. So we are very much as well focusing on this technological aspect, but also more and more when we are talking about deployment, focusing on these on the organizational processes and the business value creations of companies to try to make sure actually that those use cases which are piloted by a very interesting research project can actually find their way into the companies that are actually out there selling or providing services to others.
Thank you so much for this perspective. And now moving on to the next phase, I'll let Walter continue.
Okay. Yeah, thank you. I have a couple of round of questions for you too, but we are quite short in time, so I will be very strict and sharp. First question is for Sotiris. So let's say that in Europe we manage to achieve this adaptive AI leadership. So AI models or a class of AI models with characteristics like self-configuration or continuous learning or autonomic computing alike. Where do you see they can impact? For example, in flexible production, in human-centric systems, in adaptive robotics, and so on.
All right, thanks, Walter. I think I can try to build on what colleagues have said, because I would like really to go beyond on this human-centric part. I had it also as part of my contribution. So human centricity is a key thing, considering also the aging population, also the lack of workforce. Europe may have gone through that situation in the previous decades. Probably this time we want to deal with it differently, maybe exploiting technology to help production use best the available workforce and use technology to support and use this existing know-how to support people more in their production. So one would say that we want to move from production lines that simply repeat the same tasks to production lines that are flexible and reconfigurable in order to manage variability. And on the one hand, the machinery and tooling and production flows all have to be able to be adapted, and to be adapted with the help of AI, both mechanically but also organizationally. But more than that, it's mostly the human capital that must be able to interact with this technology. And this also comes in different levels. Most of care has been taken and being taken about operators in the shop floor that will have to interact with the variability and flexibility, and how human can mostly control the shop floor rather than being controlled by an AI algorithm. So these are things that are being investigated. And also with the increasing amount of information being produced by AI, cognitive load and handling the capacity and capabilities of actual humans is something that needs serious research and proper care. Of course, there have been researches in the previous frameworks with involving experts from the SSH, but I think we have to go even further to see how this amount of the volume of information being produced by AI can be helpful to manage in a more cognitive, proper way the capabilities of people. But beyond that, one has to see also the perspective of the engineers, foremen, and production managers that will have more tools assisted by AI to control the actual factory. And that's something that can take us to new production paradigms where lack of workers or lack of expertise can somehow be handled with the help of flexible automation, AI, and using the expertise of engineers and production managers, or even raising the quality of job of simple workers to be more conductors of production rather than performing manual jobs. So the future of work in the factories with the use of AI and flexible automation, I think is going to be very interesting, and that would be a way to sustain production in Europe in more productive, flexible, and sustainable way. Thanks.
Well, thank you, very clear. Next question is for Bert, and my apologies because it's quite high level, almost political question. So in the opening session, we heard that we are decades behind with respect, 1 decade behind with respect to certain AI technologies such as physical AI and AI farms. But on the other hand, we are quite good, also thanks to the initiatives that the Commission funded in technologies like edge computing or edge AI and adaptive AI. Do you think we should focus on these technologies rather than following other ones? And if so, on which basis? I mean, do we have the knowledge, the capacity to lead on this, or we should fill the gap with respect to the other foundational technologies? Thank you.
Thank you, Walter. Very interesting question indeed. And let me maybe take a step back there. I think as a society, we need to invest in the technology we need. And indeed, the world is evolving at an incredibly rapid pace, looking at the East, looking at the West, soon looking at the South, which means that we need to look at what Europe needs for the future. And as I referred to in my previous intervention, in Europe, we have set a certain ethical standard of living, a way of dealing with each other, dealing with the environment, which has led us to the economic landscape we are today. We are a quite decentralized, network-oriented, if I talk from a manufacturing point of view, landscape. Yes, we have a lot of strong, very large companies, but the ecosystem is made up out of a lot of small and medium enterprises. So we have a very large number of organizations in manufacturing, which are geographically quite spread, especially when we start looking at things not from a regional or national point of view, but European point of view, which is personally my opinion we should do. And if we combine that with the way we look at sustainability, at reuse of products, components, materials, raw materials in the end, and linking that to sovereignty, I think we should invest in this technology, which we need to build those pieces together into the European manufacturing system of the future. which means we need to leverage the data. Linking to what Sotiris says, we need to include the human into this loop, which is already a completely different mindset from when we look to other parts in this world. But that is what has made us strong in the past, and that is what will make us strong tomorrow. We need to leverage the digital technology or exploit the digital technology in making sure the people we have are employed, are creating added value in a sustainable manufacturing system, which makes use of the heritage we have, which is distributed, such that we can produce what we need for ourselves in future. And by doing that, by driving the excellence thereof, export will follow. So personally, I'm not a fan of the others are good in that, so let's focus and become good in this. Let's see what we need and invest in that.
Okay, thank you. For a political career, the answer very precise. Now, the next question I have is for Ovidiu. You mentioned in your previous speech the more or less some insights about cloud edge architecture. So my question is about the edge AI specifically. What would be the main advantages in order of priorities eventually that a manufacturing company could have after deploying this technology?
So maybe to make the discussion more interesting, I would mention that maybe I disagree with two statements that were made previously. One, it's related to data in the factory and that we don't have enough data for training different models. This is not true. So, and this is based on the experience that we are working now with several manufacturing companies, for example, semiconductor companies. They have huge amount of data collected from their processes. Now the issue is to how to structure that, and all of them are moving towards developing their models and training their models with very clearly task-oriented. They are not generic large language models, but are task-oriented, domain-specific language models. And here it's a huge potential in Europe for the data that exists on premises in several manufacturing capability. The same is for autonomous vehicles, or the vehicles of the future that have all the sensor collecting data. So autonomous vehicles with all the sensor, lidar, radar, the different ultrasound cameras generate 5 gigabytes of data per day. This is enormous. With this data, you can train the model for the car and improve the efficiency of the operation of the car by training during the night when you park it. So this is one. The other point, you mentioned the physical AI is far away. No, it's here. So the physical AI will be the next push, and edge AI will accelerate the development of physical AI. And this physical AI will be one of the elements that will accelerate as well the implementation into the manufacturing processes. And now coming to the question, actually for us, it's very important that we look at edge AI as a system, and not a system isolated, but more and more system of systems. I can give you an example. In the vehicle, you have different sensors. Each of them have the edge AI processing connected to the sensor, but then you have to connect them together. There is another layer of processing AI that optimize the data. And then for us, and this we developed a lot and we push in the ecosystem on edge AI with the DI Edge. Alain is here, he can support this. A clear architecture for edge AI systems that includes, first of all, one element that is the technology stack. The other element that is related to quality properties, and here on quality properties come elements related to trustworthiness. And the third one is the computing continuum. So micro edge, deep edge, meta edge, MEC, fog, and cloud, and how you process data across this continuum. And for the technology stack, important elements depend on the application. In some applications, the hardware is very important. You have to customize your hardware, maybe not in the data center. You see, NVIDIA, it's a company that show that actually the AI accelerator created the power base for developing the whole stack. Then can be the software platform, can be the AI models, it can be the training, the different training and learning algorithms that you are using. Because now you see the developments. You discuss about federated learning, but you can discuss as well split learning, which are specific to the different application. And this is the beauty of AI. It's not something that it's uniform. You have a heterogeneous environment and then different types of implementations.
Okay, thanks a lot. Next question, Antoine, of course, is for you, since you are the one left, and it will bridge to the next session block, let's say. So if you had to explain the European industrial AI development stack in practical terms, so for my mother, for example, how would you distinguish the role of network of excellence, AI on-demand platform, AI factories, shared AI infrastructures, TFs, so testing experimental facilities, EDIH, and finally also to frame them in the applied AI strategy?
Thank you for the question. So it's something that we hear a lot, like people are confused a bit about all of these initiatives. But actually what we are simply trying to do at the European Union level is to try to provide initiatives at each of the step of the production or the value chains of AI. When it comes, for instance, to the European Digital Innovation Hub, so a network of one-stop shop, if I may call them that way, which are all around Europe and which are supporting directly on the ground those companies who wants to integrate somehow AI, but also less developed types of technologies. And here we are talking very much about organizations of all size, but most with a focus on those of the smaller size. So these European Digital Innovation Hubs are very much the first step for a company that really wants to modify its organizational processes, integrate new types of technologies, including AI technologies. They should directly go to their European Digital Innovation Hub, which is around them, locally based, and which is able also to talk to them directly in their native language. Then you have several supporting capability initiatives like the AI factories or the testing experimentation facilities or the AI regulatory sandboxes that you were not mentioning, which are directly supporting those companies which are a bit more advanced. The ones which want not just to use solutions off the shelf, but the ones who wants to actually develop their own system or fine-tune existing models which are already available on the market, or train new types of models with their own data. All of these are actually supported by the factories, for instance, for what concerns the computing access, the access to AI-based computing infrastructure, testing experimentation facilities by directly trying to introduce some specific systems in real-world conditions, which are directly supported by the regulatory sandbox, which makes the links between trying in real-world conditions and making sure that actually your system is complying with the rules that exist, notably the rules that have been put forward in the AI Act. So each of the different actually initiatives have a role to play in the full AI value chain. If you are an individual small or mid caps, you go directly to the eddies, which will be able to actually send you to the good supporting initiative. So the first step should always be for an organization to go to the eddies, which are equipped basically to support you throughout the journey. If we are now talking quickly about the network of excellence, Here it's much more down the production chain. I mean, trying to support as well what we call the creation of this ecosystem of excellence. So making sure that we are actually able as well in Europe to develop the technologies we are using. So each of the different initiatives have a role to play alongside the AI value chain.
Okay, well, thank you. Very clear. So my mother would be enthusiastic. She's a respectable lady. Anyways, I would close, let's say, my part with a whole panel question. So each of you may want to address, and it's more or less on what Antoine just stated. I have I got perfectly the path that a manufacturing SME should, so the first step it should do. But to my experience, a lot of manufacturing SMEs try to enter this circuit to elevate their AI integration, but at some time of the path, they stop because of different reasons. So in the opinion of our acknowledged panelists, maybe starting from Bert and then going in clockwise order, what do you think it could be could be some root causes, and how do you think this behavior, which is quite frequent, not 100%, but it happens, how these opportunities can be achieved?
Thank you. Of course, it's very difficult to answer in your SME's case, but I think in general, there is at start a lot of over-enthusiasm when starting, thinking that AI is a magical solution, which it might be, but you really need to dissect first your business model, your technical processes, to see which data you have available, to see which data you can generate, to see which knowledge you have available, to then start implementing it. And I think there, in my world, the manufacturing world, it sometimes lacks people of inspiration. So we see that involving young people in these kind of brainstorm sessions helps, because thinking out of the box is not easy on an industry side. And then taking this to implementation requires a lot of specific expertise, which needs to be trained on a daily basis to stay on par, because the evolutions are going that quickly that big companies often cannot internalize this themselves. So we see an important role coming up for what we call integrator organizations, who take creativity and deploy it at company side. I think there also universities and RTOs can play an important role to inspire. Just to give one example, maybe in context of the automotive, it is true that autonomous vehicles generate billions of amounts of data, but that's when driving, which means it's very useful for training ITS systems, for instance. But the feedback to manufacturing is relatively limited today. What do we think is needed is that you have a full digital container counterpart of the real product, of the real car. We call it the infinity loop model. Basically, you collect the digital information throughout the full lifetime of your, in this case, vehicle. You start from design, you go to manufacturing, you go to production, and you go to operations. And if you can link that data together, if you can create a straight-through digitization approach, then you have a chance of success and really creating added value. And what we have done is we have created such an infinity lab where companies can then pass by and be inspired upon. So I think creating sufficient knowledgeable people and organization to support, and having on the other side inspirational environments I think those are two key building blocks.
Okay, I will try to be brief on that. I will share a couple of experiences with SMEs. Of course, the issue of data has to do with the company. Different thing is to do with electronics, that is more structured. And another thing is to do with the SMEs that are, so data is somehow thing that depends on the case. But from our experience, I would like to share the experience we have with SMEs with these TEFs, the AI Matters project that we participate. We established in Patras in Greece this TEF, and we experiment with different models. I mean, it's a different thing to bring to the TEF technology company that has a different perspective to try to prove a specific technology, and it's another thing to bring a production company that sees things from a different perspective. And a third thing is that we try to bring also bigger companies that are not necessarily SMEs, but also for them it's a different journey. So a key thing is to select the proper use case, and this selecting the proper use case is a risk-taking exercise, both from the TEF perspective, that you need to have experienced people that can understand each and every factory and choose a proper use case that can show the value, but also from the factory or the SME side, that they have to choose a proper use case to prove that their technology is valid. However, without TEF instrument, we will not be able to do it. So TEF in this case is a very good instrument. And the second instrument I would like to mention is the competence centers that again in Patras we established the teaching factory competence center. That is a place where people can come and get training on a specific technology, whether it is physical, machinery, humans, robots, collaboration, or more digital technologies. And these small training sessions help to inspire, I think you said this inspiration element, Bert, to inspire the people on what is possible and then to generate ideas for use case. So these are the things we have been doing, the Competence Center for Training and the TEF. And that's the way we are trying to work with Greece and Southeast Europe.
Yes, now just another comment on the part related to the automotive industry. So actually, what was fantastic this year in January at the electronics show in Las Vegas, NVIDIA and Mercedes demonstrated the collaboration in using the AI and the platforms from NVIDIA combined with the platform on Omniverse that has been developed for many years by NVIDIA. And actually, this shows how the data is collected and used by all the involvement partners in one value chain, because Mercedes can use the data that is collected in driving journey in order to analyze the different maintenance issues, and as well to see what elements in the production line could be improved based on the driving experience. So this is related to this one, and this, I think, it's part of how Edge AI will influence the developments in the different manufacturing and other sectors, from energy to mobility and other ones. Related to the SMEs. So for me, the point with the SMEs in some case, and based on experience in many projects, is that sometimes they take AI as a magic bullet. They can solve all the problems without putting an effort, understanding the technology and understanding the applications. And from this point of view, we mentioned, and in the project we insisted a lot on the engineering development process that includes AI, which means that requirements and specifications for the Edge AI system or the AI system that we developed are essential. If you don't know what you are going to do, if you don't know what are the requirements or the features that you want to implement, will be problematic to obtain this. In addition, these have to be connected. The next step is where is the architecture of the Edge AI system that you develop. Without an architecture where you envision all the elements that I mentioned, at least 4 that you have to address: hardware, the part related to software, AGI models, and data sets, and combined with augmented data sets and part related to synthetic data, then you cannot design the system. The next part is designing the system, and again, designing the system to optimize the 4 elements. And then you have another element that is missing in the normal development of the process for electronic system is the optimization of the model and continuous update of the model, because the model is valid for maybe 2 months or 3 months. The development of the data, the development of the new models are changing. How you are going in your system to update continuously over the life cycle of the system, these elements. And this is very important for an SME to understand, because then they can focus exactly on what is their needs, instead for jumping and taking an off-shelf solution, trying, failing, and being frustrated.
And I guess it's for me to close this round. So I will actually take a counter adjective to what Bert introduced in the beginning. You said, Bert, over optimistic. I would say too pessimistic about the potential of AI. No, actually, I agree with the 3 of you. What we lack very much is those illustrative use cases, like things where companies can really understand what is the added value of integrating AI into their organizational process. What we lack, and I think that's also a bit your comments about this over optimism, is we have sometimes also commercial actors that are selling actually off-the-shelf solutions, which are supposedly answering all of the potential questions and challenges of organizations. I think this is a totally bad argument to sell AI systems to organizations. We are not talking about this when we are talking about integration of AI. We are not talking about integration of a LLM. We could be talking about integration of a LLM in your customer service relations management tool, but we are talking about much more than this. We are talking about the integration actually of AI into your core processes. We are not just talking about supporting processes. And for this, we need these examples. We need to have also perhaps industry focusing on a few illustrative examples, not to go for 25 different types of system for the same type of function. We should perhaps try to put our efforts together in order to try to come up with solutions which are usable for a wide variety of organizations in the same sectors. So this is something really that we are trying to achieve with the Apply AI strategies, these identifications of those use cases, of those existing AI solutions that bring concrete benefits to core processes of strategic sectors, organizations, and then how to scale those types of illustrative example in order for actually the whole European economy to benefit from this.
Thank you so much for those very interesting discussions and answers. We had a small last block, but since we're running out of time and since most of the things have been said quite thoroughly, so I think we can stop here for the discussion. So thank you so much again. And we have a few minutes for 2, maybe 3 questions from the audience. Short questions.
Hi, hello, this is Rafael with IO Integrated. We do applied solutions. Thank you for all this good talk. I see we have a marketing problem, maybe. I wanted to know if there is an emergent a set of best practices that are emerging from at least different industrial sectors, and is there a group? Is part of the work constructing those best practices and stats and stuff like that, things that people can reuse at least theoretically? That's my question.
I can mention that yes, there are. So at least the DI Edge plus the collaboration that we have for several industrial projects, we are building the recommendations and the methodology for how to use the different workflows for different types of AI, because we are not talking about only one type. We have to think differently for machine learning, neural networks, deep learning, for generative AI, and now for agentic AI. And this show as well in the need for various type of hardware that are much more optimized for the different workflows. This is one. The second one, we are best practices. We are focusing now on how we can present the verification, validation, and testing of AGI system. This is a huge gap because everybody is testing, benchmarking, or validated using their own methods. There is not a common taxonomy. There is not a common methodology for this. And this is what we are pushing for, having a kind of best practice related to this area.
Perhaps to add quickly, very quickly, I know I'm aware of the time. Apply AI strategy is actually introducing governance mechanism. The Apply AI Alliance, among them, is basically looking at creating sectoral communities around strategic sectors, and we are organizing sessions, structured dialogues that we call with a lot of different actors to identify and then put all of these use cases into repositories, but not just repositories, also what we call pathways. So basically supporting at each steps a company to integrate a specific type of solutions. So yes, Apply AI Alliance, Google that, you will find what you need.
Plus one comment. Don't think that there are so big differences between industries. There are very much, and you can use a lot of synergy between the AI implementation in one industry in another industry. There are a lot of synergies. The principles, the way in which you apply are quite similar.
Francis.
Yeah, of course. But...
Hello? Do you hear it? No. Okay. Thank you for the nice panel. Addressing the whole ecosystem of human-centric and adaptive AI, which is very interesting. For me, the most challenging issue in human-centric and adaptive AI is the balancing system autonomy with human oversight and trust. If we can say, for example, among the different issues, if we take two issues, one is the explainability and adaptability trade-off, and the other issue is cognitive overload. So, if the AI system could adapt, its autonomy, it can generate a lot of black boxes, and also a lot of requirement knowledge from the user side. So, in the real deployment and a real application, which part of the ecosystem we are requiring the trade-off? Is it from the user perspective or from the AI perspective? And where this balance should come? And the real world, I'm not talking about the research, from the real world. Do you see this an issue?
Yes, so we have actually what we call the AI Act, which is a product safety legislation that tries to address all of risk related to health, safety, and fundamental rights, imposing actually obligations in terms of accuracy, robustness, cybersecurity, human oversight to those systems which are put on the internal market, so which are actually sold in Europe, that we considered posing some risk to these three categories, to health, safety, and fundamental rights. So when you are talking, for instance, about potential for a risk to specific systems not being fully controlled by an individual, you will then directly refer back to these obligations of human oversight, where we are actually imposing some types of technical rules for providers of systems which are considered high risk.
From my point of view, I think you touch a very interesting point that will come even more with the use of agentic AI, because agentic AI and multi-agentic AI will create autonomous system where in some cases the humans will be not involved at all. And then the agentic AI architecture is clearly to perceive data, perceive events, then reason, and the reasoning is based on either human knowledge, either connecting to LLM or an SLMs specific for that, taking decision, making the action that is supposed to do, and then learn and give feedback. And in this process, if you are using LLMs or other language models for specific domains, you can have hallucination. You see, they are clearly introducing some elements. So here, maybe heterogeneous implementation with form of human in the loop or checking elements are very important, because this need in order to create that balance that you mentioned.
Okay, thank you so much. And I'm seeing that there are discussion, so we can follow it later during the lunch break. Thank you so much for the panelists. Walter, Adam, thank you so much. Yeah, and we now move to the next session, Sustainable AI, Challenges and Direction for Future AI Application. Yes, Eirik, thank you.
Hello. Hello. My name is Erik Jonas Husum. I'm a research scientist at SINTEF in Norway, and I'm very happy to welcome you to this session on sustainable AI. Rod Evans from NVIDIA said it this morning. AI is driving the largest infrastructure build-out in human history. And I can believe that. We see it in the recent UN report on environmental costs of AI. We see it in the sustainability reports of the tech companies themselves, and we see it in the research. AI is having a significant climate impact, whether that's through materials, energy, water, or land use. And even though it's often being sold as an enabler for the green transition, it definitely has this substantial impact, and it's growing. Over the next hour, we'll have 4 short talks followed by a panel discussion providing different angles and perspectives on sustainable AI. And without wasting any more time, I'll introduce our first speaker, which is Alexandra Papagiorgio from KU Leuven's Center for IT and IP Law, where she works on EU environmental data governance and legal automation.
Hi, everyone. Thank you. Great. I'm very happy to be here and speaking at this wonderful conference and sharing some of the research I've been currently conducting on the environmental sustainability of AI. Coming from a legal background, my presentation is going to focus on the legal and ethical aspects of AI infrastructural developments. And due to time limitations, I will just focus myself on 2 main points. So starting with the AI Act, for those who are not familiar with this legislation, it's a legislation that has been adopted on EU level and is regulating on a product level the AI. So what we see when we look at the AI Act with respect to environmental sustainability is that the main article, so subject matter plus objective, is actually mentioning environmental sustainability as one of the key objectives of the regulation. And then looking on 2 levels with respect to transparency obligations and voluntary mechanisms, essentially what types of, let's say, provisions oblige providers of respectively high-risk AI systems and general purpose AI models with, let's say, on the basis of reporting of essentially sharing environmental information on the models and systems respectively that they are producing. We have for computational resources for both HRI and JPI. And the only thing that we see with respect to energy consumption is only for general purpose AI models. There is currently a stream of research trying to establish environmental sustainability risks, let's say, as a systemic risk, but this is not something that we have as given. And then you can understand that if we were to accept that that is the case, there would be a whole out of range of obligations for those providers. Probably the most comprehensive and, let's say, inclusive considerations only remain on a voluntary level. We see that the, let's say, the code of conduct of Article 95 is the one who is essentially, let's say, having a more complete assessment on environmental sustainability of AI. But as you can understand, since those are not obligations and remain on a voluntary level, do not have the same, let's say, impacts that an obligation would have. Then if we look a bit outside of the AI Acts, maybe the most relevant legislation to look at is the Energy Efficiency Directive that was recast in 2023, along with the Commission Delegated Regulation of 2024, where we essentially see that data centers operators are obliged on the basis of Article 12 to essentially report information and key indicators to the Commission. And some of this information is actually publicly disseminated, but unfortunately only on an aggregated level, which means that, for instance, you cannot have access to the specific information per data center, but this is only happening on a regional or national level. Then, of course, there are other pieces of legislation that are not specifically, let's say, pertaining to AI, but come, for instance, from corporate sustainability reporting. As we saw already, there are a lot of reports that are being published by Microsoft, by Amazon, by Google, and those essentially stem from legislation that has to do with corporate sustainability. But then there's also a legislation on critical materials, on eco-design of products, as well as waste, or electrical and electronic equipment waste, which can also be, let's say, utilized in the context of assessing the environmental impact of AI material infrastructure development. Maybe the last point in that regard would have to, of course, make a reference to ethics, right? Because my presentation is not only about the legal consideration, but also the ethical considerations. As we saw, there are some small elements with respect to ethics in the AI Act, which remain on a voluntary level. But of course, I would have to also refer to ethics guidelines that were developed prior to the adoption of the AI Act by the high-level ethics group on AI, as well as on an international level by the UN. And those, of course, as you can understand, make more general references to essentially having the environmental sustainability of AI as one like, let's say, integral element of trustworthy AI. But then it goes without saying that this is not really something that is being implemented. Those are, let's say, ethics considerations that need to be taken into account. But in practice, we see that this is not something that really happens. Maybe just to conclude with, let's say, the key takeaway elements is that currently, unfortunately, the European legal framework is lacking with respect to assessing and regulating the environmental impact of AI technologies. And that is, of course, evidenced on the previous slides. But maybe two things that are currently a bit more alarming is the fact that I don't know, for those of you who have already read the investigative journalistic piece that was published like a couple of months ago on how essentially we've had big tech writing rules on the reporting of environmental impacts of AI infrastructural development. And that is something that we also saw last week. I don't have the screenshot of that, but essentially lobbying also pushed back some rules that the Commission wanted to put forward with respect to carbon emissions. And that's in consideration, of course, of the fact that on an EU initiative level, we see also a disempowerment of environmental impact assessment procedures, which are already ill implemented. And this, of course, raises questions with respect to how local communities are actually able and it is possible for them to fight against the construction of data centers in their regions. And of course, it's not only the US, but also in the EU, many examples of those local communities who actually contradict and try to oppose themselves to such material development. This is a case study, of course, for another, let's say, paradox that we see on an EU level on the narratives of the twin transition and green growth, seeing that essentially we're trying to achieve the transition to a greener economy, to a greener future, essentially. But the way that we're doing so is not really compatible with the level of growth of infrastructural development. And of course, data centers are just a great example to demonstrate that. The only thing I would like to close this presentation with is to invite you to imagine, let's say, a different way of doing business in Europe, a way in which we make sure that ecological and human well-being are put first and not economic and financial interests of third countries. Thank you.
So in our next talk, we'll expand the discussion a bit to indirect costs and benefit from someone who has worked with the environmental impact of data centers and on AI infrastructure in a decarbonized world. So please welcome Martin Viam from ULB and UC Leuven.
Yeah, thank you for the introduction. And so today I'll try to present you a framework for the analyzing of the indirect cost and benefits of AI applications. And this framework is actually called the ELT matrix. And that's will structure this presentation. Sorry? Oh, I thought someone said something. Okay, sorry. And so the way we look at the technology, digital technology, with this ELT matrix or the LES framework is really to see how this different technology can be as part of the problem or as part of the solution towards the environmental crisis. And for AI, typically, we can look at first level, the direct impact, with by analyzing the impact of the technology itself. That's the direct impact, and we'll have the whole life cycle that would be taken into account there. And so the production phase, the utilization phase, and the end of life will have only a direct negative impact, of course, because you are not on a technology that is actually capturing carbon or releasing water whatsoever. And so this direct impact can only be negative by itself towards the environmental crisis alone. And so in the SHIFT project report, but also all other reports that are published, you can see that the trajectory for the data centers infrastructure that are ensuring its development of AI is actually unsustainable. And we see that we could get to emissions to up to twice a country like France by 2030. And it's even increasing every year for this trajectory. And the typical claim of the industry towards this problem is green AI. So the fact that we can limit the direct impact of AI just by improving the energy efficiency. But what is often overlooked is what we call the Jevons paradox, is this idea that actually when we improve the energy efficiency, we always see that the technology use increases to try to get some benefits from the investment that have been done to improve the energy efficiency. And in total, we see that the total impact increases, and that's a condition that we are actually seeing in all the environmental reports from the different big tech companies. And so usually since this AI for green claim we can verify it very quickly that it's not going on the right path right now, we have this AI for green claim that is coming on the indirect impact. And so we say, okay, there is this direct impact that is increasing, but actually it's not a problem because we are doing AI for green. We have all these applications, indirect impacts that will be positive. And it is everything that is enabled by the use of AI to reduce the impact of other sectors. And this is usually happening through two types of mechanism. The first one is substitution. It's really the replacement of a process by an AI solution or a digital solution. I could give an example in the chemistry industry. We would replace a practical experiment that has a big impact by a very accurate digital twin simulation. The second way it can happen, it's through optimization. That's what we always have in mind. And one good example of this is the Google Contrail project. This is really pushed by Google. And it's this idea that you can optimize the routes of planes to try to reduce the impact of aviation without even changing the fuels. And this is something that is very efficient and where AI can really have a good impact. But actually, this narrative of AI for green is really pushed forward by all the big tech companies. This is a report that was made in Belgium that was commissioned by Google. And we see that AI solution and digital solution can reduce up to 30% of the emissions of other sectors through different types of application. We also have seen this in the GSMA enablement effect report, where they say that 1 ton we have a 110 trade-off between if we spend 1 ton of CO2 into digital technology, then we will have gains of 10 tons in other sectors that will not be emitted. And then we have also the GSC that is showing that digitalization can reduce the impacts of other sectors. And what is common in all of this is that all these companies, GSMA is a partnership of mobile operators. Then you have GC that is also a partnership of ICT company. Then you have Google here. Is that usually all these companies are really putting the direct and indirect positive impact as a balance there. And what we see is that there is clearly a potential bias, economical bias by these claims. And this is translated in those reports through different problems that it can very easily point out. The first one is the lack of transparency. And in fact, if we look at these reports and also the ones from the International Energy Agency, we see that out of the 154 climate claim benefits that have been analyzed by this paper, we see that 1/3 of them actually do not cite any evidence at all. And another third of them only cite corporate publication where you don't have access to the data and you don't have access to the methodology that is proving those claims. And so this is a big problem in the sense that we have claims that are not materialized by evidence. And then the second problem in the lack of transparency is the fact that traditional AI, so the way we were doing AI before, and we have been doing it in the research for decades, is actually less responsible than generative AI for the energy consumption. And actually, out of all the climate claims benefit that have been assessed, most of them actually rely to applications that are associated with traditional AI and instead of generative AI. And so we have this, we have generative AI that's mostly responsible to the increasing negative direct impacts and that is motivated by a positive indirect impact that is not even related mostly to generative AI. So this is one of the problems. The second one is the extrapolation of cases to different contexts. I will not go into the details here, but it's really the idea that when you deploy an AI solution in a certain context, you cannot be sure that it will be positive. It can be positive, of course, but it will depend on many other factors that are related to the context in which you deploy the solution. And for example, in this work that has been done by Schneider Electric, we see that by applying the same AI solution to optimize the cost of the access to energy, we see that in some cases, the gains that we have for the South of Australian side, for example, it will be positive, it will have a win-win in the environmental and economic gain, but in other places with the same solution, you will not have this kind of benefits. And this shows that the context of deployment actually matters more than the technology itself. And that we should really choose the use cases, as it was said before, is the use cases in which AI will be positive that should be focused on and not generalize the usage in every sectors. And then finally, often only the positive impact is studied, and this is something that should not be overlooked. And you have two types of, ways AI can be part of the problem. First one is induction. It's really pushing the consumption or the use of a product, of a process into another sector by the development of AI. We can think about the consumption of online shopping through personalized advertisements. This is one example of it. And then you have obsolescence, is increasing the unit impact of each of the products that you have so that the previous one are not usable anymore. And this is two different types of induction of bad indirect impact that should be accounted for. I will not go through this example because I don't have the time, but it's just the idea that the direct impact is 2 times the level of France, as I said before, and we have different positive impacts that can have a positive impact, but then you can also have negative impact that can be really huge. I'm not saying that this will happen, but it just shows you the potential negative impact that you have and that you should take into account. And finally, there you have some higher structural order that are much harder to quantify, but that will relate to the socio-economic transformation. And so if AI is actually changing all other sectors, it will have an impact on jobs. And if people have a different job or different activities, then they will behave differently. And this has also an impact that can be both positive or negative. And we have to be careful with the rebound impact at this point. And so as a matter of conclusion, we have Green AI decided that we have to reduce absolutely the direct impact. And this must come with efficiency, but also with sobriety to ensure that we don't have a Jevons paradox effect. Then you have the AI for green paradox. We should apply AI in some specific application where it's really relevant and where we see positive impacts. But the assessment is only possible at micro scale with specific context-dependent results. And should not be used as a general positive effect of AI. And then finally, the micro scale is speculative. It's much harder to quantify, of course, but you have at least to think about those speculative aspects, more structural aspects. Yeah, thank you.
Wow, already I think we have many interesting discussion points for the panel discussion later, but we still have 2 talks left. And in the next one, we have one of our own in the ENFIELD project, Dr. Lisa Cole, who has actually been co-leading the Green AI pillar together with us from SINTEF during the duration of the project. And she's a sociologist at the No Center in Graz, in Austria. And she will present for us sustainable AI as a 3-pronged environmental, social, and economic practice across the research and innovation lifecycle. So please welcome her to the stage.
Quite different heights. And you maybe can't see me behind this podium, so I'm going to try standing over here. Hi, everybody. Thanks so much for joining us today. As Eric said, I'm a senior researcher at the No Center and a member of the Green AI Pillar, and I'm going to share my understanding of sustainable AI, which is something we've been developing through the course of this project, kind of branching off and beyond from Green AI, as colleagues have already suggested is important. And so how we can aim to achieve this through carefully crafted research and innovation. And I'm going to also pose some questions that we might consider together on the panel. So let's start with, what does sustainability mean? I already suggested earlier today that it's really important to understand, based on the UN definition of sustainable development, which is the main policy driver, that this is really about ensuring that we meet the needs of the present without compromising the ability of future generations to meet their own needs. And this is why sustainable is not a gradient. It either is or isn't, right? So we're either doing it or we're not. And that's why the question in the conversation is really important. And it's explicitly 3-dimensional, right? If you look at the UN Sustainable Development Goals, it's not just about the environment, but it's about understanding what happens in the environment. It's connected to the economy, right? And it's also connected to the social aspect, us, people, our lived experiences, our realities together in communities around the world. So it's important to understand that there can be unintended consequences or indirect impacts, right? So like a green choice that destroys jobs is not sustainable, right? Or an economically efficient choice that fosters inequality, say in global hardware supply chains, also is not sustainable by this definition. Oh, sorry, I had a question for you there. So something I think would be interesting to consider is which dimension does current AI policy prioritize? And Alexandra gave us a good overview of that. And at what cost to the others, right? So what are we actually looking after well, and what are we missing is a good question to pursue. So what does sustainable AI actually mean? So if we think about that interlocking understanding that incorporates environment, economy, and society, we think about it in terms of AI, we have to think about the full life cycle. And that's not just the computational life cycle that green AI is really focused on, but the full life cycle of like making the technology, right? Starting with the hardware production through to how do we train and develop models? How do we deploy them? What are the societal, the environmental, the economic impacts of the deployment? And what happens when technology reaches its end of life? So it's important, as Martin just said, to make a distinction between direct impacts and these indirect impacts that are sometimes harder to measure, like, for example, changes to labor conditions or in the channels of economic exploitation, or shifts in our culture, right? Our way of life, our social structures. These are harder to quantify, but really important to pay attention to. So often if we focus on green AI, it's measurable. Maybe it's low-hanging fruit in that sense, but it's more challenging to pay attention to these other aspects. So we can think about how far does sustainable responsibility extend, right? If you think about, the question of NVIDIA, where they're not making their products, but they're buying them, right? And so are they responsible for what happens in their supply chain? How does that responsibility extend, and who's accountable for it? So one way I think we can work together to push towards sustainable AI is through interdisciplinary collaboration. And we've been doing that in ENFIELD, which has been really fruitful and nice, because you cannot engineer your way to sustainable AI, right? That's an important part of the scientific research and innovation process. But you can't do it just with the technical side of things, right? Because AI systems and infrastructures are woven into institutions, into culture, into daily life, right? So it's really important that we have these interdisciplinary collaborations between, say, like the traditional STEM disciplines and social sciences, but also philosophy and arts and humanities to bring creative outlooks, right, to how we conceive of problems, how we design AI technology, what we're looking out for, and that collaboration is from the beginning, right, upstream. The whole project is done together and not just like in a consultation way or sort of pulse check. So I'm interested in what the other panelists think genuine interdisciplinary collaboration looks like in practice, right? How do we actually do this? And the really big question, I think, for me is who decides what AI should do? Historically, with all science and innovation, those decisions have been taken by, small, rather homogeneous, powerful populations. But I would propose that the responsible research and innovation paradigm is a very good way forward if we want to achieve sustainability and have AI be a part of that. And this is a paradigm that is collaborative by design. It's multi-stakeholder by design. It's bringing in diversity, and it's about upstream engagement. So you see in this diagram here, this is what's known as the quintuple helix within the RRI paradigm, where you have environment itself as a stakeholder represented by key organizations, industry, civil society, societal actors, government, and academia collaborating together from the start to define what is the problem that needs to be addressed. What are the methods we use to address it? What does a solution look like, right? And research shows that taking this approach to research and innovation produces really good outcomes. You have a better chance of having a technology and innovation taken up in society and by industrial actors if it's co-designed and if it's respected, right, by the communities that will be impacted. So the question then is whose voices are currently missing from the AI research and innovation process, and how do we bring them in? So I have a couple, so to kind of sum it up, some key questions that come out of this brief intro for me is, who's responsible for sustainability across the AI lifecycle? How do we resolve the trade-offs that come up across the 3 dimensions of sustainability? What does meaningful multi-stakeholder participation look like? And can participatory approaches keep pace with the speed of AI development? So thanks very much for your attention.
Thank you for those very interesting perspectives, Nikki. For our final talk, we have Professor Jan Tobias Mühlberg. He's a professor at Université Libre de Bruxelles, and he's working on security, privacy, and responsible, sustainable development of ICT. And he'll take us beyond the popular narrative that data and AI can optimize us out of the climate crisis. So with that, welcome him on stage.
Thank you for the invitation to speak here. Do you know that feeling when you're invited to be the last speaker in a session and you, like, through the talks, you think like, okay, that point has been made, that point has been made, like, what can I sensibly still add to this discussion after all these great presentations that literally raised all the points that I wanted to make? So I skipped the introduction. I only keep the disclaimer. I am not an AI researcher. That is important to me. I do cybersecurity, I do privacy, I do data protection, I do sustainability research. I am not an AI researcher, but of course, if you're working in the space of cybersecurity, privacy, and so on, then AI is something you can't avoid. Sometimes you use it in the context of an intrusion detection system to detect vulnerabilities or things like that. Or something else that we have been working on is age verification. You might have heard that the European Commission is pushing quite strongly towards notion of identifying users and making sure that in particular children are not harmed by online content that could be harmful for them potentially. And you all know these checkboxes that you have to click these days. Yes, I'm over 18. I want to see that content that is appropriate for me. This will most likely change at some point in the future towards approaches where you either have to use your electronic ID document, or where some biometric or behavioral means will be used to assess whether you are at least of a certain age to access the content that you're looking for. And you can imagine that, for example, in these situations, there will be AI involved, right? So if you do some biometrics, you basically estimate the age of a user based on their facial features. Do they have a beard? Do they not have a beard? Can they look at porn? Can they not look at porn? That's the baseline we are talking about here. It's a bit more complicated, but we're going that direction. It's a very interesting use of AI because it's really a situation where we are looking at a technological solution to a societal problem that we basically didn't have to that extent before the internet, before the proliferation of this kind of technologies. If you go to a shop and you want to buy a beer, then the shopkeeper looks at you and will probably make a reasonable assessment whether you can have a beer or whether you can have another beer. And if a 16-year-old person is buying a whole crate of beer for the whole bunch of 15-year-olds outside, then probably a responsible shopkeeper will do something about it. So we don't have this situation where a responsible shopkeeper can take care of the actions of a person who is trying to access some information or some online shopping or whatever. So we are trying to find technological solutions that involve a lot of data and to some extent artificial intelligence to address these problems. And we've done the study to the European Parliament, which has a big technical assessment and a big legal assessment of the situation and the feasibility. I don't want to go too much into detail. The interesting summary that a German tech magazine did of the study is that age verification in the internet might be necessary, but it cannot be done in democracies for all kinds of reasons that involve data protection, privacy, harm to the freedom of development of children, of people in general. But beyond all that, I think we also have to understand that if we build technology at the scale of the internet to serve information, and then we figure out that we need to regulate that we need to have additional protections in place to make that information not harmful for certain groups of people or in general. We put a lot of barriers in place as well, and all these barriers are technological, and they do have an impact. They have an impact in terms of the equipment, the hardware, and the software that you need to deploy. Things become more expensive necessarily. They have an impact on people. So accessibility is a real issue. If we look, for example, at biometric age estimation approaches, they have a probability of, 80% to estimate a face correctly in a window of 1 or 2 years. So that is not a lot, right? It means that a lot of people will be estimated as being much older than they actually are, and a lot of people will have to wait 1.5 years till they can actually access that site that they should have access to. So those are issues. And of course, that's for the general population. For some people with specific facial features, it doesn't work at all. If we look at the electronic ID cards, they have similar issues. Not everyone in Belgium has a Belgian ID card. I would imagine that many people in this room here do not actually have a Belgian ID card and couldn't authenticate, couldn't do an age test for a Belgian website under these conditions. And then, of course, if we build these things into infrastructures, in the end, your healthcare provider might want to do an age check, your housing agency or whatever want to use it too. What happens when these systems actually fail? So how do we build resilience into our society and do not come completely dependent on layers and layers of kind of shaky technology? And those are really interesting questions that we want to work on that intersect very strongly with questions of sustainability, of whether AI can be green, but also whether AI can be useful for people and can be accepted by people in all these different application scenarios. Now, I wanted to talk more about this, a citation from Amy van Bunsberger, who tried to define these different notions of green AI and AI for green. We've already heard a lot about this, so I skipped this part. What I want to show you is how much AI you actually need to do different things and how much AI you need to do some other specific things. And here you see like this chart that talks about flops, floating point operations, that are the measure of how much compute you need to train, for example, a specific model. And you see there on top is ChatGPT 4, so this is already 2 years old or something like that. But we are talking about 10 billion petaflops here. So that's 10 billion times 100 million billions floating point operation. So this is something we can't really estimate, right? But we know from OpenAI and the companies behind these big models that apparently training a multimodal model like GPT-4 has been costing 35 to 60 million euros. That's the landmark we can put on it. Now, if we look, AI is not new, right? It's not just something that is very prominent through these specific multimodal models that we can use to generate memes and text and code and whatever. If we look at other models, AI has been used for decades in the domain of biology and medicine and healthcare, for example. We see that there's also a whole bunch of large models, but they are at the scale of like 100 million flops rather than 10 billion. And that makes a huge difference. That makes a difference from something that costs up here 35 to 60 million euros to train to something that, with all the efficiency gains on modern GPUs and all the things that NVIDIA has been doing, every one of you can do at home. So it will still cost 3,500–4,000 euros or something like that to train the biggest models that we've seen in medicine and in biology that do protein folding or cancer prediction or something like that. But I assume that most people in the room will have the financial capacity to actually do something like this at home. And I think that's super interesting. That points to a clear distinction between the capabilities and usefulness of models and what we can use them for and what their environmental impact possibly would be. I mean, it's very hard to translate those dollars or euros directly into carbon emissions or something like that, but it's certainly an indication of how much infrastructure, how much electricity, how much cooling you would actually need to do that. And of course, when we look at the whole AI market, we see that there is a strong prediction for growth. We see that there is like a market size 2024 of 184 billion, tendency increasing to 826 billion by 2030. And we've also probably all still have that quote from Sam Altman in mind from a year and a half back, where he was asking for $7 trillion investment in AI infrastructure. $7 trillion of AI infrastructure is quite something substantial. I think OpenAI has been rolling back from that quite dramatically in the last couple of years, but it means an investment of basically 10% of the global GDP. And in that sense, the first speaker of the day is totally right. So this investment is much bigger than anything we've seen before, much bigger than railroads, much bigger than all kinds of big infrastructural projects that we have been seeing before. And if you think about like what else would society invest 10% or 20% of the global GDP in, that's basically food production and housing and things like that. So things that really everyone needs at a large scale that have that much of an impact in money and also in environmental resulting impacts that is comparable with this kind of an investment. And then, of course, we already see these issues with transparencies that have been mentioned before by several of the speakers, that it's often very difficult to actually understand how much resources go into a specific product, into a specific model, that there is a lot of underreporting, there is a lot of unclarity, a lot of secrecy about what is going into these models and how we can actually do impact assessment in this context. But the scale of the investment is still absolutely dramatic. And when in the past couple of years, we used to use pictures of copper mines or coal mines to illustrate the impact of our industrial development, I think then this is now what we could probably look at, because it's in terms of size kind of equal and it looks quite dramatic, and it's 500 billion investment in a specific data center. So these things are massive. These things cost an enormous amount of resources. And if we look into what populations say about them, we see dramatic growth of data centers in Belgium. We see dramatic growth of data centers in the Netherlands and in many other countries. We had this issue before that in Italy, you can get a permit in 2 months, and in Belgium, it takes a few years maybe. You also see that more and more countries try to regulate against the proliferation of data centers, simply because, for example, in Amsterdam or in Brussels, it is very, very difficult to get your household connected to electricity if there's a data center somewhere nearby. So households and schools will have to wait for months and months, sometimes years, before they get connected, because there is a serious risk for the local government to get sued. And of course, they do not want to take this risk against a company that is capable of paying a lot. So we have real issues. We have real issues of people not feeling heard, not feeling able to interact with the processes that lead to this proliferation of data centers. And that's something really interesting, I think, because we know already for many, many years that our resource consumption is far beyond the carrying capacity of the planet. I mean, this is not from the IPCC report. This is from a paper from 2 years ago that was talking about classifying chemical pollution, novel entities. And what you see here is that we should be somewhere here in this part of the donut, while our actual consumption, specifically with respect to biosphere integrity or nitrogen and phosphorus flows, is like 3-4 times outside of the actual carrying capacity of the Earth, in particular in Europe and in industrial developed parts of the world. We also know from the IPCC reports, they have been cited over and over, that we need immediate action to mitigate these things. But in practice, what is happening is that we are talking about whether we need green AI or AI for green. And I think this is kind of disturbing sometimes, because it takes agency away from the people who need to work with this donut, who might be able to understand that we have a limited number of resources available and that we need to make policies that somehow share what's inside this donut fairly across many, many different domains. And of course, there is food production and housing and education and healthcare and many other things much more important than building data centers. And I'm not saying that we do not need data centers, but I feel that what we really need are strong, deliberate, democratic processes that make sure that everyone gets involved and gets a chance to interact and is heard and understands what we need these infrastructures for and why I have to wait 5 years to get my house connected to the electricity grid while the data center is operating already for a couple of years. So I think these are amongst the most interesting questions. If you want to read an academic paper, I like this one a lot, which talks about environmental justice, environmental ethics for algorithms. And I think a lot of it actually applies for infrastructure as well. But where I want to close is really this question that has been raised before from a participatory democracy perspective, like how do we design processes that keep people involved and that allow us to make very deliberate, difficult decisions about how we share this donut, how we make sure that we build enough hospitals and schools while figuring out how much AI actually fits in. Thank you.
Thank you a lot, Jan Tobias. I think you managed to underscore the seriousness of the sustainability issues. And now we'll have a panel discussion with all the speakers, and I'll try to perhaps bring a microphone with me, if that's possible. Are there enough microphones for everyone? There should be, yeah. There is one extra. Okay, so first of all, thank you for all the presentations. I think we got a very interesting backdrop to this session with this morning's keynote, which was also about sustainability and AI. And now we've heard different perspective from law and ethics and about indirect impacts, about how we define and understand sustainability, and how about some of the serious issues of limits and planetary boundaries. I want to start with one question where we can go around robin, try to answer in 1 or 2 sentences about what you think the biggest blind spot in the mainstream discussion around the sustainability of AI right now. We can start at this end, Marta.
Yeah, thank you. You hear me? No? Yeah, okay. So yeah, in the mainstream discussion, I would say that the direct impact is quite well. I mean, people are aware about it. I mean, even people out of the science or engineering, they know about it, they hear about it. And I think the indirect impact is really something that is overlooked. And as I said, where we don't have order of magnitudes, and people don't have this idea in the mainstream discussion. So I think it's the biggest blind spot.
Thanks, Alexandra. Oh.
Yes, perfect.
Yes, there we go.
Maybe one element I would point out, and I think that's something I missed during my presentation, is the fact that we mainly focus on energy and water as, let's say, the main elements being involved in considerations on the environmental impact of AI, and we fail to look at waste, electric waste, how mining happens, where it happens. NVIDIA was the best example for that, as well as land grabbing, what happens with the land that, you need to take from local populations and construct the data centers at. And then maybe one thing that is really, really not seen is emissions based on like noise and heat considerations. So how it is to live actually next to a data center. And then apart from the material, let's say, side, one point I would like to reiterate is essentially where the decision-making lies, who is getting to be heard and who is not in this process.
Yeah, thank you. Yeah, environmental impact is more than carbon, basically, and especially about the waste is also an important aspect. Nikki.
Yeah, I would say that the main challenge or the main blind spot is let's say, resulting from fragmentation, and whether that is a fragmented policy landscape, right? Or a fragmented understanding of responsibility, right? Like who's responsible for what aspects of sustainability across an integrated supply chain or life cycle. And a fragmentation in terms of understanding what sustainability means, right? So overall, I think we really need systems thinking. As a sociologist, that makes sense to me to think about the full system, the full socio-technical system, the full social system. Yeah, so that's what I think.
Thank you. And Jan Tobias.
I think as a computer scientist, the main sustainability challenge that people around me seem to have is that they do not have enough tokens. But from the more hard sustainability perspective, I think there are many, many legal issues that often city councils are completely torn between following their own rules or not admitting more data centers, while some data center that was admitted like 5 or 6 years ago for another operator where the land was sold 10 times in between now still needs to be built because city councils are afraid of legal cases and being sued for billions and billions. And I think there is a lot of uncertainty where probably cities would want to have stronger rules to protect their citizens, and that is not happening because of legislative and uncertainty issues.
Yeah, and when we're talking about legal issues, perhaps we could dive a little bit more into the regulatory aspects. So, Alexander, you touched upon this in your talk, but in your view, what is the weakest point in the European regulation as it is now?
The softness of the rules, I would say, for sure, because we've had a long-standing debate on whether we have the data from companies, essentially from data centers operations. Why don't we have them? So confidentiality claims were also a problem, and we saw that that was a scandal that broke out some time ago. And what this leads to essentially is a delay in actually regulating the question. So we say, oh, we need more data in order to regulate, but then we don't really disclose them. And so the people don't know. And then the commission will also say, well, I cannot regulate efficiently and effectively. So this leads to, let's say, a vicious circle of, essentially delaying regulation.
Yeah, I see. And perhaps the others can pitch in as well, but what given these weaknesses, is regulation even the most effective lever or approach for dealing with some of these issues? Or do we have any other effective measures for handling these massive impacts? Do you see anything, or you could also pitch in?
Yeah, I would just echo what Alexandra said. And, the phrase that came to mind when you were presenting earlier was like, there's no teeth, right? When you say they're soft, right? The regulations that we have in place, whichever of them, but the AI Act and specifically, there's no teeth. And it really strikes me that when it's simply asking for transparency of what the environmental impact of the computational side of the model is, right? I don't understand why that's where we're at, because we have such an advanced state of the art in green AI as we have developed within this project, right? Why is there this disconnect between the state of the art and what's actually put into a policy that should regulate a space, right? We could do a lot more than say you have to be transparent. We can already have indicators and metrics, right? And personally, I mean, I think regulation is important and has a very, very important role to play, but it has to do something. It can't just sort of virtue signal, right? It has to have teeth. It has to hold actors accountable. That's what a regulation is. Otherwise, it's just window dressing.
What I would like to point out, though, is that this is a problem that we have in environmental law for years. So essentially, there is a lot of criticism, let's say, expressed against the fact that we always just need the information, and that's essentially the EU legislation is not imposing any limits, which is not true, because we have in other, let's say, environmental legislation texts, legislative texts, we have, let's say, limits, and that's what I guess should be the case right now. But maybe then the discussion would be more political than legal, because we have the instruments to achieve what we want to achieve, but what is lacking is political will to go towards that direction.
Yeah, that's a good point. And I also wanted to pick up on this regarding the metrics and how we measure, well, we had the direct impacts, but Magda, you talked a lot about indirect impacts, and you gave a very good overview and a framework for how we can understand the indirect impacts and benefits as well. Do you think there is a potential for using this kind of thinking or a framework to actually help us reduce the environmental impact of AI, both direct and indirect? Is it possible to operationalize it in any way, or do you see some potential there?
Yeah, I think it's you have, like, the framework can be applied already just on the way you are acting, and that can be applied at different level. I mean, it's mostly a way of thinking in the systemic approach, and taking into account this, positive indirect impact and so on, negative impacts. And I think this is something that can be applied at different level of decision maker. Like you can apply this in policies. You can apply this also for every citizen, in having this kind of mindset of like trying to be responsible in how our behavior can also impact things, and have this indirect thinking also. And this can also be applied in companies, trying to have the business model that is not in contradiction with this kind of thinking, and not wait for regulation to take actions also, because if you get to a point where your business model has been defined for years in contradiction with those objectives, of course, it will be harder to implement after. And so I think this systematic approach can be applied at different levels, and all the three parties, the citizens, policymakers, and corporates can imply it in their processes.
Yeah. You also mentioned Jevons paradox, for example, and the let's say the limitation of only addressing energy efficiency. So even though we make AI applications that's supposed to be more efficient, it often drives just more overall use. Do you think there's any point in chasing more efficiency if we don't also address these systemic issues? I know several of you have sort of mentioned this. Do you have any viewpoints there across the panel?
I think maybe first thing interesting is to look at one of the reports that was published by the World Inequality Lab a few weeks ago, where they did a plan, in fact, for so it was equity and sustainable development for the societies, and they show in this plan toward that that would be defined within the planetary boundaries, and they show in this plan that there would be a path in which we need responsibility from sobriety, and we need efficiency, of course, and both working together, because otherwise we would not be able to get to the goals that they set. And so in this idea, I think efficiency is, of course, very important, but it has to come along with sobriety. And then the question is, how do you implement, how do you push efficiency if there is no this automatic way of gaining money after, by just increasing the usage of the technology? And this is really a big question that we have to think about, and to see how sobriety can be imposed and also have efficiency that is still improving.
Yep.
I would just have a wordplay here, not about efficiency, but about sufficiency, because one other question that I think more or less all of us brought up, let's say, is why are we developing AI? For what purposes? For what objectives? So yes, to energy efficiency, but more to sufficiency and clarity on what are the societal goals that we want to achieve on a collective level.
Yeah, very easy.
That's great. And I would add to that scale, right? So if you have efficiency is great, but as we know, if you're deploying at the kind of insane scale that OpenAI or Anthropic are deploying, or Google or Amazon are deploying, then there's no way to really cut down that impact, right? Like it's not just about the carbon if you're, say, carbon neutral with your energy grid, but biodiversity loss and building these huge data centers, for example. So efficiency is important, but we know there's such a huge difference between small models, right? Small localized models and these large scale, massive ones that no matter how efficient they are, the scale of use is going to make them unsustainable.
Jan Tobias, did I see you have a comment as well? Or?
Thank you. Well, I think if you look at national and European environmental policy over the last, 30 years or something like that, you see that we have been very good at regulating industries that pollute locally. We have been extremely good at regulating industries like a chemical factory or refinery, steelworks or something like that, that pollute locally. With AI, the situation is very different because the materials are not produced locally, and the only thing that we can measure locally is carbon impacts and water. That's why we focus on them, because they're easy to measure, although if you look at my donut slide, they are not the most important ones we should actually focus on, but they're easy to measure, and they are the local impacts that we actually see, while the production, the disposal, the mining all happens somewhere else. And I think because we depend on industries to do reporting to tell us what those impacts are, and a lot of that fails dramatically, we tend to only look at those two specific impact classes, and that's simply not enough for the scale of the problem that we are seeing here.
Yeah. Very good point. I look at the time and I see we have to close off soon. I have many more questions I would like to ask, but one final one that you'll each get to answer is, if you could change one thing to make AI more sustainable, whether it's a rule, a practice, or an assumption, or something else, what would it be? We'll start here again.
Yeah, it's a very interesting question. And I think I would relate to what was said before, and also to what Bernie Sanders usually says in his interview, is that the current development of AI, its infrastructure, and the ownership of the models is actually in the end of a very small group of wealthy people. And it has a huge impact. This strategic technology has a huge impact on every aspect of our life. And I think that in education, access to information, economics, and so on. And so I think that this kind of strategic technology should come back to the people, and we should have an informed public debate on the adequate place we want to give to AI technology. And that relates to what was already said before.
Yeah, thank you, Alexandra.
Of course, I would not omit by referring to some concepts that were vaguely mentioned, namely environmental justice and social justice. So essentially a reinforcement of ethical considerations when we are talking about AI infrastructure and development, and of course, them being embedded more consciously, not only let's say imposed as an obligation by a regulation, but also on a collective level by the stakeholders, right? Because we also look at regulation as the savior that is going to, let's say, bring all the solutions, and regulations, is the one key tool to have a solution actually at the problem. But we fail to look at the responsibility that is let's say at the hands of each one of us as stakeholders, let it be a huge big tech company or as academics, let's say.
Very good. Yeah, Nikki.
Thanks. So I will add to this systems thinking. So understanding socio-technical systems as integrated systems, understanding AI is situated within social systems, economic systems. So looking for the big picture and less siloing.
Jan Tobias?
I have nothing more to add. Thank you.
I'm sorry I put you in the last spot again, so I'm sorry about that. But to round off, I want to thank you all both for your presentations, for your excellent answers in this panel discussion. I would, as I mentioned, love to discuss for several more hours, but we have to stop here. To the audience, I hope that this session contributed to a deeper understanding of sustainable AI and what could be potential solutions or directions, and perhaps most important, that sustainability needs to be more than an afterthought, and that we have these very real costs that are very often very unevenly distributed, and that is something we need to address. So with that, I wish you all a great day and have a nice lunch. Thank you.
Okay, welcome back, everyone, and I hope that you enjoyed the lunch and had the nice talk and networking. So for this session, we have the topic is on from principles to practice, assessing trustworthy and sustainable AI in industry. And yes, the floor is to yours, Francisco.
Thank you. Hello, everyone. Thank you for being here, even if it's after lunchtime. So I'm François Picard. I'm working at the Danish Technological Institute, which is one of the ENFIELD partners. And today we are going to talk about sustainability and trustworthiness assessment. As we push AI from the research labs into critical infrastructures and industry, we are facing a dual challenge. We must ensure that AI is trustworthy, and we must prove that it is sustainable. So today, I've got 4 great speakers that are going to talk about that. And we are going to move from high-level concepts to code, operations, practical frameworks to indeed assess sustainability and trustworthy. So this is a journey. So we are going to talk about different things. The first step is going to be about the environmental footprint of AI hardware. And today I have our first speaker, who is Amael Paroai, who is the CEO of Resilio in Switzerland. Resilio is developing solutions to assess the environmental footprint of IT. And Amael is leading efforts to shift this perspective to the provider side. Instead of pure guesswork, we are talking about providers. And so he's going to tell us how to demystify the AI environmental footprint through LCA, through lifecycle assessment, based on provider data, and what Resilio is doing to make this data actionable, available for industry. So please, Amael, welcome. The floor is yours.
Great. Thanks. I'm given the hard job to be the first after lunch, so I hope you won't fall asleep. Does it work? Yes, here we go. So I should say hi and say who I am. My name is Amael. I'm Chief Executive Officer at Resilio. And as I've just been introduced, we are a Swiss startup based out of the EPFL, the Swiss Federal Institute of Technology in Lausanne. And over the last 4 years, we've run from a nice Swiss startup to a European company, really trying to work with the bigger technology provider, although we don't have so much in Europe. And now we're expanding towards the US and the larger US players. And you'll see this as an interest in the project we're talking about today. Our vision is really to reduce the footprint of technologies. So we really want to make sure tech people can understand and really take action from a sustainability perspective. If there is one thing you need to remind from us, that's definitely it. And we are about like 30-ish people, mostly based in Lausanne, Switzerland. So we like to say we deliver an ecosystem of solutions. It's all going to make sense because the key challenge, we believe, for technical people is to get the environmental data, environmental assessment right, fast enough, make sure they can collaborate one with another, and that they can reduce the environmental footprint at the end. So making sure they got the data well enough and they take action. I won't spend so much time here, just to say we provide both software and services. So we are for a limited profit company. We have a bunch of software and a lab team, which is the one I'll speak right here. So I think it's pretty straightforward for everyone that AI is now the big thing in tech, at least over the last years. We're pouring a lot of money in it. It looks like a lot of people are using it more and more. And in the meantime, it happens that climate change, it really is a fact. I mean, we're going into the next heat wave for the next days which are coming. So we all gonna feel that climate is changing right now. And there is a legitimate question of, is this the right kind of technology that we want to implement? So first thing that scientists do is looking for the numbers. And unfortunately, we don't have much numbers. If you just look at the few pictures I took here for the average, which once is an average query, once in an average prompt, and then it's an average page of text, we have orders of magnitudes in the difference in the numbers. So the very few numbers out there are perfectly inconsistent. We just cannot deal with it. On the other side, we also have existing software, mainly open source tools. I'm speaking about the AI Energy Score and the Ecologits, which are open platform that everyone can use. They're transparent, but unfortunately, they're coming from the research. So they have absolutely no clue or very limited evidence about how it is running on the industry side. And this is where we got onto a challenge. So we have fragmented data. We have closed source model on which we have even very few data. And all of this is moving fast and fast. Just to make things more complex, we're fragmenting the information across the AI supply chain from the hardware, the clouders, the models providers, and the one that actually run it. And over all this scattered chain, what we want to know is where is the direction we need to go. So what is polluting more, what is polluting less, and what do we want to change? To solve this challenge, we believe we need to now fix some methodological issues. And we also believe we need to get to catch up on the speed and get the industrial player participating into this challenge. There is a lot of important question we should address. Is token the right way to assess the environmental footprint? Should we speak about efficiency in terms of energy, in terms of flops? All of these are methodology questions that we want to address. And currently, they're either scattered, inconsistent in the industry, or open, consistent, but missing industry data on research side. So what we are building is a project that really enables provider-side assessment, where we want to get the industry players, and I'm here speaking also about the biggest one, the hyperscalers and the like, to get them provide some relevant data we could use. So to be conscious of time, I'll be quite fast here. We want to make sure we have a common life cycle assessment methodology that can be used on the provider side, so that the Google, Gemini, the OpenAI, Salesforce, SAPs, and others could apply, where we would basically take a big picture of all the infrastructure they have, so all the servers, the data centers, the energy that goes in, and then we'll split it across the different customers. So it's not more complicated than this, except that first, gathering the full picture is very hard because supply chain is scattered. And second, we don't know what's the right knife. So we don't know if we need to split by token, by sessions, by anything else. And we have good reasons to believe token is not necessarily the best one. So based on those primary data, we're going to release research out of the aggregated footprint and averages. Up to now, we've been working with all the supply chain from the data center operators up to the AI application providers. So the guys that host the GPUs, run the GPUs, make the models, and run them. It's quite a lot of participants. And from actually March right to now in July, we've run the first batch with mainly European players. Think about Orange, Swisscom, Scaleway, Mistral, and the likes. The idea, and I just want to focus on this, is pretty simple. We take real values from the providers and we perform a top-down approach. Not that it is the best approach, but at least it gives us a baseline for any bottom-up modeling that we would like to have. So there is a shit ton of good research out there with bottom-up and a ton of assumption. And we want to make sure that if we make it top-down, we kind of match and converge somewhere. So this is infrastructure data, usage data, the amount of GPU hours, is that the right key, is that the flops, the trainings, the values, and also making sure we have enough different models covered. The project is running and we're making work. So we're using both internal and external resources. As I mentioned, the final objective is to get aggregated value. This is the average footprint of an LLM. This is a good methodology to assess it. And this is the average result that we've seen over the industry. I'm not promising you're going to have the private results from Google. Unfortunately, this is out of my control. But what we are doing is offering LCA and critical review to them. And then, of course, encouraging them to provide the data in return publicly. As soon as we have a benchmark, half of the participants are below the benchmark, so they have an interest in disclosing their data. And once half of the market disclose the data, the other half is kind of required to do so. So that's the basic theory of change we hope to enable. And to do that, we will contribute to the existing software such as Ecologits to make sure that the outcomes could be used by a wider audience. We have a lot of research in. I'm not going to go into the details because I need to stick to the time. So last big part, what to expect and by when. As I mentioned, we've been working with quite a lot of companies up to now. The customers that just sit to the table and say, dear providers, we want data, we need it. So putting some commercial pressures, some academics, of course, mainly from Switzerland as of step one. And there, I'm calling on you because we need additional research partners for the upcoming batch 2. And the public sector, because we also want government and regulators to be properly informed for what comes next. We've been working mainly with European players, and that's where the next thing is coming. We're working with the hyperscalers and the American giant to make sure that by the second part of 2026, we could onboard them into this this project. And last but not least, this is where all of this is going. We are making the results on our way towards the Geneva AI Summit. So it's the big AI gathering yearly. Next time is in Geneva, Switzerland. So we're playing home. We hope to be able to deliver the first batch and second batch by that time. We have a bit less than 1 year to go. As I mentioned, the objective is to say, hey, this is the environmental footprint of AI. This is how we can best assess it. These are methodology opportunities or simplified formulas that we can use, building on what have been done so far and providing information from the industry, both in European size players and giant or larger player. In the background, Resilio is also working at the other side of the supply chain on the semiconductor footprint because we use the latest technology nodes for hardware, and we have basically no clue on what's the footprint of those things. So we're putting some fancy new, the NVIDIA guys are putting some fancy new metals in the graphic cards, and we have no clue how much this pollutes. So we have troubles at the two sides of the supply chain. And this is where I can call on you, and that will be my last slide. I know I'm addressing mostly researchers here. So this is a call for all of you to take your phone and take a picture if you think this is making sense. We're looking for research partners to help us getting the papers in line, making sure we can thrive and build on this work. I put my email address on purpose so that you could send me an email afterward or find me before the end of the day. The first paper will be released probably by the end of the summer, and we would like to have at least 1 or 2 other before we release at the Geneva AI Summit next year. And that's it. I think I'm quite on time. Thank you.
Thank you, Amael. I think it's a great opportunity. I'm sure many people are going to be very interested in that. So we talked about sustainability assessment, and we have a better understanding about how do we assess AI hardware. So now the next question would be, how do we build trustworthy, engineer trustworthy AI systems? And to tell you about that, I would like to invite Nicolas Rébière, who is the president of the European Trustworthy AI Association, a non-profit association providing open source tools and methodology to indeed build a trustworthy AI system. And Nicolas is going to talk about the W-shaped engineering methodology and tools developed by the association and supporting developers to design and implement trustworthy AI.
All right. Thank you very much for the introduction and the invitation. I'm really happy to be with you this afternoon. And so let's get right into the content and dive into this association. So today is the final event for the ENFIELD project. And of course, it's a very important moment for all the stakeholders in the project. You've been doing great research for years, and now you've got all these assets, etc. And that's precisely the situation where the ecosystem of this association was back in 2024. Actually, this association is a result of 4 years of research that was held primarily in France, and the program that was called Confiance.ai. So maybe some of you have heard of it. And it was really an industrial research program where leading industry companies in aerospace, manufacturing, defense, services have bound together, and also with, of course, the research, let's say, players, to work on trustworthy AI. What does it mean to have trustworthy AI in our system? We all see the potential, we all see the benefits of AI, but of course, this is raising a lot of new questions. How do you evaluate the system? How can your quality department, let's say, check that it's ready to go on the market, etc.? So they had collectively this problem on how to be able to measure and to assess trustworthy AI. They've been working on this for 4 years, and all this program has really been driven by industrial use case. So they all came with real specific concrete example on where they would like to introduce AI into their systems and what were the barriers and the trust barriers before they could really ship it and put it on the market, or in some case, just apply internally. Because of course, what we have discovered is that AI is of course introduced into the products that they are shipping, but AI is also used a lot in the transformation on their own business, on their own internal processes. And here it's the same. So if you are starting to use AI models to automate the inspection of quality of some of your PCs that you are building in a manufacturing process, for instance, how reliable is that? What is the risk that you are taking if you rely on the judgment of a model instead of the judgment of an expert, etc. So they have been working on research, and at the end of the program, so 4 years of research, came the question, what do we do with the results? Now we would like to scale the usage of what has been produced. The main the main results are methodology and tooling. So how do we make sure that this is actually usable by all our colleagues in engineering, and that they have, let's say, good resources to apply to transform their engineering process and to have dependable tools that they can really use on a daily basis. And let's say the result of that reflection of the consortium at that time was, okay, let's create an open source foundation. We are going to take all the results coming from research, and we are going to invest. So keep investing in this portfolio to maintain it, to rise the quality at a level where it's really dependable, where we know that engineers, they are going to be able to use these tools without losing their time. They are going to be able to use these tools with the size of the data that is meaningful in their environment. And for that, of course, this demands some work. And there was this idea to create this association. So here it is, European Trustworthy Association. So it's a non-profit. It's established in Brussels. One of the goals for that was really also to enter into the next phase with the scaling of the adoption of the methodology and the tools. So the research was primarily driven in France at the beginning, but of course, all the companies that were part of it, they are global companies. They operate everywhere in Europe and beyond. And they really want all this methodology to be used, to be applicable across Europe, across all the region where they operate. And they decided that the right, let's say, scale to continue to develop this body of knowledge and this research was Europe. So we created it in Brussels. Its goal is really geared towards enterprise and industry. So everything that this association is doing is about empowering engineers to build trustworthy AI systems, and they are providing us really the North Star. So all the work of this association needs to help them apply concretely methodology, and we spend a lot of time and a lot of energy to really understand how they work and how they need to transform their own process, their own operation. We do the last miles so it really is, let's say, usable by engineers in the field. And so what we provide concretely, it's open source methodology, open source tools that they can apply for the engineering task. So the association has many, let's say, activities. First one is we are developing the ecosystem. So of course, we started with all the ecosystem from the research. Like today, you have an ecosystem from a research project. So we started from there, but then we continue to expand to have all the community interested in developing further trustworthy AI. Then we are building a set of reliable tools. What we mean by reliable is, I mentioned already quality, I mentioned performance, but there are other properties that are really important for industrial companies for them to accept to depend on tools and technology. Some of it is typically compliance. So industrial companies, they are comfortable with some open source license, and they are not comfortable with some other open source license. And another example is export controls. And many of the companies that we work with in this association, actually the founders of this association, are working in the defense sector. And for them, they just cannot tolerate to be exposed to ITAR. So they need to have ITAR-free open source. This is exactly what they want. So that means software tools that are not limited by export controls. Expertise and support. So that's really important as well as we're transitioning in the deployment phase of all the results from research. So during the research phase, what we have working with us usually is the corporate research center. So there are researchers inside the industrial company, and they know how to do research, and they are very subject matter experts of trustworthy AI. But then in the next phase, we are transitioning to engineers who have their own skill set. And the first thing they need actually is training, is to discover all the resources that are available to them. And so for that, the association has a lot of activity on making the results approachable, usable, and organizing the development of skills. The last point also is very important. We participate in all the standardization activities around trustworthy AI. So right now with the Sensenelec and all the trustworthiness framework, for instance, to make sure that the results that we have created are lasting, and that essentially the company who bet on the taxonomy, the ontologies, the methodologies that we have created together, they made the right bet, and that it is, let's say, well aligned with emerging and future standards. So we are also heavily invested in standardization. Okay, so that was a short introduction to the association. Now more into the, let's say, subject matter, what really is our portfolio. So what you see on the left is what we call it the W methodology. So it's an end-to-end engineering process. that starts from the intended purpose of the system, then describes what we call the ODD. So it's a concept taken from the automotive industry. It stands for operational design domain. And essentially, it's a specification of all the operating conditions where the system is expected to behave properly and to perform. So we have to model that. And this really serves as input and is used across all the full engineering life cycle of the product. Maybe you recognize a bit the shape of it. So of course, it's derived from the V cycle. So I have learned the V cycle at school. Many of you probably have as well. The W is actually coming from an evolution of the V cycle that was introduced in the aerospace industry already. What we have done in this research program is that for each of the phase, we have been looking at, okay, what do we need to add? Where do we need to enrich existing processes so that it can handle AI, essentially. And we have introduced new concepts, new roles, new activities to be able to manage AI. And one thing we have added on the right, and that is specific to AI, is what happens after the product is ready, is a GA, as we say in industry. When it's going into the market, into the field, it's not the end of the story. You have to monitor it. You have to make sure that the operating condition really reflect the training condition. And that phase is super important for the AI products. On the right of the slide, you can see some examples of the tools that we have in the portfolio. So everything is open source. If you go on the website, you should be able to find all these resources. These are just a couple examples on the dimensions of trustworthy AI. So the one on the top is about robustness. And this is a use case coming from the automotive industry, where they wanted to automate the inspection of welding on a car. As this is deployed in a real factory, usually there are some vibration and the camera is moving, and this is introducing some motion blur. And they wanted to check if the AI model was robust enough, or how far was the model robust enough, depending on the level of blur. So that's an example of tool to measure the robustness of an AI system. At the bottom left, you see an example of explainability. So here it's more classic. It's heat maps that helps you, or that helps the data engineer or AI engineer see what the model is paying attention to. And that can help define if we have the right data set, enough data, etc. And on the bottom right is an example of uncertainty quantification. So this one is particularly interesting, is that in addition to just having a point prediction by a model, it will give you a range of uncertainty. And with that range, you can do many things. So if you are still in the development phase, you can decide that, okay, I don't have enough data in this range of use, and maybe I need to continue my training, etc., acquire more data. So that's more in the design phase. But when the system is already in the field, what you can do with that is you can have systems that handle uncertainty at system level. And that means that maybe you don't do anything at the AI level, but the system is able to detect that it has high level of uncertainty, and then it can maybe hand over to the user to take a decision, or it can maybe put himself in a safe mode, or maybe it can just wait, because in some situation, that's one possibility. Okay, so that's just a couple examples so you can see the kind of resource that we are putting together to really help engineers acquire the skill and apply AI into their own systems. And now, I don't know how much time I have left, but I will go quickly on this one just to explain that the approach that we have taken is really meant to scale. So as explained, what I've presented is essentially the result of the initial research that was led in France. But now we want to really scale across Europe. And we are building a process where we can integrate assets coming from other projects, so exactly like ENFIELD. And so we are going to review all the assets that are coming from our international ecosystem of scientists. And they come with a methodological proposal, or they come with tools. So we have a process where we can review these assets together with industry. So where you see CCB, it's called Change Control Board. So this is a body in the association that is led by industrial companies. They are going to assess the asset that come in and decide if they want to introduce in the portfolio. And from there, so if it's going into the integration phase, usually there is some initial investment that is needed to raise the bar in terms of quality, so documentation, test plans, so everything that you have not done in the research phase, probably, but that is required to use. So that's the first initial investment, this integration. And then you've got the loop. And the loop is really where you put the tool into the hand of the practitioner, and they are probably going to want some improvement. You also are going to get some feedback from practitioners, and many methodologies, like in software, etc., they have been iterated and improved through the feedback of practitioners. And so this is this loop that is happening on the right. And you've got some plain maintenance work that you need to do on software. So a software that is not maintained just dies. And I think we had this discussion earlier in the morning that we need the Red Hat of AI to maintain AI stuff. So this is exactly it. And actually, that's one of the first requirements I came from the VP of engineering at one of our industrial funding companies. And he was saying, I want the number of the guy I can call if the tool is not working and my R&D is blocked. And that's one of their primary requirements, is that to be really able to use all these resources, you need to have a process in place where they are going to be maintained. So that's, in a nutshell, the introduction of the company, the association, and an invitation for you to participate if you're interested. So we are really looking forward to hearing from all the research that you've been doing in the trustworthy AI space and see if that would make sense to participate in this funnel. That's it.
Thank you, Nicolas. I think as well a nice opportunity for us to move forward after the projects, especially. Okay, we have the tools, we have the engineering methods. Now we have to scale them in the company, and generally can collide with compliance. And our first speaker is indeed going to talk about that. I'm going to invite Alexander Machado, who is the team of the trustworthy AI, the head of the trustworthy AI team at Applied AI in Germany. And it's going to talk about how organizations translate regulation, such as the AI Act, into production-ready AI governance structure.
Thank you so much for the kind introduction. And I think you can see all my slides now because we're at the end. So I'm coming to the first slide. Perfect. No worries. All good. Okay, yeah, so welcome to the talk about challenges and best practices for implementing the EU AI Act. I'm going to cover more the practitioner's perspective. So Apply AI, we're a consulting company, consulting large companies in Germany like Siemens, Infineon, Linde, etc. And basically, I'm leading one of the working groups that is named AI Act Governance. And the focus of the working group was to understand the key challenges on these big companies on how to implement the EU AI Act, but also together try to come up with best practices, solutions, so that we can basically relieve those pains and be more effective and efficient by implementing the AI Act. So I'm going to start. I found the clicker, have it here. I'm going to start. I try not to make it too theoretical because this is basically a white paper of about 60 pages. But I'm going to try to tell the story, basically. So imagine we have now Lena. Basically, she's the new head of AI governance in a large corporation, let's say in Belgium. It's about 20,000 people. And the CEO basically tells her, Lena, we need you to comply with the EU AI Act. But at the same time, please make sure we are not slowing down innovation. And Lena is basically in her first weeks, first months of work, and she tries to see what exactly is already there, but what needs to be implemented, what is the delta. And she realizes she has to talk with a lot of departments along the whole company, and realizes that this is a very challenging task to orchestrate all these different departments. That means, in a nutshell, implementing the AI Act is no longer just a legal challenge, but it's basically an organizational challenge. So in this working group, we had different expert interviews, and we come up with top 3 challenges. Actually, there were like 20 challenges, but the top 3 were the following. Number 1, there is a lack of guidelines to implement the EU AI Act. So as we all know, there is a lot of different standards like ISO 42001, trustworthy AI principles, and so on. But many of these documents, they lack the component of operationalization. So how we can actually implement it in a simple way in our companies. So the first challenge is the lack of clear guidelines and also how to orchestrate them across all the teams in your company. The second one is the AI Act is a legal text. For example, in my case, I am an engineer, so I'm an electrical engineer, and when I read it, it's very confusing to translate it into technical requirements. So the second challenge was how to communicate from legal to technical and from technical to legal to make sure they comply with this regulation. That was the communication challenge. And on top of this, as we know, the AI Act is a legal text. It's going to be complemented by the harmonized standards with more details on how to implement it. But there have been quite delay. And actually many companies say, okay, what should we do? Should we just stop? Or is there something we can actually do today so that when these standards are ready, we can be faster? And we're going to talk about it in a bit. And the last one is what skill profiles, what roles, what responsibilities are necessary to implement the AI Act. So in the working group I mentioned before, we went through each of these challenges, and basically the results are a 60-page white paper that you can find on the QR code. But everything, we follow the design and thinking method of the double diamond approach, trying to understand the problem space, define the problems, but also try to understand how to solve it, and then put everything in a very simple framework. That is exactly what you can see in this screen. So at the end, we came up with a very simple framework of 3 layers that implement the EU AI Act. The first one is named the orchestration layer. It's very simple. The key goal is to set the regulatory strategy and what policies we want to implement regarding the EU AI Act. Typically, in this layer, you have roles like AI governance, data governance, and AI management taking place on this. So they set the direction of the policies. They also make sure they're implemented, and they evaluate its implementation and improve the process over time. The second layer is the integration layer. So they translate all these policies that are legal texts into technical requirements and then implement them into their infrastructure, into the processes, so that anybody in the other teams in the company can implement it. And that's exactly the third layer. That's the execution layer. So every time a new AI use case is developed or deployed, they need to basically follow all these guidelines and make sure to come up with the right documentation to comply with the EU AI Act. So in the next slide, you can see a bit more of details. So you can see an example. In the first layer, we can see the management setting up this regulatory strategy. For example, there are companies that are very immature in their AI journey, and for them, a quick win of only focusing on low-risk AI systems brings more benefit than trying to set up a very, let's say, bulky compliance process. On the other hand, when a company is more advanced, they tend to have a strategy where they said, okay, the first time we implement the high-risk requirements, it might take us a while, but I know for the second time and the third time, the time is going to be faster and faster until at some point, actually, it's just one more use case. And that's approach many large companies are also taking today. Then in the next layer, we have the governance expert translating the policies into processes and infrastructure so that basically they work together with the ML architects to encode all these policies as a code in different tools, platforms, could be open source tools, could be end-to-end tools. Like, for example, we did it with some tool providers in Germany. And at the end, basically, you see this cycle. It means you can also prove that these policies make sense with some feedback loops with the upper layers. And afterwards, the ML engineer at the use case level, they just execute those policies across the use case. They generate all the documentation, all the logs. Ideally, you will have some CI/CD pipeline tests where you have basically your first line of defense to make sure you have the necessary quality in place. Of course, in case that is not enough, you can also escalate to the previous layer for the AI governance experts just to ask if this information is correct, is enough. And sometimes some companies also prefer to have a third line of defense coming up to the highest layer before deploying to production. This is a typical approach on how we are implementing governance. So here we can see this with a simple example. So in case you're a high-risk AI system and you need to comply with 7 requirements, one of them is data and data governance. In a nutshell, you have to do 4 things. You have to document your data collection process, all the transformations that you do in your data. data quality and biases, and data provisioning. When we focus on the third one, data quality, in the AI Act, it says your data has to be free of error, representative, has proper statistical properties, completeness, relevancy, and so on. And the question is, okay, but how can we measure this? Is there any ways? Because the AI Act is very abstract. And that's exactly what we should do. Basically, I will mention in the next slide, you will have typically an AI governance team setting up these policies. Then you have the MLOps team translating it into more technical requirements. And the data science team is going to actually encode, measure how complete, how relevant, how many errors a data set can have, and create a data card report with that information that's going to be also, if necessary, passed in a feedback loop through all the other layers when necessary. So an example could be, let's say this is a use case for cardiovascular disease, where we set up for the metrics of completeness and relevancy, some acceptance criteria. We set for the first one, we need to have 100% complete data. But for the second one, at least 80% of the columns needs to be relevant for this given variable we want to predict. And at the end, in your pipeline, you can set up these thresholds and measure exactly by using some formulas how close you are to this data quality requirement or how far you are. So the good news is the harmonized standards are going to be based in existing ISO standards, for example, ISO 5257, where they have very well-defined formulas, how to compute completeness, how to compute relevancy. And basically, you can just pick those formulas from those standards, run it in your code, and you will get a number. And if the number is higher than the acceptance criteria, then you comply with that requirement. Otherwise, you didn't. That's just a practical example of how you can check compliance on the AI Act. Then we come to the third challenge, was about how to structure my company to comply with the AI Act. And that's, of course, is a very tricky question because some companies are very small. You have maybe 2 people, a startup. That means one person needs to have multiple hats. But you have also very large companies where you have maybe 1 person per hat. And what we define is a framework we named the ML Skill Profiles Framework. That's nothing else than hats or set of skills that companies need to implement regardless of their size. That means if you are small, 1 person or 2 will have a lot of hats. If you're big, you can even have 1 person or 1 team for each of these set of skills that you need. And the logic is the same as we mentioned before. In the orchestration layer, you have the management level designing the direction of the regulatory policy. AI and data governance, they do the oversight. The data architecture implements it with the ML architecture into the infrastructure. Data steward and AI steward make sure that all these policies are also implemented correctly in the infrastructure, and also they follow them across all the different agentic AI or AI use cases in the company. And the PO or product owner makes sure these policies are implemented in their use case, communicating with data engineers, analysts, ML engineers, data scientists, and so on. So this is a way how typically we recommend companies to implement the AI Act. Just now as a last slide, so keep it the time to 10 minutes. The key question at the end is what successful organizations are doing differently. Number 1, they translate regulation into a standardized, reusable governance process. You don't want to redefine the wheel 10 times in 10 teams. Just with 1 single process, having it reused across multiple teams is the fastest way to comply. Also, you need to have clear roles and responsibilities, not only on your team, but across your company. And an infrastructure layer, ideally, you need to embed all these policies as a code into AI platforms that support standardization, automation, and collaboration. Thank you so much for listening, and happy to listen to your questions in the panel.
Thank you, Alexander. I guess we can find all the publications on the website as well of Applied AI. Okay, so we have this whole range of, let's say, layers. We are missing the one from the perspective of people actually developing these tools to actually measure what trustworthiness is indeed. And so to do that, I would like to talk about that. I would like to call Paolo Giudici, who is the head of the Safe AI Lab at the University di Pavia in Italy. And is going to talk about all the metrics they are developing over there.
Thank you, Francois. It's a pleasure to be here with you. Much of all what I'm going to say has already been said. So I would like to start with something maybe a bit unusual or controversial. That is, I would like to say that the AI Act and the compliance is a very important topic, but let's say for the users of AI, we need also transparency. And so especially if companies that implement AI want to be successful, they need also to be, I believe in the future, to be transparent, to describe the metric, to describe quite precisely what is the advantage of using AI and the advantage of using AI of high quality, not just any AI. So this is the motivation of my talk. That is, it is a result of work that I've done in 2 European projects that I've been coordinating in the last 6-7 years, especially working with the regulators in the financial industry. So the whole idea is that, in a nutshell, being compliant is useful. It's not just legislative burden, but it is a win-win strategy. If I'm compliant, if I follow the AI Act, not just in a, let's say, compliant matter way, but also in a transparent way, I can also, improve my market size, my conditions. That is the idea of also that was discussed this morning of providing the appropriate incentives to companies to be compliant and safe. So this is the motivation. So the whole idea is to develop metrics that are transparent, but also credible. The credibility comes from the fact that these metrics are rooted in the mathematical language, which is often quite universal, and the other aspect comes from being useful. So where does SAFE come from? SAFE is a work that we are doing in collaboration with an international association. It is called IASAI, International Association for Safe and Ethical AI. It is based in California, but it is a worldwide association. I didn't put here the link to website. I'm sorry about it, but you can easily find it. It's iasai.org. And there you see, it's a very large non-profit organization that covers many institutions across the world, not just from Europe. Within that context, we developed this framework. It is called SAFE because it has 4 key components. Right. These 4 components, so the perspective is the perspective of the user, not of the company. So I repeat, compliance here means that user need to understand, like a bit like in the first talk about sustainability. So safe means that the provider or the deployer should provide 4 main outputs that I see as key risk drivers. They are not the ultimate risk, but they are the drivers of risk. So the one you see them, security, we know what it means, accuracy, fairness, explainability. These are 4 drivers of risk. So for example, if your AI system is not secure, it means that it may generate a risk of cyber attack, which may cause harm. If your AI system is not accurate, it means that there might be hallucinations, which may generate issues. So these are risk drivers. So now the idea is to be transparent, so measure these 4 quantities in a transparent way that is mathematically sound, but it can also be understood by theoretically anyone. So to do so, we use the simple idea of area under the curve. I'm sure you heard about area under the ROC curve. It's one of the most important metrics used in classification problems. We took this metric, we generalized it to all types of response variables, and we are still doing that, to text, to multimodal data. And this become the key metric. Become the key metric through the connection of area under the curve with the Gini index. Gini index is also well known. It is used in random the classification trees, random forests, and so on. It is connected with area under the curve. It is also a measure of inequality. Gini index was proposed in about 1 century ago to measure inequality in income. The idea here is to apply the same idea to inequality in the output. So the key idea is, apart from this a bit of mathematics, but now it's at 3 o'clock. I don't want to go into detail, but the key idea mathematically is to replace L2 loss, meaning mean square error that many people use, with L1 loss. L1 is the Gini index, basically. So you see above, the Gini index is the mean of the absolute values, is not the mean squares. So it's L1, not L2 in mathematical terms. Means that it can be used to also all types of variables. The key idea is here. The yellow line, yellow line describe the cumulative distribution of the output. In this simple example, we assume there is a ground truth. We don't have to, but just for clarification. So a ground truth could be, for example, the grades of students in a class, no? Grades accumulated from the lowest to the highest. That is a kind of ground truth, yellow. The green is the worst possible model, the model that ranks the children in opposite order. You know, the one that is best become last, the one that is last become best. That is the green. The area between green and yellow is the Gini index. Lawrence Zonodis was Max Lawrence that proposed. Our metric, so the red curve, is the cumulative distribution of the output in the ranks of the predictions. So if your model is correct, red line coincides with the yellow. If your model is very bad, red line coincides with the green. So the simple idea that anyone can understand is to do a ratio between the areas, no? The area between green and red over the total. This is called, is an extension of the area under the curve. It's called GA. We show that this measure is exactly equal to the area under the curve, but it can be calculated in general. All types of variables, ordinal, continuous, multimodal, whatever, and it is like R squared. You see there in the formula, R squared, you know, 1 minus ratio mean square error of the variance. You can calculate it only if your response is continuous, not if you have ordinal or binary or text. RGA has the same shape, but it's not the ratio of mean square over variance, but it's the ratio of Kramer distance over G. Same, no, same, it's a percentage, number between 0 and 1. So anyone understand that if security is 90% is good, if security is 20% is not good. But behind there is a mathematical model. Doing so, now we have a metric that speaks common language like the meter. No? In the metric system, the meter is the basis. No? You can use the meter and modify into kilometers or centimeters, but it's the meter. Yeah? It's not different things. It's not Shapley values combined with area under the curve combined with variance. It is the same measure. The same measure called percentage of Gini index that you can use to measure robustness, security, difference between predictions and perturbed predictions, to measure fairness, how different are the predictions for men, women, for white, non-white, fairness, to measure explainability, how much ESG, for example, impact your results, no? Same metric. And with this metric, you can do your calculation. We have a number of papers in which we applied, including one that we did with Francois and other people, in which we apply this metric to the problem in basically in computer vision. No? So in the different applications, you can use this metric. Here we use the metric to compare ChatGPT versus a bank. No? Here we assume that credit is given not by the bank, but by ChatGPT with a credit scoring model, ChatGPT-4. In the metric tell you that GPT is less accurate, but if you give ChatGPT some examples, it increased to 66, and it was also quite robust. Here is about decision-making, resilience of the model to perturbations. Apart from the technicalities, it shows you that some models are more resilient because their robustness remain higher for longer. They resist more to perturbations. Same you can do for explainability, but now there's very little time left. The main message is this table. In AI, we're used to measure the capability of the model in terms of performance, predictive performance. In this case, you will choose the most complex model, and we heard this morning from NVIDIA that we go towards models that are more and more complex, because the capability is better and better. But if we consider not only accuracy, but also security, explainability, sustainability, then the choice is different. Okay? And that is the compliance incorporated into your decision making. So compliance means business, if you want. And this can be, of course, done not only ex post, but can be implemented ex ante. So in the agentic system, we have this paper. We show that you can build the safety agent inside the machine. So there's an agent that check the different metrics. And yeah, there is more about, now we are try to add a fifth metric that is about computational efficiency. And we are testing that on quantum AI models, basically. But there is no time left, so thank you very much. Of course, I look forward to questions, but more important to interaction with you, because I truly believe that Europe has the potential to develop an AI of high quality, which is safe and which is good for compliance to the AI, but also for the growth of the business and for the growth of AI of high quality, not just of any AI. Thank you very much.
Thank you, Paolo. I'm sorry, I've been told that we don't have time for the panel discussion and questions from the audience. So thank you, everybody. Thank you for dear speakers to have been able to come here. And thank you for the audience to have been listening.
To be on time, we just move to the next session, but you can use the coffee break time if you have any question to reach out to the speakers. Okay, for the next, we have the AI trustworthiness in the wild, closing the reality gap. George. Okay.
All right, welcome to this second session, which I think makes a very nice connection to the previous session in that sense that we keep focusing on the topic of AI trustworthiness. In particular, the main emphasis in our session here will be on bridging the gap between, let's say, all the research that is out there on the topic of trustworthy AI and looking closer on what it actually means across different domains. I want to start with a very quick quote on why this topic is important. I think clearly we all know that trust in AI is a question of pace, right? You lose trust much faster than you build it up in very, very small steps. And this challenge is becoming even more important now with the speed, with the pace of development that we see in AI in general. And also something that we could see across all the talks, not only in the previous session, but also in the morning, is that trustworthy AI means a lot of different things, or it comprises of many, many different challenges, topics that need to be addressed. And I'm just putting up the 7 key requirements for trustworthy AI in this slide from the high-level expert group report. So in order to address this in this session, we are very happy to have 4 excellent speakers and experts on trustworthy AI. I will quickly introduce them, and then we will follow up with a brief talk by each of the speakers. And if the time allows, we will also have a nice panel discussion at the end. So our first speaker will be Giovanni Bonatti. Giovanni Bonatti is a manager at Majoli and also a digital innovation advisor. Then the second speaker today will be Sofia Seculi. She is a research associate at the Center of Research and Technology Hellas and will give us some insight on the application of trustworthy AI in the healthcare sector. We will have Javier Augusto from Boeing Spain, or Boeing Europe, I think, who is a simulation engineer there and tells us about some challenges of applying AI in a very safety-critical sector. And closing up, we will have Georgios Patoulas, who will take a closer look on, let's say, the perspective of research and academia and the gap between that and industry. And now I want to take the time. So welcome to Giovanni Bonatti.
Thank you for inviting me. Thanks. I would like starting my little speech with the question, because we are thinking a lot if the use of artificial intelligence is discouraged, but a lack of reliability by a lack of awareness. In my opinion, this is a strategic question because in Italy we are thinking about what type of trust are relevant when we discussing about artificial intelligence. And I would like to use 2 particular events that happened in the last month, particularly the first one is in Italy. I must study this event a lot for my job, because some months ago in Italy happened something that I describe as a reliability of artificial intelligence output, because the specialized business division of the Court of Florence examined a case involving the improper use of artificial intelligence in a dispute, when a little lawyer used some result to give them to judge, and the judge read this case and affirmed that, oh, but is it not happened really? And the first is that this information was inserted without verifying the correct origin of themselves. So we use to think about reliability of artificial intelligence output. And the second one involves the reliability of artificial intelligence procedure. I have been working 4 years ago in San Francisco, when a group of researchers, a friend of mine, decided to start doing a study asking to every inhabitant of San Francisco, would you ever take a taxi driven by artificial intelligence if you knew that in San Francisco more than one such vehicle crash every month? And every inhabitant answered, oh, I wouldn't. But unfortunately, about 10 injury crashes involving human-driven taxis for every one injury crash involving robotaxi. So we think that, generally speaking, people tend to overestimate artificial intelligence generated outputs while underestimating the capabilities of a well-designed artificial intelligence-enabled procedure. And this is an important matter of study that we need to explore to understand why we can build awareness around artificial intelligence. And we come from Italy, where we have a problem such as another states of Europe, because if digital skill and artificial intelligence awareness remain weak, we have the problem that public administration and also private sector tend to fall in two strategic failures. The first one that I name avoidance, that happen when artificial intelligence is kept outside the organization, even when it could preserve service capability or capacity. And the second risk is that supplier-driven adoption. It happened in particular inside Italian local public administration. Technical choice and process redesign are delegated externally rather than by accountable public decision maker. This is a case that frequently happens in Italian public administration when the private sector take decision for the public administration. We just in these weeks we are collecting 2 or 3 data very strange, because our local public administration lose more or less 30% of employees compared to 27. And so in this case, artificial intelligence should not be considered as a threat to the job, because it is a condition for preserving efficient service for citizens and to guarantee the correct function of public administration. Sometimes we speak about how many employees artificial intelligence put out of their job. Now in a different state, we are studying also different nations. We are the opportunity with artificial intelligence to look after function that we are not employees, we are not workers able to look after them. So artificial intelligence is a need, in particular for Italian public administration. In our group, we are applying and we are studying some interesting function that artificial intelligence are managing in public administration. For example, document registration. A lot of local public administration transfer to human worker to the artificial intelligence to collect documents that citizens send to public administration, because there are no workers available to register that documents, but also to draft administrative documents. And at the end, very important function, sometimes we named it chatbot, to dialogue and to support the first question that citizens ask to public administration. 2 final data that are very important to take into account, because last week, Maggioli Group and the Innovation Group published important research made inside the local public administration, and only 28% of local public administration in Italy declare some use of generative artificial intelligence. And unfortunately, inside these 28%, just 1% use artificial intelligence into an integrated way with their process. So they are using artificial intelligence without considering how to integrate artificial intelligence inside the public process. And this is a very important question because it can become a risk to spend a lot of money without simplify and without put away a lot of bureaucracy that we must solve. And at the end, our study come to a solution to a project that we want to promote also in a European session to start a very important Marshall Plan for digital skill, because Europe needs a community recovery plan for digital citizenship and artificial intelligence literacy. Not isolated courses, but a well-structured plan to be promoted inside all European local public administration for citizens, for public workforce, for manager, and for the institution. In a nutshell, we must move from a passive digitalization to active digital sovereignty in public service. This is a challenge that we would like to bring in this meeting, and start from today. We would like to put this question, this idea in a lot of different sessions, because after recovery plan that give a lot of software, a lot of digital infrastructure in every Italian but also European institution. Now is the moment to start and to create important Marshall Plan of digital skill to allow every citizen to acquire the knowledge and the consciousness to use in a correct way artificial intelligence. Thank you.
Good afternoon. I'm Senguli Sofia. I will represent today the AI integration and the ethical challenges of this technology. I represent CERT, ITI, and more specifically the Visual Analytics Lab. So as we are waiting, I have to say that ethics are considered a conceptual concept, but today we will prove that ethics are part of the operational loop. So, as AI integrates, trustworthiness is more So, as AI integrates in clinical settings, trustworthiness is something more than technical excellence and algorithmic performance. But why AI is so important? Why AI is so important? Excuse me again. But I don't know, something happens. So, why the healthcare domain is so important? Because it is not just another industry. It is a critical infrastructure sector, and data speaks in itself. It is the most targeted sector globally over the past 2 years. The average breach cost is more than 10 million, and the mandatory cost for a breach is should be reported within 72 hours. And what matters so much is that patient data are of high value they hold long life sensitivity, and also they have a strong black market value. And if operational disrupts, the patients are harmed directly. So cyber incidents can interrupt diagnosis, treatment, and of course, care continuity. Also, we have to consider hyper-connected attack surface, stretching from Internet of Medical Things to legacy, clinical devices, and cloud devices as they increase our exposure daily. And also, we have to consider regulatory complexity under a number of regulations, such as GDPR, NIS, and medical devices regulation that interact in clinical settings. But now, AI in healthcare is not a promise. It is a reality. It enters the clinical chain from raw data to informed decisions in a number of areas, such as diagnostics for the early detection and prediction, treatment optimization through personalized pathways and risk prediction, patient care through virtual assistants, and clinical governance through auditability and human oversight. But the key tension in here is that the more AI affects care, the more transparency, accountability, and safety assurance are required and should be operationalized. In our lab, we are making ethical discussions about a number of AI applications and technologies, such as conversational agents for chronic diseases, asthma, chronic heart failure, hypertension, diabetes, for care interaction, also embodied AI agents for cancer prevention, hypoglycemia prediction through AI models, and human heart reconstruction through scans. Excuse me. And how do we preserve trust while moving from prototypes to clinical settings? This is the core design question that also affects not only technicians, but also clinicians. So the problem is the adoption trust gap. Innovation is accelerating faster than clinical governance and regulation. So we have to understand the cost of mistrust, patient confidence. If patients lose confidence, data may be withheld, and AI-driven intervention may face resistance. So what is the answer? The answer is to implement for day one ethical frameworks that will accelerate readiness, safety culture, and clinical adoption. So we are talking about a high-stake technology that needs, apart from technical excellence, also ethical excellence. And there are 5 risk hotspots of high importance: bias and inequity. We have to control if the data are representative. Black box decisions, clinicians need to understand why a recommendation is made and if this recommendation is proper for the subgroup of patients. Privacy and cyber risks. Sensitivity medical data need to be protected for cyber attacks. Also, accountability gaps. Responsibility must be clear when AI-supported decisions fail. So we have to ask, who is responsible when AI fails? Are clinicians, are technicians, all of them? Also, another very hot spot is training and awareness, because as it has been mentioned in previous presentations, we are talking about two different words, technical teams and legal social teams. And they need to be trained. They need to acquire more knowledge in order to interpret AI risks and uncertainty. And we have to keep in mind that a cyber attack on a hospital is not just a data breach. It can become a clinical emergency. So mainly, there are three pillars of trust: explainability, equity, and protection. According to the explainability, we have to move from black box to glass box models through interpretability and meaningful clinical explanations. Concerning equity, we have to implement bias mitigation, fairness audits, and performance checks across subpopulations. And to ensure protection, we have to initiate zero trust architectures, privacy by design, federated learning, and secure data control. So ethics is not an afterthought, should be implemented by design and should be operational. Trustworthiness must be engineered before deployment and also monitored after deployment and continuously verified. So there is an operational loop that we implement in-house, which is first to define the specific clinical purpose, risk boundaries, and human oversight. Afterwards, data validation through controls of bias and quality of data, secure privacy controls through the protection of sensitive data with privacy by design and zero trust controls, and finally, initiating the loop of monitoring, which should be constant. So more, how can we move from ethics to verifiable signals? There are core principles that should be actionable, such as transparency. Clinicians should understand AI decision. So if clinicians provided with sufficient information about this decision, they can act properly and in time. Also, fairness, bias mitigation, subgroup validation, and acceptable variance thresholds. Accountability, clear ownership, audit trails, decision logs, and escalation protocols. Safety and robustness, which can be secured through high-quality data, and sustainability through clinical accountability and the European governance data responsibility in time. So accountability in AI decision, clinical AI needs responsibility structures and measurable performance. There are some tough key questions. Who is responsible when AI fails? How should liability be assigned? When must a human override the model? So to answer all these questions, we have implemented the following approach: a multi-level governance and also a KPI package for clinical AI and decision support models. So models are validated through discrimination, calibration, clinical utility, and validation transportability. It is also important to be mentioned that the safeguards have to be modified according to the context and data specificity. So, for instance, in terms of clinical decision and agents, the most important is to define the ethical boundary of care empathy, while according to personalized medicine and wearables, we have to focus on encryption and transparency limits. And finally, another example is smart home and cognitive support through AI, where autonomy boundary is, in autonomy boundary, we have to place emphasis on. So the primary validation pillar is human oversight, and a key message, AI will not replace clinicians, but clinicians using AI responsibly will outperform those who do not. So what is really needed is training, sufficient training for clinicians, uncertainty literacy, escalation protocols, and feedback to improve the AI system. What clinicians should bear in mind is that they have to interpret the outputs, they have to detect failure modes, escalate safely, and close the loop by providing their information back to developers. And some takeaways: trust is clinical safety, ethics must be operational, and assurance must be continuous. Thank you very much for your time.
Hello. Thank you for having us. It's a pleasure to be here. Thank you for organizing everything. It's really nice to have the opportunity to talk with many people that know so much about AI. First thing, I'm not an expert in AI, so I will try to do my best on this. I'm Javier. I work for Boeing, so probably you all know what we do. So I wanted to start this talk with, I want participation, guys. And I know that some people knows about aerospace and aviation because Nicola, you talk about something that is really similar. Martin, I think in the morning did something similar too. So because he was talking about contrails. So how many of you know people that works in aviation? 1, 2. Well, it's a lot. Okay, of course you know me and Nacho that is there, so it's fine. 2 things about us. We like planes and we like to talk about planes a lot. So if you engage in this type of conversation, you have a problem, do not ask us about planes. We can talk about this for hours. And also normally spacecrafts and everything that flies. And the second thing, and this is an important takeaway, is we are obsessed with safety and security. If you talk with anyone in our industry, is the pillar of everything, and you will see. And I'm talking about this because, as you will see, it's really connected to trustworthy and all these things. So, you know Boeing, you know what we do. Well, we do many things. Probably you fly in one of our products, programming here, maybe, or Airbus, whatever. But I'm mostly in this program. Well, I was not expecting the sound. Okay, you are still hearing me. So, mostly I work for this company that is based in the US, in the Bay Area. We do the first fully autonomous vehicle. Well, that's loud. It's 40 seconds. We can wait. Thank you. That was too much.
Well, it's nice to have also the music because it's nice. The video is nicer. Anyway, what we do is a fully autonomous vehicle. It is designed to transport 4 people, especially in cities between one point and the other. It is not just the aircraft. You need many things in order for this to work, like communication with a ground control station, but also the integration with all the other actors in the airspace. So you are not flying alone, so you need to talk with traffic controllers, you need to talk with other users. So we design a system that has both the aircraft, ground systems, that allows us to move people from one place to the other inside the city. It is a fully electrical vehicle too, so autonomous and fully electrical. We do not, if you see the interior of this, it doesn't have some steering wheel or anything. It's like you just see seats. It's quite nice. The video that you saw is the second version of this Gen 6 that we have, the flights that we are doing for testing and for proving that everything works fine. Again, we are obsessed with, so I already talked about my plane, so I'm happy with this. Second thing, I want to talk about safety. Aviation, you know the numbers. Probably you are familiar with this table that is in the left side. By far, commercial aviation is the safest means of transport that you can find, by far. And this is mostly because we have this Swiss cheese model that if you search a little, you will see how it probably is more used in human factors, but in general is applying to all the industry, in which you put several layers of control. So starting from the regulation, through the whole development process, training, operational certifications, everything is creating like different layers that makes a potential accident or incident really hard to happen. So for something to go wrong in aviation, many things need to go wrong, starting from maybe a design flaw, but also not for the pilots or the crew not following the procedures. Many things need to happen. And this is where I saw Nicola before, and I say I know that what he's talking about. So there is a standard that is called ARP 4754, that it is what guides every design in aviation. So this is where we start, is this V development cycle. They modified a little with the W, but it's fine. I'm fine with that too. But mainly it is you start from the definition of the system, you derive requirements. Based on the requirements, you do something that is called functional hazard assessment. You understand what happens if this function is failing, and which is the effect or the impact that it has. You classify the effect between medium, high, catastrophic, and based on this effect, you need to put controls in order to avoid that at the level that you need. So, for example, when something is catastrophic, you need to design a system that has a design assurance level A that they call, and A means that the system just can fail 1/10, 9 times. So it's 99.99999% of the time is working as you expected. For doing that, you need to do things like adding redundancy. So, for example, do not think about one computer, think about 3 computers, doing the same, comparing results, and if something goes wrong, you have mitigations when this happens, because this should not happen. So the first part is deriving all the requirements, understanding the functional hazard assessment, the preliminary safety assessment, and all these things. And after that, we start going up the V. That means that we are starting the development. The development starts in the bottom part. So, and I wanted to talk about that a little. When we talk about development, there are 2 main things that we have: software and hardware. It's a combination of both things. When we think about software and hardware is also the engines. So there are many things that are inside this. So there are 2 standards, one for software, 178, one for hardware, 254. So, and depending on this design assurance level, the standard forces you to do some testing and some verification on your different pieces of software. And if the software is it has a high level of assurance, you need to do things like you have there. So starting from the easiest one, that is you have requirements, you validate your requirements, but you have things like testing every single mathematical combination of the decision paths that you have. So if you have an if and you have an else, this code needs to be exercised, this code needs to be tested for any single thing that you have. And this includes the libraries that you are using. So, you know, it's like, I told you guys, we are obsessed with safety. Everything needs to be under control. So we need to verify that things do what we are expected to do. Coming back to this figure, what is in the right is validating that what you have done is doing what is expected to do. What is in the left side, that is validation, means that are we doing the right thing? So we spend a lot of time thinking of which is the right thing that we have to do, and a lot of time thinking about it is doing what we expected to do. There is a complementary path that is coming in the last years, that is the use of simulation tools for validation and verification. That means that you can start using simulation frameworks because there are many, many operational scenarios that you cannot do in the reality and test in the reality. So this means that we are using platforms and we are using sensor models, for example, or different models in order to validate the code. And one critical thing here, Nicola, you also mentioned this. I think that we need to talk, by the way. Uncertainty quantification. So it's really important to understand the uncertainty of the models that I'm using in order to see how it's propagated through the system and show the regulator that, okay, even with this uncertainty, my system is able to handle the outputs that I have mostly. So I will be short. And in the presentation, so this doesn't mean that we do not use AI. We use AI. And we use AI for things like inside these boxes that we were talking before, requirements, create specification. It's really nice to have a tool that allows you to read documents faster. When we are doing prototypes or this simulation, it's really nice to have a code assistant, but we need to take care of this. We cannot trust blindly this. We need to validate everything that happens. Things that we cannot use AI right now is production code. We do not expect AI to do the full job. It is a tool for us. It is not just something that will replace the things that we do. And if the system is a high assurance level system, it's really hard to verify the system because you are using libraries and frameworks that are really heavy, that are putting a lot of overhead that you cannot validate and verify later. So finally, I wanted to show you one example simulation. I told you one of the situations that we need to deal with is a passenger is inside. We do not have crew. It's a fully autonomous. There is now no one in the vehicle. So the pilot in the ground needs to be able to understand if the passenger is having an emergency, and in this case, to divert to a closest vertiport. I mean, even if our flights are short, you need to make this decision. So there will be a feed coming from the aircraft to the ground that the pilot can visualize and make a decision. So we are studying how much workload at this decision making and which is the right level of information for them. So it's really difficult. If we need to hire people.
I can't believe you signed us up for this.
It is perfectly safe. Just calm down.
We are test subjects, Brian. Test subjects.
It's autonomous. There is no pilot.
Okay, so if we want to train our pilots in the ground, we need to show them things like this, and they need to make a decision. This, for example, is not an emergency. This is just someone freaking out that you can't handle the situation. You can talk with them. We have other videos in which we are like trying to mirror a heart attack or all these things in which they need to decide, okay, I need to divert. So these are the places, for example, in which we can use right now AI and generative AI in this case. So again, we want to keep using this. It's really nice to be part of this project because it allows us to see where the things are going. But we need to keep this balance between trusting this too much or using this in the right places mostly. Thank you.
Hello from my side. It's nice to have cool friends like Javier, but it's difficult to give a talk after them. So short disclaimer, I don't have planes and stuff on my presentation, but I'll try my best. So for the ones that weren't here today, my name is George Pathoulas. I'm an associate professor in the Department of Information Security and Communication Technology in NTNU in Norway. I have been serving as the technical coordinator of the project as a whole, but this presentation is mainly about another role I had, which was leading a research pillar we had that was named Trustworthy AI, and that attracted a lot of interest during those years. So, to be honest, I'm in a position that many other colleagues have been. We have been many that were cybersecurity researchers, and we have been, by decision or by someone else forcing us to look into AI. And doing this transition and trying to secure AI systems, while until recently we did that for traditional systems, created an issue for us. The reason is that traditional systems have some properties that you cannot find in AI systems. So there you have hard-coded logic. You have something, it executes, it is deterministic, it will do the same thing as many times as you execute it. You have binary states of truth. You have something that is happening or not happening. You don't have something like 70% probability. We have cryptographic certainty. If you have a well-developed and designed cryptographic algorithm, and this says that this is valid, it's valid, and it's over. And we can reproduce situations and do some root cause analysis to find what went wrong. In this transition from securing traditional systems to securing AI-based systems, we move from a deterministic space to probabilistic space. So while previously we had well-defined threats, we had predictable behavior to some extent, and we had a clear trust model. Now we end up having probabilistic calculations, a real big problem, which is the fact that such systems have a dynamic state space which is huge and we cannot control, and a more fluid new threats vector. So in the work we've done, we started with what trustworthy AI is. There are different definitions. The one that most of the people agree is the one that we before today, defined by the high-level expert group on AI in 2019. It consists of 7 key requirements, which are human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination and fairness, social and environmental well-being, and accountability. Just with this slide, we can agree that our job to design trustworthy AI systems or ensure trustworthiness of AI systems is a very challenging one and a very complex one. We are trying to do that when we're developing AI models, but when we move those models to the real world, things work not as expected or not always as expected. Why? The first and the main reason is what we already discussed. Such models are mainly probabilistic in their nature, meaning that you cannot work on a hypothesis that if this run correctly and as expected this time, it will do the same the next time that I will use it. And this affects most of the properties of trustworthiness of AI. We have a black box effect where we either use models we cannot see, we cannot touch, or even we use models that we have access to, but their internal state is so huge and difficult to explain, so it's actually more or less like a black box again for us. We recently have been using massive models of very large scale, and this creates issues regarding to data we need to train them, privacy, data governance, and transparency. Those models, of course, because of their size, come with huge resources requirements, and this creates an issue about societal and environmental well-being. We have systemic data bias and drift. Our models are as good as our data is, the datasets are. So if we don't have good enough datasets, we end up with not good enough models. And last but not least, due to the size of the models nowadays and to the access limitations we have, the life cycle of an AI system is completely fragmented and it's not controlled by a single entity or the user. So given that we don't have control on that, we have issues related to privacy, data governance, human agency, and oversight. In total, the way that we develop and actually deploy models in the real world affect in more than one ways all the concepts of trustworthiness of AI. This makes the mission we had in the project, but we share with many others to make trustworthy AI systems very, very challenging and difficult. So looking at it from a research perspective, I can say that we are living in a lab illusion. What we usually do as researchers is that we take a model, a reference model, we take a data set from a domain, we apply a couple of different training configurations, we pick one of those that creates the best accuracy results, and more or less our job is done. We can publish a paper that says that we can solve this problem with that model, and here is the proof, and that's all. But this is valid if some assumptions hold. So in order for this to be valid, you should have a perfect representation of the real world within your data set. This is usually not the case. And another point in which we suffer is that even if we have a good representation of the data that the model will meet in the real world in our lab, we are finding very difficult to model adversarial or edge cases that will happen in the real world out there. So eventually, when we build a model like that and we try to apply that to the real world, we did it a couple of times in ENFIELD, we end up having a model that is not prepared for what it will meet out there. We have a model that behaved very well in the lab, but when you put it out there, then you have issues with data drift, adversarial cases, edge cases, and it's very difficult to replicate the results you had in the lab. One of the conclusions from ENFIELD is that we have to deal with this situation in a more sophisticated way. The main conclusion is that you cannot achieve AI trustworthiness with a once-off approach that I made this model, it's trustworthy, send it out. Trustworthiness of AI is the result of a dynamic, ongoing process that shall follow the model throughout its life cycle, from its development, training, across its operation throughout time. And towards that goal, we have a lot of steps to still make. Thank you.
For the last part of the session, I would like to ask the speakers back to stage again for a short panel.
All right, thank you. Looking at the time, we will keep the panel as short as possible, but today in the different presentations, I think we have seen different notions of the meaning of trustworthy AI in the different domains, industry domains that we see represented, or research disciplines. So I would like to ask to you, what actually does trustworthy AI mean in your work to the colleagues you're working with? And is that perspective, is that definition actually useful?
Thank you. So the definition actually depends on who is using AI. If AI is used, implemented, let's say, by developers, the focus, the emphasis is on concrete metrics such as robustness, such as explainability, safety and security. If we are talking about the end users, such as patients, clinicians, they are placing emphasis more on their data privacy. Also, they need to be secured that at the end, the physician and the doctors is the one that will take the decision about their care plans. And also, if we are talking about organizations and also hospitals, the emphasis is placed on regulatory frameworks and also on legal aspects. And the other part was about, from my point of view, the meaning is useful when it is approached from a multidisciplinary perspective, meaning that this is the trustworthiness should be built on participatory design, and also is a decision of a number of stakeholders.
As you saw in the slides, we, by definition, we do not trust anything. So, you know, this idea of trustworthiness is something that we deal really bad generally. We need to prove that works, and we need to do all these steps that we were talking about. I think that the path that we are taking is that for us, what is important is the output of the systems to be bounded and controlled. You talk a little about this idea of that it is not deterministic. That's a problem for us. So I think that when we define trustworthiness is how repeatable is. So probably we need to, that's why it's not really useful, the definition that we probably have here. But we are leaning towards something that is bounded, is controlled. I mean, can we put the boundaries for this to work? That's the main idea.
From my side, bringing in the cybersecurity perspective, I can confirm that all of us mainly perceive trustworthiness of AI as only technical robustness. So we think it's cybersecurity as usual, while it's not. Mainly because of the probabilistic nature, all the other questions that come up from trustworthiness concepts become very difficult to answer. So while technical robustness is very important, and through our research we have been able to understand how our AI models can be attacked, and mainly how those can be defended against such attacks, which is a very important component of the discussion. We still have to include in our efforts and in our perspective all the other concepts we have discussed, because only in that way we can reach to a point where we can have AI adoption in a fair and human-centric way, as we shall do.
Thank you. Doesn't work. Thank you. Your question intended the word reliability. In my opinion, we must divide public and private sector, because me and my colleagues come from Italy, a nation with 7,800 local municipalities, 80% of them less than 10,000 inhabitants. And frequently, in this little local municipality, the reliability is something that happens without consciousness, but because a private company give to a public administration procedure that use AI to function. And I think that the problem is not how acquire their reliability, but how make them more consciousness that we are just using artificial intelligence without their process, but they are not conscious that they are using inside their office artificial intelligence. Yesterday I was with a manager, Italian important manager. Oh, do you know that you are using a lot of artificial intelligence? Oh, are you sure? Because they don't understand the procedure that the office are buying from the private company. And we must build day by day the awareness of public decision.
Right, thank you. Very clearly put from all of the speakers. Asking for a closing statement already, but maybe that leaves room for one or two audience questions afterwards. I would like to hear from each of you If you had like a wish free, if you could have whatever you want, if there would be one change, be that regulatory, be that organizational, institutional, be that technical, of course, also, that would help accelerate the real world trustworthiness of an AI solution, what would that be for you? What would you wish for?
From our evidence in-house in the visual analytics lab at CERT, and also from the literature and from the experience that we have from pilot operations in a number of projects that we are running currently, I think that the most critical point right now is to for organizations to have an external auditing infrastructure. I mean that audit controls in-house are not sufficient. Which should be implemented right now is something external, which will bring, I think, will force also all these core principles that we are discussing, such as fairness of data and so on. All this should be implemented. And also what is very important, and the European Union is supporting it enough, is to implement as a culture the documentation of data in each operation. This is very important. Data need to be cleaned, need to be documented, and need to be not biased. So this is my...
In our case, if I have to choose just one, honestly, I think that we need to improve in many areas, so across the board. But if I have to choose just one, probably it will be, in our case, regulatory, because it's like regulation is really heavy in our industry and makes sense. So this is not something that we as a company can do alone. We need to talk with FAA, with EASA, and being on board with them, working with them. Indeed, they are already working on this. So I think that we are going towards the right place to go. The thing is, I think that the rate of adoption that we have seen in the general public is not the same that we will see in a safety critical sector like aviation.
From my side, I would say that one thing that I could wish for is that we need a straightforward way for the average end user to ensure trustworthiness of their AI systems. We have been working in trustworthiness of AI for years now. We have been discussing that for years. We have been proposing different solutions for years. But if a small SME of 50 people comes by and says, okay, I'm integrating AI technology in my workflow, I'm very aware of what is happening, so I read all EU AI Act. Now I'm more confused than I was before. Tell me what to do. Tell me how can I easily ensure that. Many presentations previously touched that we need this practical way of applying trustworthiness in real-world scenarios. Probably such SMEs do not have huge money to invest in that process, so we need something that can work for this small to medium size of companies, so all of them can take a step further towards achieving trustworthiness of AI systems.
I try to answer with the half of my body that work in European Parliament, because in my opinion, we are in front of a crossroad. On one end, the USA approach, in some way, innovate first and regulate after. And on the other end, the European approach, regulate first and innovate after. In my opinion, our challenge is put our dimension in the middle of this approach, because we can run fast as American, as USA, but frequently we go too slow because we tend to regulate too much our law. And in my opinion, we must individuate the correct point that it's at the middle from the USA approach and the European approach.
All right, thank you so much. I think we have time for one audience question. I see Sagar, for instance.
Thank you for the talks and the panel discussion so far. My name is Sagar. I'm a research manager from Sintef. So we spoke a lot about the sort of non-deterministic nature of this AI. So one of the approaches like Anthropic uses is to use AI to make plans, and then the rest of the operationalization is 98% of it is deterministic. And they somehow guarantee some form of convergence because what you synthesize as a plan, like, is sort of validated by the deterministic part, which is operationalization. So the question is, I mean, so there 2% of cloud code is AI and 98% is operationalizing AI on the cloud. So why don't we in Europe sort of think similarly? Why don't we sort of try to operationalize on our different systems, have a variety of hardware that we have, machines, even human-machine interaction, or more health-like setups, for instance, or even in aviation, and make it our niche. And Anthropic still hires software engineers, and they pay them $500,000. There is a need for software engineers. If they were so good at generating code, they would just do it themselves, right, with their software, but they don't. So they use the engineers to engineer this infrastructure for operationalization. So yeah, so I think the question is evident, which is how do we go ahead making Europe good at making AI more predictable, deterministic?
I feel that question is for me somehow. I don't know why. Well, first of all, yeah, I agree with you. I think that that's the point. It's like what we need to do is to keep working on how we make this bounded, and there are ways to do it. And I agree that it's a place where we can be better than others. I agree, but 2% is not enough. That's the point. I'm in a sector in which 2% is too much. You cannot have this type of variability. Again, I think that we can work to get this number lower and work together and see how we evolve this. And we are using, and you said something that, they are using AI to create the plan and the execution is deterministic. That's exactly what I was trying to convey. It's like in this V process, in each one of the boxes, you can use the tools. And I agree that we can find frameworks that's a really valid point. And I think that we are going in that direction, by the way.
Just a small comment from my side on the discussion we had many times of what Europe shall do, how Europe shall compete. It's a very difficult thing to compete in. We know the differences, we know where it starts from. But there is a window of opportunity because there are things that are not prioritized on the other side of the Atlantic Ocean. So trustworthiness is a thing there as well, but they do not share the European perspective we have. We see this from a different perspective, and this leaves gaps in which Europe as a union can do better than US or China does. I'm not sure if that is enough to compete with them on the general landscape, but it could be a start point.
I would like to start from your speech because I love reading two statements because let me know that our law is the first European law that has a human-centric concept. Allow me to recall that the 23rd of January 2024, the European Declaration on Digital Rights and Principles for Digital Decades treat just this concept that it states that every person should be enabled to join the benefits offered by algorithmics and artificial intelligence systems, including by making informed choice in digital environment, while at the same time remaining protected from risk and harm to health, safety, and fundamental rights. I love every time reading this concept because, in my opinion, in this brief statement, we can find our competitiveness respect the other continent.
Thank you so much. Now, a short call to action, maybe not. Let's see. No. Okay, then in this case, it doesn't work. It's fine. Let's thank the speakers again, and we're happy to join the coffee break.
Okay, welcome back to the last session of today. This session is on AI research funding in Europe, and we have Anna here to moderate the session. Thank you.
Thank you, Marta. Hello, everyone. Good afternoon, and thank you for continuing with us in the afternoon, last session. I think we selected well the topic, so it's very appealing, I think, for everyone in the room. And I'm very glad to be challenged to moderate the session. Also a bit nervous, but I think it's part of the job. Yeah, okay. My name is Ana Solange Leal. I'm a director for partnerships at Innova Mais in Portugal, and I'm also a partner in the ENFIELD Network of Excellence. I have to admit that I'm a bit nervous also because the topic is not abstract to me. For many years and at Innova, we have been helping and supporting research organizations, industrial institutions, but also consortia navigating the European funding programs and opportunities. Writing proposals, managing projects, dealing with synergies and fostering cooperation has allowed me and us at Innova to have a specific opinion about what the funding programs promise, but also what can actually be delivered by them. I will keep my opinion for myself because today it's not about what Innova thinks, it's about what we all here are able to discuss and explore. As Ida mentioned, the session is dedicated to funding in Europe for artificial intelligence, and for that we will be building up on the examples of the networks of excellence that were created with the ambition of connecting the fragmented research communities across Europe in order to achieve excellence in AI research. Now we are in 2026. We have many of the networks of excellence coming to an end or concluding their activities. I think this is the best moment at all to ask honestly and to also get an honest answer. Did it actually work? Have these networks changed something in the structural way we are doing research in artificial intelligence in Europe? Or did it just produce something more fragile? Lots of papers, lots of publications, strong networks, good relationships that will slowly fade once the funding stops. I will be putting this question later on to all the people that grateful accepted our invitation to be part of the panel. But I'm genuinely curious about all their answers because as you can see in the slide, they came from different fields, so different perspectives are very relevant to have an explorative conversation more than just a retrospective exercise. To have this conversation, I'm very pleased to have with us today first, Georgios Patoulas. I think you already heard his name today. As he already mentioned, also he's an associated professor at NTNU in Norway, and he has been acting as the technical coordinator of the ENFIELD Network of Excellence. Then we also have Alain Pagani, which is principal researcher and deputy director at the FKY. He's also coordinated the Network of Excellence DIH on distributed AI at the edge. We also have Dimitrios Zovaras, if I'm pronouncing correctly, who is a research director at the Information Technologies Institute of CERT in Greece, and also co-founder of 8 spin-offs and owner of more than 10 patents. Because I cannot be only female presence in the stage, we are also very happy that Cécile Huet has accepted our invitation. She leads the unit for robotics and artificial intelligence innovation and excellence at the European Commission. I will be directing specific questions to each one of them. I will also open the floor for questions from the audience, okay? But before that, let's hear from them first, and therefore I invite Georgios to come to stage. Thank you.
Good afternoon, everybody. It's the last time you see me. I won't appear on the stage tomorrow. I have to be in this session as I was the coordinator of the ENFIELD project. I have some thoughts already about how we've done. It's the reality is that I need some years to pass after it ends to give a definitive answer if we've done well or not, but we'll see. So talking about AI research funding in Europe and where we are and where we want to go. If you have been following the news in recent months, you should know that we are at a stage where we discuss that we're going through an AI arms race worldwide. Some of it is hype, but I guess that we all agree that states that have a lead in this so-called race are going to have a competitive advantage in the years to come. So that stories in the news are mainly about a dilemma, which is, can China compete with US in terms of AI development and stuff like that? Of course, here today, this dilemma is not something we would like to have. So our discussion is mainly about whether we can put European Union into this discussion, into this race, and even if we can put European Union in the first place of this race. So let's see where we are. If we're going to try to check how we are doing, let's look at some data. These are data from the Artificial Intelligence Index report from Stanford University that has been released recently. And it counts how many notable AI models have been produced per country. And probably you could have predicted that. Most of those models have been predicted in US and China, and only 2 have been produced in Europe, 1 in France and 1 in United Kingdom. So according to this slide, we are not doing very well, or as well as we would like to do. So what can we do to change things? I will try to give a very, very simple recipe of how to succeed in this AI race. You need some ingredients. The first one is resources, computing resources. You cannot do AI without that. The second is AI talent. The third is a lot of financial investment. The fourth is energy capacity, which is not obvious right now, but in a couple of years we will be into a discussion if the energy we can allocate to data centers is enough in order to compete in that race. And finally, we need regulation. You cannot go into this process without regulation. So for hardware resources, one piece of data is that as years go by and as the size of the models grows, the hardware resources we have to meet grow exponentially. And this will be like that in the years to come. The second thing that we have to mention is that most of such resources reside in the US. So we have to use hardware resources there. Regarding talent, if we, again, in a very simplistic way, try to measure how many people that are doing significant things in AI exist worldwide, most of them are in the States. But if you normalize those numbers with the population of the countries, you'll see that many of the European countries come up to that list. And I would say that all of us in the room can confirm that one thing that we are not lacking in Europe is AI talent. We have talent, maybe we have a challenge of not losing the talent, but I would say that we have the right people to do the job. Regarding financial investment, on the other hand, we all have seen that the scale in which the financial investment in AI in the United States grows makes any discussion about comparison not applicable. We cannot compete with them on that front. They are going upwards. For energy capacity, the models we create tend to demand more and more energy. And hopefully this is one of the parts of the problem that we can do well. And finally, for regulation, there are regulations that are being developed and proposed around the world. Let me express my personal view that the European perspective in terms of regulation gives us an advantage on that. So going back to the recipe, we need 5 ingredients. And what we have, as Europe, we have an advantage in terms of energy capacity and mainly regarding to clear energy, green energy. With what we have done up until now, and we are proud to state that we are part of this as NOEs, we have been able to develop AI talent and contribute to regulations. With what we will be doing in the years to come, with the AI Continent Plan, we will still contribute to AI talent and regulation, but with AI factories, we hope that we can have the element we were missing, the resources in European Union to use for developing and deploying AI models. So we are almost there. We are missing one ingredient, and that is the investment in a scale comparable to what happens elsewhere. European Commission has committed to invest 175 billion euros allocated to Horizon Europe for the next period, 2028 to 2034. If we're going to be honest, even this is a huge amount of money, it will not be comparable to what we expect that will be invested in other places around the world. So direct European Commission funding is not the answer to the financing limitations we have in the AI domain in Europe. But it can be a very efficient tool to trigger much larger investment from private funding. If you look at the numbers in the US, it's not governmental money. It's not money that comes from the state. It's mainly money that comes from the private sector. So this is something that should give us an indication of how we should think if we want to increase funding in AI in Europe. So from our side, as the AI community, research excellence, for which we have been working very hard in recent years, is not enough. We still have to strengthen our collaboration between industry and academia, to activate and maintain networks between stakeholders, like NOEs, to develop and attract AI talent, and to make optimal use of this hardware resources that will be made available to us in the years to come. If we succeed in all those points, then maybe we can bring private funding into the equation and find the 5th element we were missing. We have a long road to walk and challenge. A lot of challenges will come up, but you know, it's not only about winning the race I started my presentation with. It's not about a race. It's about 2 significant risks that we're running as a continent. The first of one is transfer of wealth. According to Sandra Fustenberg, Europe risks the largest involuntary transfer of wealth to the US unless it builds its own AI future. If we don't react, we will end up paying for hardware resources residing in the US, paying for AI models, paying for AI-based services. And as the adoption of such services increases, we will be paying more and more money towards the other side of the Atlantic Ocean. And even if we can bear with that and we can say we're fine, we can go with that, we cannot go with the second risk. The second risk relates to digital sovereignty, and according to the European Commission President, we cannot afford to depend on others for technologies that keep our hospitals running, our energy grid stable, and our services secure. Nobody in Europe nowadays, especially with the current geopolitical situation, wants to have our critical infrastructures running on top of services or model that are being controlled in other places in the world. So I will conclude my presentation by saying it's not about winning a race. It's about protecting our economical and societal well-being for the years to come. Thank you.
So good afternoon, everyone. From my side, I'm Alain Pagani from the FKI, the German Research Center on Artificial Intelligence. And I'm actually the coordinator of a sister project, the project DI Edge, who is also a network of excellence, but focused on AI at the edge, as the name says. And I would like to start my presentation by making a statement, which is that the Europe AI research landscape is entering a new phase. And the reason why we're entering a new phase, and we heard it already, is that the networks of excellence, as we know them, are now going to end. We are together with ENFIELD and others, NOEs, the last ones, and they will all end this year. In the last 6 years, there were 9 networks of excellence, each choosing a specific area of interest. And now the question is that going to die with the last projects, or is it going to help the new form of AI research? So by looking at the achievements of these NOEs, I think that we achieved a great success in creating research communities, connected communities that go across national and institutional boundaries. And we improved the visibility of AI research, and we actually connected researchers to work together on different things. For example, roadmaps, mobility actions, scientific exchange. So actually, what we discovered with that, the output for me is that the coordination itself, so making a coordinated effort, is a strategic asset for itself. Now, what we did specifically in DI Edge is focusing on a specific aspect, which is really looking at what happens on chips. And this involves not only software, but as you know, hardware design, chip design, questions of energy. So for that, we actually mixed, like other NOEs, community building, research, experimentation, use cases. And we have actually relevant outputs that we'll present a little bit later, which is our virtual lab, our use case, and a strategic roadmap, strategic research and innovation agenda for Edge AI. So maybe before I want to explain why I think that Edge AI is so important. Actually, if you look at when we speak about AI and the cloud AI, we speak about large scale, we speak about compute, we speak about super large models. But there is another way of doing AI, and this is looking at what appears near to the systems, near to the devices. So in your smartphone, in your vacuum cleaner, in your car. And this is quite important because this is where AI meets the real world constraints. So Edge AI is what we call operational AI, is where you actually have the most difficult in the wild problems. And because we are tackling energy problems, if you are designing a chip, you have an energy budget, you cannot go beyond. So you have to go for compromises between the accuracy of your models and the energy consumed on the speed. Then because of that reason, we also are forced to look into sustainability in terms of energy consumption and also at privacy, because the data that you produce locally, you don't want it to be shared with the rest of the world. So in that project, we have been very looking after how to make results shareable and usable by the community. And for that, since I think Edge AI is a topic where fragmentation goes to a higher level, because everyone is working with a different chip. Everyone is working in a very different domain. People are interested in hardware design, are not connected to people looking at software optimization, pruning, distillation, and so on. So we have decided to build an infrastructure that we call the DI Edge VLab, where you can literally connect to a computer that is linked to physical devices all across the world, actually in Europe. You can choose your device and you can run a benchmark on any device you want. So we have a long list of possible devices. Here is just an overview of the devices, and then you can run it. And this has proven to us that we don't need only large-scale compute, but we need also experimentation that is distributed and accessible to everyone. And then in terms of research to use cases, we have selected 3 use cases that show really how edge is useful in everyday situations. So the first one is a smart city, where we have cameras installed in a city. Actually, it's a test bed in Modena that is connected to Wi-Fi, collect information, do local processing, send information to a central place, and then you can know where you have parking lots, if there is a danger. We even connect that to the helmet of bikers to have direct information on what happens on the street. The second use case was space. Actually, we are writing algorithms that work on chip to do on-satellite pre-processing of images, in that case for sea ice classification, which can be very useful for helping navigating. I don't know why my presentation is running forward automatically, but to predicting where you can go for ship navigation. And the last one is having smart warehouses where we use drones and cameras to help security, but also processing in warehouses. So even by doing this and showing how edge AI is important, we still face challenges. And I said it before, fragmentation is still a problem in the community. So we need actually more discussion and more common work. And in the project, we have tried to do this. What we have seen also is you can do good research, but there is an engineering gap. You need to have good engineers that can then implement the algorithms into the actual use case. And every single use case is very different. So you need to adapt and to engineer the solutions. There is still a problem of uneven access to resources. Even if we did some efforts to share, not every engineer has access to the same type of resources, and this is still a problem. And I think that we need more links between research, deployment, and to favor industrial uptake and actually the creation of market possibilities. Now, speaking about the future, there is one instrument that is actually going to come very soon, is the RAISE. So it's the Resource for AI Science in Europe. And maybe you have heard of it. Maybe we get also more information later about this. But this is actually going to provide resources to the AI communities. And at first, you might see that as replacing all the NOEs. But I think this is a kind of evolution. Because here you see all the NOEs on the bottom. I call that the community and strategy layer, and we need that to have actually the stakeholders, the actors, and the scientists discussing what we need. But a community cannot work without resources. So we need a lot of resources to be able to implement our ideas in compute, research funding, data, and talent. So the challenge is actually in the arrow between the two. How do we do the connection between the communities on one side that are now going to have to survive without funding, and the RAISE funding that will give resources? And I think this is what we should actually discuss. How are we going to make sure that the community can have access to the resources? And then the RAISE is just one of the instruments in the global AI continent that will is the plan from EU that will provide compute infrastructure, data, skills, development of algorithms, and simplification of the regulatory information. And here, I think that the most important is that we have a coherent ensemble. So this means that the communities should also inform how these resources are going to be used. What I noted by reading the AI Continent Plan is that Edge AI is not explicitly mentioned. I think it's part of the compute infrastructure, but we should not forget that compute is not only big data centers, it's also Edge, and we need to find a way to make a powerful community for Edge AI in Europe. So to conclude, how are we going to move forward? I think that we need to preserve the community layer from NOEs, so we need to find a way to keep them. And the second is we need to use the new resources that will be provided by RAISE. What is very important, I said it before, is the funding of engineering and deployment. This will only with that, it will be possible to transfer the findings into products and usable assets. Trustworthy AI, this is also an output of our finding of our project, is that it should not be only a constraint from the regulatory coming from the laws, but it should be promoted as an attribute as industrial quality, and this we should work more on this. And Edge AI, I see that as a central component for making operational AI in Europe. And maybe to leave you with one final sentence, I think that from NOEs to the next step, we are moving from a coordinated excellence to deployable European AI. Thank you for listening. Okay. Let me check. Okay, it works. Perfect. So good afternoon, everyone, and thank you very much again for the invitation. Before I start on my actual presentation, I want to mention that our organization, CERT, is also the coordinator of AI for Media, which is one of the NOEs. My colleague Yannis Koubatsiaris was the leader of that. And some of the results are, I see results in the talent target, I would say, for Europe. They build a lot on the AI doctoral academy, the AIDA, and a lot of results on sandboxes, databases, a number of tools that were provided with the NOE. What happens next? When you ask me, I will answer later. So for my presentation, I will just use my 10 minutes, but I just would like to talk about myself just half a minute. So I started at CERT in 2000, and there was always the same question. What happens in the research centers and the academia, and why aren't you providing services to the industry? Why isn't the industry trusting you to give you contracts to implement their innovative products? Then, after many years and passing through all the senior researchers positions, director, president positions at CERT, I had the question, what happens to all this money that come to CERT? And that's why I'm here today, to answer to you what happens to all this money and how CERT sees the next day. So I'm here not as a research director, as you mentioned, but as the former chairman of the board of directors of CERT. I finished my duty on April 2025. So it's very recent. Due to health reasons, I didn't continue, but now I'm okay. So starting CERT, so I will just talk about the case study now. So for us, CERT is a research center, one of the 11 research centers in Greece, located mainly in northern Greece, with the main premises in Thessaloniki. We are currently having more than 1,600 people and a turnover of around 70 million the last 2 years, 60 million as an average the last years. What we are, does this work? I don't know. No. What we are proud of is this 13% that comes from industrial contracts, which means 10 million euros per year. Most of them, which surprisingly come from the US. You don't believe it, but most of them come from the US and from South Korea. And you can understand, US is mainly for the chemical research institute, and South Korea means Samsung.
And we are listed among top 11 EU institutions in terms of participation in competitive research grants. I have some more details about that. Just a moment, Earth is an umbrella organization with 5 institutes: the Information Technologies Institute, the most well-known in European projects and Horizon Europe, Horizon 2020, FP7, Chemical Process and Energy Resources Institute, the first institute that started CERT, the Institute of Applied Life Sciences, the Institute of Bioeconomy and Agrotechnology, and the Hellenic Institute of Transport. So where we stand now, and that's why they ask me these questions, is we are number 1 since 2013 in Greece in terms of funding from European projects, from FP7, Horizon 2020, Horizon Europe. We are still number 1 with a significant difference from number 2, which is 4th. And we are now number 1 on all 15 widening countries, since CERT is considering as part of the widening countries, something that I don't like at all, Greece. And we are number 4 in Europe in terms of funding in AI. So now it becomes more interesting. So why are all this money coming to us? And which are the projects that are funded? So these are not the projects of CERT. These are the projects of my group at Information Technologies Institute of CERT in all these domains, from the starting of Horizon Europe until today. You see also some of the projects that we are discussing today. What happened at CERT since 2013? We based on some decisions of the board of directors to found spin-offs based on the royalties model, based on changes on the laws in Greece, which allowed the creation of spin-offs at universities and research centers, and also based on the change of modality and the availability of people at CERT to take some risk, which is something in Greece. Risk was a question for everyone. Everyone wanted to go work for the public with a permanent position. So risk in Greece is a word not well known. So this is what happened. You can see in this diagram how these spin-offs were founded. And today I want to show you what happened in some of our more active and more successful spin-offs. So where do our money go? To this 1,650 people, and to support the creation of these spin-offs, to get industrial contracts from big players. I will name some of them. And I will show you some examples of this spin-offs. It will take me 5 minutes. One of our most successful spin-off is Pragma IoT. Industrial IoT was founded in 2018, but what gave us the advantage? Now we have the biggest contract in Greece with the biggest cement company in Greece. Cement company in Greece is applying digital transformation in all their factories in Greece, Turkey, Balkans, Brazil, and 3 factories in US. Okay, and they are applying digital transformation based on what we call the Titan sphere. Titan is a cement company with the adjacent platform from Pragma IoT, and we are very proud of this. Pragma has received funding from venture capitals and now is having a very interesting for the investors turnover. Another company is called Parelli Analytics. In this case, we deal with mission-critical logistics, and we have just one customer. Which one? Coca-Cola. But not Coca-Cola US, Coca-Cola Hellenic. Coca-Cola Hellenic is actually representing 28 countries. There were 29 countries, but Russia left this group, so now there are 28 countries. So there is a very big contract, and we are supporting. What gave us the advantage? Our expertise in AI that was gained in all these projects. This is another spin-off, Aussie Robotics. We are currently making new contracts with the Ministry of Defense for what you see here. We call it Tharos. It's a carriage in Greek, Tharos. George knows. And another contract we have is with Fraport. Fraport, Greece. If you come to Thessaloniki, in the Macedonia airport of Thessaloniki, you will see our robot. What gave us the possibility? This is in the wild, in the very wild, this one. And advances in AI gave us the possibility to be able to support this. One of the most challenging cases is AI vehicle inspection. It is actually for rental services, fleet management, car workshops, import and export of cars. And we are actually looking for small scratches in the cars. It is a very difficult task. We tried it many times. We achieved it the last 2 years due to AI, to the new models. We are building models of our own, and we increased the accuracy from 55%, which was considered okay to understand how difficult is the problem, to now more than 90%. And we are very proud of this. And this is we are very proud of Optimums. It's our fastest growing spin-off with 1,200 customers. And actually, this product plus mind is mainly on the optimization of actually load estimation, prediction of load, prediction of production, and prediction of storage, use of various domains of storage. So they have worked a lot on optimizing this. And this is now it's coming to Italy. Someone was from Italy here before. Now we're coming to Italy and the Balkans. These are our next steps there. So this is where the money go. Of course, these 5 spin-offs are 5 out of the 8 that I am a shareholder. So that's why I say I move from a researcher to a businessman. And I would be happy if I'm successful. Thank you very much.
Thank you. Yes. Okay. Thank you. So I think there might be a bit of repetition as compared to what we saw, but let's go through it. So I'm going to present the networks of excellence in the ecosystem of excellence. So the whole landscape of what we fund, but also some perspective on the future. So for those who don't know me, I'm Cecilia, and I'm the head of this unit, which is part of the AI office. There is one unit, which is the oldest one. We created it in 2004, and it's about funding the research and the technology itself. So our unit deals with the technology on AI and in robotics. So this project, all these networks of excellence have originated from our unit's programs. So trustworthy AI, of course, we want AI to be trusted. And I really liked your slide where you said it's not just about a regulation, it's to make sure that respecting rules that have been elaborated, but to build a trust in the company using the system. So also designing a technology and benchmark which are meaningful for company. Does that technology achieve what I need, and can I trust that the result will be robust enough, will be scalable, will be also accurate the way I want? So you have the regulation to ensure that the systems are safe, but we also have the need to develop the technology which makes the system safe and accurate and robust and so on. So for that, we work with the community, ADRA and EFRA, for manufacturing EFRA, but ADRA for AI, data, and robotics. They work with the community and the networks of excellence to define the strategic research agenda. We use that input to define the priorities for our funding in the calls. We fund research projects, but we have created a specific type of project, which are the networks of excellence. And the goal was to make something different than a normal project. It was really to bring the best teams we have to join forces and progress faster in creating critical mass and being more than just collaboration, but really building an in-depth networking process in Europe and a community in Europe. So in addition, we have the AI on demand. We have asked you to put your result there. The goal was really to offer to the community a means to share results and have a platform to find resources that you can reuse and not to reinvent the wheel at each project. And this platform has two sides, one for the researcher, but also one for the industry. We hope that your result one day will come to the industry, and the left-hand side of the platform is the industrial side, which is there to have industry-grade resource there. And then we have the testing experimentation facilities. Once your technology is mature enough, we offer to the developer an environment, once they have tested in the lab, to offer them this environment to test in real or close to real environment. We have 4 domains, actually 5. There is energy as well, but it's in manufacturing, health, smart city and community, and I forgot one, agri-food. And then we have the last mile delivery, the European Digital Innovation Hubs. They are there to bring this technology in their local environment and local industry and economy. So for the digital transformation, and now they're becoming really experts in AI to bring AI technology in the local ecosystem. So that's a bit the type of project, but I wanted to show how important is the network of excellence in that context. And yes, in numbers, something went wrong with the image, but don't worry. So we saw it already in one of the presentation. We have actually funded 10 of those projects for 100 million. And in terms of achievement, we really wanted to foster talents. You have seen many postdoc, many master students, and many also PhD students created by these networks. But more than creating individual researcher, we want really to have them included and being part of the community. We want, of course, to support cutting-edge research and also collaborate with startup and creating also an environment where you can develop your startup. So in total, we have more than 300 labs. I think these figures are even a bit higher, more than 1,000 of researchers, more than 4,000 publications, and 100 million funding. So this represents a big chunk, and we really need to be proud of that, and you are part of it, so that's really great. So here it was to just put the networks of excellence as one major component of between the standard project and the on-demand platform, the testing facilities, and the digital innovation hub. But this is for me a very important part of the whole, let's say, evolution of the technology. And here it's more the overall funding and number of projects we are dealing with in the unit. So you see, out of the 1 billion euro total budget, 1/10 is for networks of excellence. So it's a very substantial part, and for me a very important part as the community itself. So in AI research, what is coming up then? So you all have heard about RAISE. Initially, it was called European AI Research Council, but that created a bit of confusion with ERC. We want to be as excellent as in ERC, have the same reputation, but this is not the same activity as ERC. So here there is a figure missing, but the goal was to write RAISE there, which stands for Resource for AI Science in Europe, and it has 2 legs, one for science for AI, so what you're doing, fostering the progress for AI itself using scientific approach of fundamental research in AI. And then the other legs is about using AI for advancing scientific disciplines. And RAISE, we want it to become a virtual European institute that pools essential resources. So it was a nice illustration what you presented. So it's about creating the resource in order to implement the vision that comes from the community. So you have, through your project, developed a strategic research agenda, and this could be a vehicle to implement that. So we will have continue to support the talent, research funding, computational power, and data. And what will be important is to find a way to, again, create this virtual institute and creating a community behind it. So these are the two legs. And yeah, we want to maximize the synergy. Of course, we are stronger when we join forces. That's the European project in essence. And also the added value of bringing different discipline. AI in itself, it's already bringing different discipline, but you will have also the opportunity to work with other scientific discipline, and that's what we want also to support. So the research on AI and with AI. Then in that context, we just actually evaluated the call on a project which will pilot science for AI pillar of race, so your community, the AI community, and we will fund this 18 million euro project, a single project that will have to come up and propose a pilot for the next generation of RAISE project. And so they will have to come up with the best model to build this network, to find methodology to collaborate. So, and it would be very good also to build on the knowledge you have also developed through your project. So I expect a lot of interaction between this new selected project and the one which we have been funding, the networks of excellence we have been funding. So we expect to have a network of excellence AI lab. Of course, excellence is still at the core of it. And we want to keep raising the visibility and strengthening the collaboration in AI. So raising visibility was something which was at the core already of the networks of excellence. That's why we tried hard to create a common identity where everyone working on the networks, any of the networks, will be very proud of being part of the team. We want also to find a way, and listening to the community has to propose a model of collaboration among those labs to support the development of a strategic research agenda and fundamental research in AI. Ensure that the network operates as a virtual institute. That's always something we were trying to also foster through your project, pooling resource and expertise, develop synergy with the AI in science, so the other legs of RAISE, and of course, stimulate and support world-class research in AI, both fundamental and applied research. And building on our strengths and on the collaboration with industry is also something important. So the right balance between fundamental research, more applied research, and this collaboration between the researcher, but also with industries and the scientific disciplines. So here it was, again, there was something wrong with the picture, but the frontier AI is also, since you work in more fundamental research in AI, we are also, we have a number of calls to foster the development of frontier AI in Europe. This is a strategic asset to Europe to keep the sovereignty. So it's important in our view to support that. And we will fund a project of, that's the concept, but we will fund a 44 million euro project, a big initiative to really strengthen our capabilities in frontier AI models. So for us, we want to have, again, a strong team with sufficient critical mass to develop frontier AI or support the development and keeping the know-how on frontier AI also in Europe, and keeping our values in defining those models, including safety by design and so on. So thanks for all your work, the passion you put in your networks, and you excel. Let's keep it alive. So don't close the door after the end of the project. Thank you.
I invite all speakers now to join to the panel. Okay, I will keep my questions short. So as I promised, I will open the floor also for questions coming out from the audience. Okay. So perhaps I will start with a question that I did already in my introduction. Networks of Excellence, as it has been explained today, has been created to connect the research communities in order to have them working together and to foster excellence in research. Having said this, we are now ending and concluding the projects and the networks. Perspectives that this in a certain way will continue, but I leave the question to all. I would like to hear one answer by each. Will actually this continue, in what way? Or it is expected that slowly this will fade away and the work that we have been doing for the last years will be a memory in the coming years? Who wants to start? Oh,
Okay.
Georgios.
Okay. Well, I cannot promise that this will continue. I would be very happy if it happens. What I can say from our perspective is that all this process that now comes to an end has created strong connections between us in our network of excellence, between the different networks of excellence, within the whole AI community around Europe, research and industry community around Europe. So for sure we have stronger connections that will last for the near future. What I could also say is that the major gain out of this process is that we feel part of it. We feel that we have part of the responsibility to promote research excellence in AI in Europe. All of us that have been involved in NOEs, along with the Commission representatives, feel that we're on a mission to create an AI continent somehow. I hope that this part of how we see it, the responsibility part, will drive us forward, and it will push us to find ways to continue what we are doing currently, even after the networks of excellence are finalized.
That's a good collaboration between NOEs. So yeah, so I think it will continue, but the question is how. So how will it continue? So because there's a momentum. I see people in the communities, they are very enthusiastic and want to continue, but of course it's always difficult to continue without funding. So of course we are not going to beg for funding for doing the same thing, but I think we need to look at what came out of these projects. And for the AI Edge, the fact that we were working together, we produced assets. So we produced books on architecture, on requirements. The strategic agenda is yet to come, and this will also be produced. So these are already reference books that we are providing as a legacy, which will serve, I guess, for the next project. And something that we also have pushed a lot is to create a conference. So together with other projects, but we are co-organizing for the first time this year the EEAI conference, the European Conference on AI, on Edge AI. And this will happen this year again in October. Date still to be found because we are now negotiating the place, but it will continue. So it's actually organized by DI Edge and other projects. And it created such a momentum that I think this conference will continue, probably financed by other means, by other projects, but there will be projects that will have an interest of continuing this activity. So I think that the community will stay.
Okay, Dimitris?
May I add? I think the main responsibility of all the NOEs is to keep the talent here in Europe. That's the main responsibility, and which means that one way or another, they have to keep this talent that was trained during this period of some 4, 5, 6 years, to keep them in Europe and to be actually the ones that will work on the big AI projects. If it will continue without funding, I'm not sure, but I'm sure it will continue in terms of smaller groups. This is what happened in the past also.
Cecile? It's working?
Collaboration, yeah, of course. Yeah, I think what you build in the networks, I mean, maybe in the longer term, the individual thing might, when people leave, that will decrease. But you created between labs some important links when you created those joint supervised PhD or collaboration with industry. That's something we pushed a bit, pushing you beyond your maybe a zone of comfort. But at the end, this is something that will last because the network between the people, the professor, the student might leave to the next place. But between the labs themselves, between the teams, that this is something that will last hopefully for at least sufficient amount of time so that the next generation and the next wave of project, be it raise, be it another type of project, will be there to support whatever means. And then whatever means, it's in your hands, it's in our hands, but we need you to help us defining what's best for the community, I would say.
Okay, following on the inputs that Old gave, I have a question for Dimitrios. Considering the experience that you have in bridging, now you come from research, now you're more lean to industry. How important are networks and synergies between research and industrial institutions for AI research and adoption? What can a strong collaboration between these spheres produce that neither side could do realistically achieve working alone?
Yes, I think the example I gave with Titan is a success story because we started collaborating on, I would say, typical digital transformation stuff, creating data lakes, some kind of prediction algorithms and things like that. And then we together worked on how to use best the recent advances in AI, on agentic AI, and to create something where this company from a very traditional area of business, which is cement, to become one of the pioneers now in worldwide in terms of digital transformation strategy and AI adoption.
Okay. Now perhaps to Cecile and then for the coordinators of the networks. The AI continent plan is clearly a big strategic step towards the European ambition, with which the focus is now shifting a little bit towards compute, infrastructure, industrial deployment. Is there a space in the plan for fundamental research?
Definitely. In this 5 pillar, there is one about algorithmic development. And even if it's not explicitly mentioned in the 5 headlines, this is about development of the technology. We don't want to have apply AI, the adoption of only non-European technology. Sovereignty, we hear it more and more. It's more and more important, especially in the context we live in today. We need to master this technology. It's coming in all our industry and in our private life as well. We cannot afford just to be a customer of a technology we cannot master. And from day one to the next, they can be cut. So we really need to have to master the technology. So this algorithmic development is part then of apply AI. And in apply AI, it does not mean only applying any technology. We want to also develop solution for this vertical sector and not only deploy, but develop and deploy. And then we also publish the Apply AI together with AI in Science, which contains race and which contains in Apply AI, we also have the Frontier AI initiative. So it means that we want to continue. This is one of our strengths also in Europe, is the research, the scientific excellence we have, so that we cannot forget that is part of the ecosystem. It needs to be there, but we need to reinforce the link with the adoption, and we see very nice example. So we have to enrich that part a bit more, strengthen a bit that part, being more visible, because I think we are very good, but maybe we should sell us a bit more and not oversell, but just sell what we have. And but there is space, definitely. And but we need you to make it happen.
Okay. Now a question for Alain and Georgios. If you had the power to redesign the next generation of collaborative research funding, what is the one thing that you would keep from the network of excellence model? And what is the one thing that you would change completely? And the amount of funding, it's not a possible answer in this case, okay?
Well, from my side, I want to recognize that one of the things that make things possible is the openness on which the design of the project has been made. So it's a project that doesn't have a specific system to build, a specific goal. It's a project that invites a wide scope of researchers and industry players around Europe to collaborate on this broad field of AI. This enabled us to have a very fruitful and effective collaboration between us. Everybody was happy because everybody did what they wanted. And this allowed us to create the network, to form the network, to strengthen the network. So this openness and flexibility provided by the framework allowed us to build the networks we built. Regarding what I would change, I cannot get more money, but I can get more time. So I would ask for at least 1 more year more, because such networks take time to be built, take time to induce trust between the partners. So we are in almost the third year. We're finishing the third year now. Now we feel it among us that we are a network that we trust each other, that we can work together. So having a bit more time would be beneficial.
Okay. And you, Ella?
Yeah, I think I'm joining a little bit George's about the things I would keep, maybe framing it a little bit differently. I think that the community building aspect was actually written in the code in some subtle ways, but if you wanted to win, you had to plan for actions that would create a community. And so we had to plan for making workshops, for disseminating a lot, for getting stakeholders engaged. The FSTP instrument was excellent in attracting external stakeholders joining us in the effort. So I think this community building aspect is definitely something that was well designed, and in similar calls we should have the same thing. For things I would like to change, maybe it's just maybe more incentives also to go more towards the creation of specific deployable assets at the end, or marketable assets. So this is of course in every call asked for, but given the time frame, it's very difficult to do at the same time excellent research, fundamental research, and try to have at the end of the project things that you could actually deploy and commercialize day one after the project ends. So maybe it was not the aim of the network of excellence generally, but typically it's a research and innovation action, and it contains innovation. So we are supposed also to foster innovation, and maybe having something that would more guarantee more outputs in that direction.
Okay, thank you. Now I open the questions in the audience, 2 to 3 questions. So anyone has a question? We have one in the back of the auditorium, Mohammed. Sorry, you have to run a little bit. And then we have one in the center.
Hello, good afternoon. Thank you for all the panelists to be here today. So my question is regarding to what we're seeing now with Fable being released, or being retracted and then re-released and then retracted. How do you feel about European positioning towards AI research and research becoming more automated or steered by the researcher when we do not really participate in the game?
I mean, that's why we are, we are launching new project on Frontier AI, and this is also why we launched. I mean, in January 24, we launched in 1 month a communication, which in the commission time is usually 1 year to draft a communication. We planned it we published it in 1 month, and it was to put Europe on generative AI landscape in the world, and then we have funded a number of projects. So we are doing our best to fund. I know we are not at the scale of the investment we see out there. But one thing I always repeat is that the EU funding, the public funding we provide is only the glue to build on all what you have in your labs and all what's happening in Europe. So we build on excellence that exists there, and we add a layer which hopefully is the glue between you and makes it more than the sum of the parts. So we hope that with this effort and the new dimension now where compute is so much more important, data is, these are the other elements which come into the overall, let's say, strategy. So we're trying our best to bring our piece in the whole building.
You want to add something at Georgios?
Yeah, maybe just one comment, because I think that the comment was a little bit of criticism that the AI development is not triggered by the researchers themselves, and I kind of respectfully disagree because typically this type of projects, the NOEs, they contain also a deliverable which is a strategic research agenda, where the community is asked to provide inputs on what we see as important directions for the development of AI. So I think this, at least this type of instruments, is the right one for having researchers having their say in the planning.
Okay.
Yeah. Sorry. Thank you for the nice presentation and a nice panel, which is insightful. To me, the network of excellence, they have to sustain in one way or another. When we talk about sustainability, it's not only funding. It is how the results achieved through this network, how they are maintained and updated. And this requires the instillment of this into the institutions which are involved there, how they can maintain. For this, for example, to have an ecosystem of this network of excellence, it has to coordinate this even with minimal funding. One, trying to get incentive from the industries who were involved from all these centers. There must be somehow they have benefited from this research and incentivize this funding from the industry as well as from other funding agencies. But first, there must be a clear business plan which instills these network ecosystems to a minimum working platform to maintain first the results achieved by these networks. That is important. If those results are not maintained and updated, and there is no point of talking about sustainability, because they have achieved about 4 or 5 years work, and then what do we do with those achieved results? So for me, what I will suggest is that this ecosystem of networks need to be built with trust, with the industry backing, not only funding agencies. The industry need to fund these ecosystems because they will benefit from the result of the sustainability. So my question is, have you tried to build these ecosystems of network of excellence?
So thank you for the very, very good comment. About the sustainability of results, I have to say that there is at least a try, is the AI on demand platform. So the AI on demand platform has been started in the AI for EU initiative, and it's still running. And I think there are new projects called Deploy AI that are actually maintaining the platform. And the mission of that platform is exactly that, to collect the results of EU projects and beyond, and make it available for the stakeholders generally. So, now, of course, we can debate a long time about the efficiency, but at least the will is there. And for the second part, I think your idea or your comment on making the industrial partners kind of invest in the sustainability is an excellent idea. But I don't know exactly how to incentivize it, because I agree that they benefited from the funding and they could evolve. But how can you contractually make sure that they will invest to give back a little bit what they received? That I am not the best in position to answer that.
Can I jump in?
Yes, but I would also like the perspective of Dimitris, how to convince industry to bring money to the table.
Yes, I have a different perspective.
Okay.
Okay. So for me, the big question in Europe is why does the industry takes the risk to not take the risk of investment? Because this is a big risk at this point for the European industries. To not take the risk of investment in AI. For the future of NOEs, for example, the research agenda you created, the others, AI for media created. Why don't you try to sell it to the industrial domain you are targeting? And let's see if they buy it and what they buy it. And probably the European Commission could contribute in their support partially. So this in Greece we have a very simple thing. They call it Innovation for Society Awards, and some companies in North Greece. This year they are 14 companies. They came with challenges and they asked for contribution, and then they have to have a contract with the ones that provided the solution. This is in a very small scale. You could do this in a very large scale. You have the money to do it.
Okay.
We are actually, and it's a good point, the AI on demand was the tool to support it, and we want also in the later run to have it sustainable. That's why there is also an industrial part that could maintain it and hopefully then continue serving also the research community. So that's the goal. Let's hope we manage it. We are actually launching competitions as well, and the goal is to create ecosystems. So we give money to industry that have problems, challenges that can be solved by AI, and then they will redistribute the money to in this specific call is more targeted to startup and SMEs that will compete to develop the solution. And then it's a stage way. In the first wave, a first prototype, each of them will receive 250K to develop the prototype, but the 4 best ones are going to receive 2 million to develop the solution. And the goal is not necessarily to give money, it's to create this ecosystem, because all of them will benefit to be exposed to the companies and in the industry. But we can think about other mechanisms to make those results surviving after the project, of course.
Okay, final question from the second row before we conclude the session.
Thank you so much for the panel. I really enjoyed all the points. And actually, I have significantly more questions, but I will try to reduce to 2. But you answer one, just pick one that you prefer more. And I'm Anastasia Nikiforova, Head of Information Systems Research Group from University of Tartu. So my first question would be around Regulation in AI Act, because you have mentioned today that actually there is a bit of the tension, that it is a popular opinion that Regulation in AI Act in particular is killing innovation in Europe. I'm definitely not in support with this claim. And as far as I understand, we are here all the cellmates. And one of the initiatives that European Commission is making in order to facilitate AI Act adoption and enforcement was an establishment of this recent advisory board and also AI expert panel, if I'm not mistaken. Yeah, it is funny that I don't remember because I'm one of experts. But yeah, the point is that in a bit more than 1 week, we are starting to work, and I would like to really use it as a bit of this ideation task now. So what would be your message to us? So what should we force? What should we push so that not only we as an experts are making those decisions and are making some changes, because actually 60 experts and it is only 1 expert per country, meaning that actually spans even beyond Europe, including US, whose beliefs are significantly different from ours, from European Union. So what would be your message? It is the first question, whereas if you don't like it, there is another question with regards to this sovereignty, because it is indeed the topic that actually follows us and pops up more and more frequently, be it digital sovereignty or AI sovereignty in particular. So at the beginning of today, whereas in the different contexts, but we have also mentioned that actually oftentimes it is due to the lack of clarity on the underlying concepts, we are not making expected progress. And I do see from one time to another when we are discussing the sovereignty issues or sovereignty questions, so not to make it as an issue in a negative connotation, that actually there is still no agreement on the very definition, because the quote which has been provided by Ursula von der Leyen, for instance, even it differs from what we can see from in European Commission documents. And I was also lucky enough to participate in expert panel on this, and policy brief of ours will follow up later this year. So I'm wondering, do you believe really that it is some people are posing this and pushing that it is all or nothing? So either we are producing everything ourselves or we are non-sovereign? Or rather, do you believe that it is rather a continuum and we can find a bit of more feasible solution where we can still consume and use those technologies, but rather we are in control of the things surrounding it in a systems thinking? Thank you.
Okay, I'm not from the AI Act team, but I would say what we are asking to experts is to bring reality in the game. So you as an expert, we are asking the expert to contribute in helping to make this implementation as pragmatic as possible and realistic as possible. So that's my own view on this exercise. And because you know the field and as an expert and because you know the reality out there. So you are supposed to reflect what is good for Europe in terms of innovation, the right balance between innovation and making sure that our values are respected. And now on the sovereignty, again, I would take a pragmatic approach because, you know, in the Commission, we are not expert as you are in the field. So you know what is best. And we are not going to be in control of the full stack in one day. We need, again, to have a pragmatic approach. Where does it make sense to control some of the part? And then let's progress on the different part where we can, but let's not just try to swallow everything at once and not being able to bite any of it. So I would also promote a pragmatic approach and say where there is a chance that we gradually build our strength.
Okay, just to conclude, and because tomorrow we also have sessions on sovereignty, I would ask for each one of the remaining panelists one sentence as a recommendation for Anastasia to take to the expert forum. Okay, Alain?
I'm also not an expert on the legal side and sovereignty, but my take on sovereignty is that we need to better advertise the benefits of sovereignty so the end user is aware of the necessity of having it. Because if we don't have the end user, European end user, willing to have sovereign solutions, they will just go on the free market and choose something coming from another continent. And so maybe this is what we should do, is make more awareness about the necessity of sovereignty.
Okay, Georges?
For sovereignty, I would say that we have been failing with that even before AI. We have been using Google search for everything in our life before 2022. And this comes back to the awareness comment by Alain. We have to understand where we stand and we have to understand what we want to do. So day by day, end users have to understand what they're sacrificing by using a search engine, an AI model, whatever it is. Of course, we cannot go and fix everything in one night, but step by step, component by component in this stack, we can make things better.
Okay.
Regarding the...
So, Dimitris, one sentence, sorry. You have to use your time, sorry. You'll have time to talk after.
I mostly agree with the other speakers, but I think we should give freedom to the user because this is what will happen at the end. So let's give freedom to the user and try to put some restrictions on various levels. This could be an approach, and the user should have the option to decide on these various levels. Because I completely agree with Cecile. If we try to impose all the restrictions together, then we are not competitive. So let's give the freedom to the user, and if they want to lose their data, they want to lose their money, why not? Let them lose them. Of course, that's what I said. So There should be various levels, and there should be clear explanation of what happens if they decide this. Because if they go with the American and the Chinese solution, they will have it as default.
Okay.
Make them aware that we have strengths in Europe and
Yeah. So I think the takeaway message is create awareness and let us know how to sell better what we are able to do in AI research. Thank you so much for the panel. Apologies for not having more time, but thank you for having us here.
Thank you for the panel, and as a co-chair of this conference, I'd like to thank you for all your participation and perseverance. And don't forget that tomorrow we shall still have another day. And I call your attention to the Marble Gallery, where you have lots of short 2-3 minute videos about the results that ENFIELD has reached, and actually 2 live demonstrations of the portal and the strategic framework. So thank you again.